Hello, and welcome to a special episode today where James and I, rather than us kind of commentating as we usually do over videos, we've got a couple of guests, Phil from the SkyDivePhil YouTube channel and Daniel. Do you both want to introduce yourselves and what it is that you guys do?
Sure. So I have a YouTube channel called SkyDivePhil. I had that name, but I didn't know what I was going to do with the YouTube channel. So it's got nothing to do with that. I mostly do films with cosmologists. I've got a series called Before the Big Bang, and I've interviewed all the leading people in the field: Stephen Hawking, Roger Penrose, Alan Guth, Alex Valenkin, blah 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 blah, about models of the early universe. So that's my sort of speciality. And obviously, we've done this film about the Kalam because it's very, very obvious when you talk to these people that they don't support the Kalam, even though they've been quoted as supporting it.
And yourself, Daniel?
I'm a PhD student in philosophy. I specialize on my specialization is in philosophy of science, in particular philosophy of physics, and in philosophy of religion. I work on the Kalam argument for my dissertation, and I have 3 publications on the Kalam argument, with another currently about to be published, hopefully.
So the kind of context for today's video then is the documentary that you made on your channel, Phil, which includes several sort of well-known philosophers, cosmologists and so forth, taking a look at Craig's Kalam argument. William Lane Craig has produced a response to that documentary, and so we're going to be looking at some of his claims and kind of talking about them. But before we get into those videos, Craig's response specifically, what are your sort of initial impressions from what you've seen of how Craig's kind of engaged with the documentary?
Well, what can I say? He's wrong. There are a lot of times where he just ignores what we said. That's disappointing. And also, he doesn't really engage with the scientific content very much, I think. He'll be like, just refer to my Blackwell Companion article. He does that a fair few times. And I don't think that article is very good. But, I guess we'll get into the details when we go through it bit by bit.
Okay, no problem. Unless you want to say something, James, or you, Daniel, before we go into the first sort of timestamps of the video?
Yeah, I mean, I guess I'll just offer my reaction. My general reaction is one of the participants in the video. I mean, I'm in there for like all of 20 seconds, but one of the things that's just sort of really peculiar about Craig's response is that he says something to the effect of that he's not going to be able to respond to every point raised in the video, but then he at the same time just ignores the fact, and I mean, that's fair enough, right? Like, I mean, any video on YouTube or any piece of writing or anything in philosophy or science or whatever is always finite, so you can never like respond to every possible objection. But then he just simply ignores the fact that, well, likewise, Phil's video can't possibly cover everything too, and many of the people who are contributors to Phil's film, like myself, have written a lot on this topic. The 2 co-authored papers that Craig wrote with Sinclair, those were the papers that I spent most of the bulk of my papers responding to. But Craig has simply ignored the fact that those papers exist. Likewise, I mean, if you look at he's, there's almost no evidence that he's even read Alex Malpass's papers, or and so it's it's just sort of strange that there's this sort of double standard where it's like, well, it's not, it's okay for him not to respond to everything, but apparently not okay for other people. It just
I think the notion of double standard is a real thing. Like, just for example, he criticized us for saying we're not being objective. We're not objectively investigating whether the universe had a beginning. This film was intended to be a response to Craig's videos, which promote the Kalam, and this is a video criticizing the Kalam. So if he can make a film promoting and defending the Kalam, why can't we make a film responding? It's just a ludicrous double standard, quite frankly.
Yeah,
he's not being objective in his film.
I loved that little bit at the end. I guess we'll get to that. But
Yeah.
when he accused you guys of being polemical, I'm like, really, Craig? You're going to accuse people of being polemical?
Yeah, unless you can tear down all of his points and erect arguments in their place, then the conclusion follows still logically and inescapably. Well, with that being said, then we will get into the first video. So I think the first video focuses mostly on infinity, and we might skip around through a few bits that aren't as kind of pertinent to the commentary. That
are great scholars.
Let me know if it's too fast, by the way, for you guys to hear. I've got it on 1.5 speed.
Produced this video are popularizers. And when they misrepresent the Kalam argument to these scholars, then the inevitable result will be criticisms aimed at a straw man. And that greatly diminishes the value of this video. As for the scientific material in the video, there's really nothing new here. It's just a rehash of old material that James Sinclair and I have already responded to in our published work. So the video really fails to advance the discussion. So in the end,
I love it when Craig talks
somewhat
about a rehash of old material in a derogatory way, as if he hasn't been making essentially the same arguments for 30 years.
Right.
It's
Right.
it's just a bit rich. Like,
Yeah, I mean, like, suppose we had nothing new. I mean, there's nothing new in his videos to promote the Kalam. But there is stuff that's just a false accusation. For example, we had a guy talking about entropy. That's not, he hasn't discussed that. We had a model of the universe called periodic time cosmology. He's never referred to that. That's not in the, his articles with Sinclair. And the other thing that he said, we misrepresented the Kalam. So the people in the video, Alex Malpass knows the Kalam pretty well. You know, he's published articles in the leading journals. But then we had Adrian Moore, who is the editor of Mind. You know, and I had lunch with him. He knows Craig's work very, very well. Another philosopher is, well, a logician, brilliant logician, Daniel Isaacson. Now here, I don't know what his familiarity was with the Kalam before we contacted him. But this is the interesting point. It's so ironic. We sent him Craig's videos on the Kalam. We said, this is what we want to respond to. Now, if we misrepresented it, how did we misrepresent it? By sending him Craig's videos. So he's only got himself to blame, hasn't he?
I'd also point out that, you know, I'm in the video for a very short amount of time, you know, like all of 20 seconds or so, but it's, I mean, I know the Kalam quite well, and I've read everything that Craig has written on this topic. So it's difficult to imagine that, I mean, I guess maybe what he's referring to is, some of the physicists that appear in the video that are not themselves philosophers, and so are not, but I mean, but they're talking about physics, not philosophy. So
I should add that all of those physicists, well, everyone in the film, everyone living in the film, obviously Hawking died, so he couldn't review it, was sent a copy of the film, and were given several weeks before we put it out, saying, if you object, if we think you've misquoted, we can cut you out, we can change it. Does Craig do that with anyone that he quotes? I very much doubt it.
Yeah, and I think it's probably it's unfair for a couple of reasons to say that it doesn't advance the discussion, because I think, you know, Malpass and Morriston, the stuff that they've had to do over the past couple of years, at least philosophically, that's new as far as I'm aware. And I guess you could say maybe at the academic level it doesn't advance the discussion, but I think that this is the most sort of comprehensive look at the Kalam that there is out there. In the, you know, like in the public space, in terms of getting the relevant experts to speak on each particular part of it. I don't think that Craig has attempted to do that himself. So I think in terms of public communication, it's advancing the conversation a little bit.
Right. I mean, this is a YouTube video. It's not supposed to be an academic paper.
less impressive than it at first appears.
Well, due to the experts featured in this video, Bill, and its popularity, it's up to around 52,000 views at this recording. We thought we would take the next several podcasts and give you a chance to respond. Now, the video falls naturally into 4 sections. The first section is on the first philosophical argument. The segment is on a few representative clips and
covering exactly those 4 segments that you just mentioned. So it will not only be in video and audio on this podcast, but we'll have it also
all over social media, all over the internet. So here's how it begins.
Let's start at the beginning. Philosophers like Craig have argued that the past must be finite.
If the universe never began to exist, that means that the number of past events in the history of the universe is infinite. But mathematicians recognize that the existence of an actually infinite number of things leads to self-contradictions. My studied position is that the existence.
And note, like, something to really keep in mind here is that he does say the word contradictions as well.
Yeah.
You know,
But it's not just contradictions. It's also this phrase mathematicians recognize.
Right.
Now, we've been accused of misrepresenting him and saying, no. He's not saying that there's a mathematical contradiction. He's saying that it's metaphysically inferred. But the problem is what's metaphysically possible or not is not a subject for mathematicians, right? So if mathematicians recognize it, he's implying to his audience that this is a subject for mathematics. He's implying a mathematical contradiction by using that phrase, mathematicians recognize. That mathematicians recognize no such thing.
Notice too what he says is that his studied position is such and such. Well, great, but that what he means when he says that, I think, is that he offers a different position in his peer-reviewed work. That's your point, right? Your point is that he says one thing to public audiences and another to academic audiences.
Yeah.
This just seems to be, I mean, I don't want to accuse another academic of like malfeasance or something, but it just seems that this is he is stating in other terms exactly your claim, and yet somehow claiming that your claim is incorrect. And it's like, no, this is just an outright statement that you're exactly right. That is what he does.
Right. I mean, we're accusing him of saying A and not A. And he can't defend himself by saying, oh, but look at the times I said not A. But that doesn't help you. You still said A elsewhere.
Right.
The existence of an actually infinite number of things is metaphysically impossible, whether or not it's strictly logically impossible. Now, this position requires us to understand the distinction between broad logical possibility and impossibility and strict logical possibility and impossibility. Something is strictly logically impossible if it involves a contradiction. But philosophers have come to recognize that there's a wide range of things which are plausibly metaphysically impossible, even though they are strictly logically consistent. To give a few examples, gold has the atomic number 3. Now, that statement doesn't involve any strict logical contradiction, but surely it's metaphysically impossible. If gold had the atomic number 3, it would be a different element. It wouldn't be gold. Or here's another one. This desk could have been made of ice. Now, certainly we can imagine an ice desk that is in the same shape and size as my wooden desk, but it wouldn't be this desk. It seems that it's metaphysically necessary that this desk could not have been made of ice. Or here's another example. Something has a size, but not a shape. There's no strict logical inconsistency in that, and yet surely it's metaphysically necessary that anything that has a size has a shape. Or another example, something.
So, I think what he has in mind is something like this view from Kripke that when we discovered that water is H2O, we discovered what water essentially is. So we discovered that whenever you use the word water, you are effectively also referring to H2O, so that you couldn't have a possible world in which there was water without having H2O in that world. That's what we call an a posteriori analytic truth. Analytic truths are truths that are true in virtue of their meaning. The statement that water is H2O is true in virtue of its meaning, but we discovered that empirically. What's important is that in those, like if you said that water is not H2O, you would be contradicting yourself. You know that you're contradicting yourself after you discover what water is. Or in other words, I mean, the statement doesn't have the logical form of a contradiction. It's not the form P and not P, but it entails a contradiction once you understand what the nature of water is. The same is not true for most of the examples, or really any of the examples that Craig gives for like actual infinite collections, right? Like in the Hilbert Hotel example, it's not that there's some a posteriori necessity that, like, it's not as though once you learn the meaning of the terms actual infinite that you are expressing something that turns out to entail a contradiction when you say that there are actually infinite collections. So like this just seems like the argument here doesn't really seem to work. But anyway, you can.
Yeah, the only thing I was going to comment on that is that Craig's reasoning rather seems to be, well, there's these sort of strange consequences that it's perhaps difficult to conceptualize, which is a different thing than you're contradicting yourself in terms of the meanings that you use it.
Yeah, no, that's exactly right. And one of the things that I like to point out is that metaphysical possibility is a very low bar, right? I mean, metaphysicians imagine all kinds of things as being, the possible denizens of possible worlds. There's presumably a possible world where there's a galaxy-sized elephant that sings the Star-Spangled Banner. But, the fact that we can construct the fact that that example is absurd doesn't tell us anything about its metaphysical impossibility. The only cases in which we have a metaphysical possibility but are not in the form of a contradiction, there's two cases I can think of like that. One is where you have a statement that entails a contradiction but is not itself in the form of a contradiction. The other is a case where perhaps there's some metaphysically necessary principle, and then it turns out that that the scenario you've dreamt up violates that principle. So for instance, one example that philosophers like to appeal to when talking about metaphysical impossibilities is that it's supposed to be metaphysically impossible for one and the same object to be red all over and green all over. I'm not sure if that example really works, but supposing that it is, the only reason it's metaphysically impossible is because it violates some principle about that, objects need to have only one color all over them. They can't have two colors everywhere on the same surface. The examples Hilbert's Hotel may be absurd in some sense, but they're not absurd in those senses.
Well, God's existence is something that's thought to be either metaphysically necessary or metaphysically impossible. So,
But
I mean,
notice
that's sort of another example.
Yeah, but that's because, in Anselm's argument, for example, it's because of the meaning of the term God, right? It's like once you conceive of God properly, you come to realize that that sort of thing has to necessarily exist, and so it's similar to the if Anselm is right, then what it means is then part of what that means is that the sentence "God does not exist" turns out to entail a contradiction. So that was in fact one of the cases that I offered.
I think the bottom line is none of these. It's just not analogous to the cases that Craig was claiming. So it's just wrong to use this sort of thing. It's just not analogous.
Right.
Can come into being from nothing. There's no strict logical contradiction in asserting that, but I would say that if anything is metaphysically impossible, it's surely that.
Well, hang on,
here's my favorite example.
So he gives this example of a metaphysical impossibility, that something can't come from nothing. Why is that a metaphysical impossibility? But if I just modify the statement of saying a being can't create something from nothing, that's not metaphysically impossible according to Craig. But a philosopher like Philippe Leon saying it is metaphysically impossible. There doesn't seem to be a way to adjudicate these things. If we think that a being can't create something from nothing, then the Kalam is going to fall over, right? I mean, certainly, or at least Craig's version of it is. So that's, I think, shows you the tenuous nature of it, what he's presenting as metaphysically impossible.
Right. So there's at least two things to be said here. One is that there are many philosophers who have thought that everything needs both, or the beginning of any entity needs both material and an efficient cause, and not just an efficient cause. But the other thing to be pointed out is that if you deny Craig's causal principle, if you deny that the beginning of any given object requires a cause, that does not thereby deny the principle sufficient reason. You can think that there's a sufficient reason for something beginning to exist, even though that reason's not a causal reason. And this somehow gets lost in every time that Craig gives a defense of his causal principle. That he acts as though, or sometimes he argues as though, denying the causal principle would mean that things can just pop into existence randomly or something. But you could be a really strict necessitarian and think that anything that begins to exist that its beginning to exist is completely is necessitated, without thinking that it's causally necessitated.
I think Phil's sort of point about it being very difficult to kind of adjudicate between when two people have different intuitions on metaphysical possibility, and I think that's an important point that's also going to kind of come up in Craig's defense of the Kalam as well, where it does essentially come down to whether you kind of share the same intuitions as Craig or not. And then if you don't, there aren't further reasons that can be provided. And now you could say, a lot of different kind of worldviews are going to be like that. But then, is it a good argument? Should it convince someone who doesn't share those intuitions? I don't know.
From Alvin Plantinga, the prime minister is a prime number. That is clearly metaphysically impossible, and yet there's no strict logical contradiction in that. So none of these things is strictly logically impossible, and nevertheless, plausibly, they are metaphysically impossible. Some metaphysical impossibilities are also strictly logically impossible, but not all of them. And my focus in the Kalam argument is on situations that are metaphysically impossible, even if they're not strictly logically impossible. Things like a Hilbert's hotel with an actually infinite number of rooms, or Bernadette's book with an actually infinite number of pages. Now, if any of our viewers or listeners are interested in illustrations involving strict logical impossibilities, I want to recommend Alexander Prusa's recent illustration. Let me just mention one of these that is very graphic and very accessible, the so-called Grim Reaper paradox. It goes like this. Imagine that you're alive at midnight, but there is a Grim Reaper who will cut you down at 1 o'clock if you're still alive then. But there's a second Grim Reaper who will cut you down at 12:30 if you're still alive then. But then there's a third Grim Reaper who will cut you down at 12:15 if you're alive then, and so on ad infinitum. The result of this is that it is logically impossible for you to live past midnight, and yet you cannot be killed.
We shall see contemporary.
I'm not sure if you guys want to comment on the Grim Reaper stuff or.
I want to say something about that. Let me just grab here we go. So I think there's a sort of mistake that happens in many of Craig's arguments, and we can dream up all sorts of thought experiments that turn out to imply a contradiction. That doesn't mean that every single thing that goes into them is problematic. So, if we imagine this is a silly example. If we imagine that the Grim Reaper is purple in color, that doesn't mean, the fact that the Grim Reaper scenario is impossible doesn't show us that purple things are impossible. Anytime that you have one of these thought experiments that you've dreamt up, there's going to be some set of assumptions that go into constructing that thought experiment. So we can imagine some conjunction of claims like P and Q and R and whatever. And so what you show when you show that conjunction is impossible, so you show not possibly P and Q and whatever. Well, in modal logic, you'd have the negation, and then diamond means possibly, and then that conjunction. You can take that negation, you can bring it inside of the possibility operator. That makes your possibility operator makes diamond into box, into the necessity operator. And so you say not so then the claim not possibly P and Q, for example, becomes necessarily not P and Q. If you now use De Morgan's law, that statement becomes necessarily not P or not Q. So what thought experiments like this actually show is that there's no possible world where all of the conjuncts are satisfied. Now there's two conjuncts that go into examples like the Grim Reaper thought experiment and other thought experiments that are similar. And these two principles can be shown to entail a contradiction. So one that I'm going to call P is that the set S has no first member. And then the other is what I'm going to call a statement Q. It says that for all X in some set S, E at X, if and only if E nowhere before X. And it turns out that there's no possible world in which you can satisfy both of those two statements at the same time because they jointly entail a contradiction. What you can't then do is to say that it's the fault of P, right? It would actually be a fallacy in modal logic to infer necessarily not P from necessarily not P or not Q. That's called the unsatisfiable pair diagnosis. There's two papers. One is by Shackle, or is out there in the literature, and the other is by Malpass, and it's forthcoming at Eric Hetness. And I think that they do a really good job at hammering this point home that, and this is what's wrong with the Grim Reaper thought experiment, but I think that something very analogous is actually going on in Hilbert's Hotel if we suppose that Hilbert's Hotel is metaphysically impossible. All the absurdities that are generated in Hilbert's Hotel if those do show you that it's metaphysically impossible, all that would show you is that there's a certain kind of infinite collection that you couldn't have. It wouldn't show you that you couldn't have infinite collections more generally.
Yeah, I think that's a really clear way of explaining the problem with Craig's presentation of the argument there as well. So thanks for that.
Yeah, also, Craig doesn't really appeal to the Grim Reaper paradox in his own writings. I think he actually gives the Grim Reaper paradox as an argument for why time can't have the structure of the real numbers, because then it would entail that you could have this sort of series of Grim Reapers appearing earlier and earlier and earlier.
There are people who say things like that, but I don't think Craig says that. So
yeah, he does. He
Craig's-
argues this in, I think, one of his books on philosophy of time.
Well, so Craig's view about the structure of time is that time is a kind of Aristotelian continuum. So his view about time is that for any interval of time, for every subinterval, that subinterval has subintervals. So you can never get down to instants or points. He argues that in a variety of different places, but and it's a quite difficult view to make sense of because it's quite difficult to square with his presentism, right? So he says, for instance, that there are no instants because every subinterval has subintervals. An instant would be a subinterval without subintervals. This is also called the Gunky view of time, but or the Gunky view of continua. If you took up the view that time had a kind of discrete structure, that would be to deny the Gunky view. It would be to say that there are subintervals that do not themselves have subintervals.
So actually, Dan, I'm going to ask you a question. If we have discrete time, then what happens to the Grim Reaper paradox?
So a lot of people that defend the Grim Reaper paradox do think that time is discrete. They think that there's a version of the Grim Reaper paradox that shows that time is discrete. It's because you can, so one way to construct the Grim Reaper thought experiment is with an infinite past duration. But another way to construct the Grim Reaper thought experiment is just to construct an infinite number of Reapers over the past, say, hour. And that people take to show, or some authors have taken that to show that the time must have a discrete structure.
Right, but if we say time has a discrete structure, can we then say that it's not the infinity it's not the existence of infinity that's the problem, it's the existence of a continuous structure of time.
Suppose that there were, suppose the time were discrete. Let's call the discrete increments of time chronons. The view that there's infinite past time is the view that there's an infinity of past chronons, and there could be a Grim Reaper that acts at every chronon, and so the thought experiment would then it would then purport to show that the number of past chronons would have to be finite, and that's so then the total duration of past time, according to that argument, would have to be fine. I mean, that's like Rob Koons's view, for example.
Was there anything else you want to say on that point, James, or should we move on with the video?
Well, I was just emphasizing that I'm not really sure what the Grim Reaper paradox gets Craig, but we can move on.
Yeah, I suppose so maybe the idea is that the documentary is responding to Craig's argument as he's formulated it and put it forward. And so if he's saying, here's a bunch of other arguments that have come along now from different, if after the fact, I thought, well, yeah, okay, maybe they are there, right? And maybe they're good arguments, but it's unfair to say, why isn't the documentary engaging with those? Because the documentary is engaging with your work specifically.
Yes, and coming back to the point, so this was in response to Craig's claim, or the clip that was played about Craig talking about mathematicians coming to view infinity as self-contradictory, or whatever the exact phrase that he
did
used
say
was.
Contradictory, yeah.
Yeah, and Craig really didn't have anything to say in response to that. He just started talking about the difference between metaphysical and logical contradictions or impossibilities, and that doesn't really address the point as to why sometimes he talks about time as if it's why he talks about infinities as if they're logically contradictory, and other times he doesn't say that.
Contemporary mathematicians do not think infinity is contradictory, although it's true that philosophers of the past were troubled by it. But even they did not banish the concept. For example, Aristotle distinguished between different types of infinity.
The distinction that he was drawing was between an infinity that's present all at once, all at some particular point in time, which is what he meant by an actual infinity, contrasted with an infinity that is spread out over time, which is what he called a potential infinity. So, for example, if space were infinitely big, that would be an example of an actual infinity because the whole of space is there at any given point in time. On the other hand, if you imagine a clock endlessly ticking, the ticks might go on forever, but if they did, that would be an example of a potential infinity.
Well, it's a privilege to be interacting with Professor Moore. I have learned a great deal from him. One of the books in my personal library is his book, The Infinite, which I heartily recommend to anyone who's interested in the fascinating history of this challenging concept. Unfortunately, here, the narrator of the video begins to lead things off track. She says, contemporary mathematicians do not think infinity is contradictory. But neither do I. I'm not claiming that the concept of the actual infinite is an inconsistent concept. Rather, I'm claiming that the instantiation of an actual...
Well, he is making that. He does make that claim. You can just watch a video and hear him make
Yeah,
that
I was
claim.
going to
And then
just play
also,
that.
not only did he make the claim, but he repeated the claim. So if you watch his video, Philosophical Arguments for the Kalam, the sort of short video they made, they also say it's a contradiction. So if he maybe once is a slip of the tongue, but he repeatedly makes this claim.
I was just going to briefly.
If the universe never began to exist, that means that the number of past events in the history of the universe is infinite. But mathematicians recognize that the existence of an actually infinite number of things leads to self-contradictions.
I mean, actually, this reminds me of when we had a conflict with him with the animal suffering issue. So maybe people don't know this because it was a long time ago. But he made the claim that animals don't suffer. So
Well, they do. They suffer, but they're not aware of their suffering, I think, is what he says.
Well, yeah, but it's a question of in a moral. I was going to say, don't suffer in a morally significant way. That's really the claim that's important, because he laid, elsewhere he said, well, God has shielded animals from the suffering, and that's a sign of his great mercy and goodness. And then he said, well, I didn't say they didn't suffer. They're just not aware of their suffering. But it really amounts to the same thing, because if you don't have what's called pain affect, the emotional response to pain, then we're adding up to the same thing. Otherwise, the argument won't work. You've got to look at it in context. He was responding to Stephen Law, saying there can't be an all-powerful good God because look at all the animal suffering in the world. And then he responded saying, well, animals don't suffer in the same way that we do. And it's really the same thing. He's making a claim and also trying to use the authority of academics to bolster his claim. That's why he's using this phrase, I believe, that he's using this phrase that mathematicians recognize, because it sounds like it's got enormous weight. I've got the whole world of academia at my side, and then when he's challenged on it, he goes, oh, I never said that. Well, you did.
Yeah.
Do not think infinity is contradictory, but neither do I. I'm not claiming that the concept of the actual infinite is an inconsistent concept. Rather, I'm claiming that the instantiation of an actual infinite in reality is metaphysically impossible. So I follow Aristotle in thinking that only potential infinites can exist in reality, in contrast to actual
I just stopped there a second. Yeah. I mean, Aristotle's definition of potential is the one we gave. He's not following that, because Aristotle's distinction is what Andrew Moore said. A potential infinity and an actual infinity have a different definition to what Craig is using. So Aristotle said you could have the sorts of infinities that Craig denies. So he's not following Aristotle. That's just false.
Right.
Yeah.
It's quite important that so Thomas Aquinas, following Aristotle, denied the Kalam argument. I guess there's slight differences between Aristotle and Aquinas that are relevant here, but I won't go into them. Thomas Aquinas thought that there wasn't going to be an argument based on reason for thinking that the past is finite. Aquinas did think that the past was finite, but he thought that that was the sort of thing that needed to be revealed and that couldn't be reached by way of reason. Part of this was that in an Aristotelian view, infinite collections are there's a variety of infinite collections that are actually acceptable. There are other infinite collections that are not on the Aristotelian view, but it's a bit odd to say that. It's a bit odd for Craig to just simply assert that he's following Aristotle.
But perhaps he just means you know, in the sense that he's talking about this distinction between potential and actual and infinites, but nothing more. But in that case, you know, the question is, well, what work is, why
So
mention them?
Aristotle,
Yeah.
so Aristotle thought that what you couldn't have is a collection all of whose members are co-present, and that was infinite. But he didn't have a problem with thinking that that past time was infinite, because Aristotle denied that the series of past events exists.
Well, as does Craig,
agrees-
interestingly.
Right, Craig agrees with that, and so this already tells you that there has to be some difference here between exactly what it is that Aristotle wants to say and what Craig wants to say. Yeah, I mean, it's so, you know, Craig has to say that you can have an actually infinite collection even though all the members are not co-present. Now, there are people like, so Andrew Lope, for instance, tries to construct a thought experiment where he says, look, if you could have an infinite past, then you could have the possibility of accumulating an infinite number of objects in a collection, and then you would have an actual infinite in the Aristotelian sense. I would reply to that kind of thought experiment in a way that, so Landon Hedrick has a paper from, I think, a couple of years ago, maybe it was just this past year, but he argues anyway in that paper that what this might actually show us is that that it's metaphysically impossible to have an infinite amount of matter, and not that that an infinite past is impossible. So it's sort of similar to, in a way that's sort of similar to what Alex Malpass is saying, where it's it's what the thought experiments show us is not necessarily that an infinite past is problematic, but perhaps that certain kinds of infinite collections are problematic.
Conceptual.
And let's go to the next excerpt.
But in the 19th century, Georg Cantor revolutionized the mathematics of the infinite.
What Cantor achieved was to treat infinity as a subject of mathematics.
I'm just going to skip through the original video.
Cantor founded infinite set theory. And it's important to understand that all of my arguments assume Cantorian set theory and ask whether that theory can be instantiated in reality. My claim is that that would result in situations that are plausibly metaphysically impossible.
Okay. Next clip.
What Cantor showed.
Plausibly doing a lot of work there.
Yeah, well, so another thing to be pointed out, by the way, is, part of what happens in the dialectic between Cantor and the mathematicians that preceded him, at least the kind of story that one often finds in textbooks, is that Cantor needed to provide an argument to convince other mathematicians that they couldn't make use just of the potential infinite, that they needed the actual infinite. The argument that Cantor provided is what's called the domain principle argument. This is an argument according to which the potential infinite presupposes the actual infinite. So, for instance, if I have a infinite sequence, so if you imagine like multiplying, starting with the number 1 and then multiplying by 1/2 over and over and over again, the sequence approaches 0, but in some sense never reaches it. That reflects a kind of potential infinite, the fact that there's no value of the sequence at infinity. But what Cantor pointed out is that that whole sequence is defined over the positive integers, and that because it's defined over the positive integers, if you want to state that in rigorous terms, like the way you would state it in, say, real analysis, is in terms of the set of integers, which is an actually infinite collection. And so Cantor, the way that Cantor convinced the rest of the mathematicians that we should take the actual infinite seriously is that the potential infinite appears to presuppose that there are actual infinite collections. In the case of, so when Craig considers an interval of time, Craig says that you can potentially subdivide that interval of time forever. So you can take like the present day, divide it into the present hour, the present second, and so on, and do that forever such that every subinterval has proper subintervals. If it's really true that every subinterval has subintervals, then all of those subintervals need to be in some sense already there in the original interval that you were dividing up. But if that's right, then it seems that Craig's view of temporal continua itself already presupposes an actual infinite. Richard Swinburne, in his reply to Craig's Kalam argument in his book, The Existence of God, points out something like that. He doesn't invoke, as far as I remember, Cantor, but the argument that Swinburne gives there and the argument that Cantor gave about Cantor does this with line segments, but they seem qualitatively similar arguments.
An interesting thing here is, I sort of am sympathetic to some of Craig's points here in the sense that I do find a lot of the talk about infinity highly counterintuitive. I think where I differ from Craig is the sort of claims that then he wants to make about what can and can't be, instantiated in reality or in any possible world or anything like that.
Yeah, I mean, it's important that that something is counterintuitive may provide some evidence against it existing in reality, right? Like, I would be very surprised if we found like a Hilbert hotel floating somewhere out in space. But the idea that means that there's no metaphysically possible world where there's such a thing, I don't understand how that argument is supposed to work. It's, we don't ordinarily take it to be the case that something being counterintuitive gives us that kind of consequence. Like, ordinarily in doing philosophy, we may take it to be the case that something being counterintuitive is some amount of defeasible evidence that we wouldn't find it in reality. In the sense, we'd be surprised if we were to find it. But it's not evidence, it's not typically taken to be evidence that there's no possible world where there would be such a thing.
And so if Craig sort of formulated this argument such that it was, perhaps a lot more modest, it was kind of, well, there's good reason to think this, and then he kind of framed it probabilistically, then maybe it'd be a bit more sympathetic to the way that the Kalam was working. But it's the way that he makes it, no, it has to be this way. It's not even possible. Yeah.
I mean, these a priori arguments are supposed to deal with metaphysical necessity. It's supposed to be that it's metaphysically impossible for the past to be infinite. That's such a strong claim. And, it's difficult to think, it's difficult to imagine how you could have an argument that would really get you to a claim that's that strong.
Well, Nathan and I asked Craig about this in one of our videos, which he actually sort of responded to. If you remember, Craig, Nathan, that Craig responded in one of these in his question things. We asked him about how you can establish that something is metaphysically impossible on the basis that it is absurd, which is the phrase that Craig uses, or counterintuitive, or however we phrase it exactly. And I don't really think he answered the question very well. He just sort of reiterated what he usually says. But I do think that's a fundamental weakness of many of Craig's arguments, actually, that he appeals to his sort of intuitions about the way he thinks that space and time and causes and things just sort of have to work. And if people don't agree with his intuitions or ask why he takes them to be reliable about such things, he just sort of says that, well, they're wrong, or that it's crazy to think differently and things like that.
And then I think that this actually does quite a lot of harm to the broader discourse in the sort of apologetics context, because then I at least find that I talk to a lot of Christians who are sort of looking up to Craig and kind of arguments that he's giving in favor of Christianity, and you'll kind of probe for people's reasons for sort of supporting certain premises, and they'll say, well, it's absurd if you think that, and you'll be like, well, what do you mean by absurd? No, your worldview is just absurd, and kind of reasons come to an end at that point, and it's very difficult to then proceed with the discourse, as Craig says. So Craig's kind of use of absurd here I've at least experienced it doing a bit of harm. Maybe it's not done that much harm. If I were to actually look into a larger sample size than my experience, but yeah.
An infinite set has a strange feature. We might call this the infinite property. That is, it can be put into a one-to-one correspondence with a subset of itself.
Well, this is rather his definition of the actual infinite. This is not something that Cantor proved. He simply defined an actually infinite set to be a set which has a proper subset with the same number of members as the original set itself. Moreover, two sets are defined to have the same number of members if their members can be put into a one-to-one correspondence. This is all done by definition. Ironically, Cantorian set theory, which is called naive set theory, is in fact riddled with logical paradoxes. And the way in which the mathematicians solved this problem is by what's called axiomatization of set theory. That is to say, they simply adopt the axiom that there exists an infinite set. And as an axiom, it cannot be proved nor does it enjoy any intuitive support. It's just a postulate that the mathematician makes.
Nor does it enjoy any intuitive support then as well. I mean, according to whose intuition?
I mean, why should your intuitions about infinity be reliable? I mean, I expect intuitions about things that happen in my living room to be reliable, things that happen when I walk down the street to be reliable. But why on earth would I have reliable intuitions about infinity?
Yeah, and here he
sorry,
almost seems to be edging back towards the position that the mathematical description of infinities is self-contradictory. He hasn't directly said that here, but he's talking about the postulates not having intuitive support and definitions of infinities having the same size in terms of correspondence and things like that, in a way that makes it seem like he's casting some sort of doubt or aspersions on this, when this is all just the mathematical structure. Typically, he just says, look, that's all fine, but it can't exist in reality. It can't be like instantiated in the real world. So I don't even know why he's sort of saying this. It seems a little, I don't know, it just seems odd to me that he even needs to comment on this.
One of the things that gets lost in these kinds of conversations, or maybe even never brought up in the first place, is that Cantor had one particular way of dealing with infinity mathematically, but not the only one. Not the only one even in his own lifetime. So there was another mathematician named Bolzano who had a different way of dealing with infinities. It was, for a long time, people thought that there were really deep problems with Bolzano's system. In the last couple of decades, people have worked out ways of making Bolzano's system logically consistent. And, and then today, people have different conceptions of things like the size of a set and different notions of infinity. There's a rather nice book that is fairly readable for lay people by Donald Knuth, who you might know if you do computer science. But Knuth also wrote a book about a different way of thinking about numbers that he calls surreal numbers. And among the surreal numbers, there's a different way of thinking about transfinite numbers than the system that Cantor had. A lot of the paradoxes that Craig brings up about supposed paradoxes. I mean, it's unclear whether they actually are, but the ones that, some of the issues that Craig has with Cantor's way of treating infinity just do not arise for the surreal numbers. So it's but you don't see people in this sort of literature, in this milieu, talking about these other ways of thinking about infinity, and that's, to me, from my perspective, rather strange. It's sort of, he took the one little bit of transfinite mathematics that you get in philosophy grad school and then ran with it without checking to see, are there other ways that mathematicians have of doing these things?
Also, my understanding historically, which is, I mean, it doesn't have that much bearing on what Craig's saying here, but is that didn't some of Cantor's kind of musings on infinity kind of drive him towards thinking about the divine, and that, like the infinite was really important, and he sort of, I mean, I think he had quite poor mental health towards the end of his life, but my understanding is he started talking about theology quite a lot and the infinite in that context.
There's a lot of theologians and mathematicians that think, well, God is infinite, so when we find infinity makes sense, that's in supporting God. I mean, Bruno thought that God was infinite, so he would have made an infinite universe. So the universe had to be infinite because God was infinite. So, there's obviously
both Cantor and Bolzano were interested in theology, and it's quite right that that Cantor brought his work on the transfinite into his theological work. I don't think it was connected with his mental illness. I mean, sometimes in popularizations, people present it as like, oh, thinking about the infinite.
He stared into the abyss.
Yeah. Right. But I mean, look, I first learned about this stuff when I was in high school. And then when I was in college and undergrad, I had courses that covered set theory and all kinds of things. It never drove me into insanity or something like that. So it captures people's imagination to think that there are kinds of knowledge that are so forbidden that they drive you insane or something like that. But I don't think that that's a realistic way of understanding what actually happened historically.
Yeah, I suppose my only point is that situating Craig's argument in this kind of broader Christian project of natural theology and so forth, I mean, surely he doesn't want to kind of undercut a bunch of other people's models of God and the divine.
Yeah, that's
Yeah,
right.
but-
Though there's other ways of, so in the case of divine knowledge, for instance, if you think that God's knowledge is simple, then you're not going to run into problems with omnipotence. Is not going to be the statement that there's an infinite number of propositions that God knows. And likewise, in the medieval and early modern period, there were two different ways of thinking about God's transcendence. One was called there's this notion from Thomas Aquinas about the analogy of proportionality versus the analogy of proportion. The analogy of proportions would make God be something like an infinitely great person, whereas the analogy of proportionality would make God categorically different from human beings and transcendent in that sense. So it really comes down here to what your specific model of God is, in terms of whether or not it has a conflict with the kind of finitist arguments that Craig supports.
Coherent about what we say in the infinite case, it just follows that we have to start saying different things in the infinite case.
Well, again, Kevin, I'm not challenging the internal consistency of infinite set theory, given its definitions and axioms. The question rather is whether an actually infinite set of things can be instantiated in reality. Could there be, for example, an actually infinite number of baseballs?
What you get from most mathematicians, I would say almost all
See,
mathematicians.
we sort of touched on this before, but I don't think too many people think there could be an actually infinite number of baseballs. I mean, certainly not in the physical universe. I don't think they would fit, right? But it doesn't follow that there can't be an actually infinite amount of anything, such as past events, especially if you don't think that they all exist at sort of the same time, right? They exist successively, according to Craig. So this is the issue here. Go ahead.
No, go ahead. I'm sorry.
Yeah, well, this is the issue here when Craig uses these sorts of analogies or thought experiments. There are more that will come later when we talk about like the causal principle as well. But he sort of, and even Hilbert's Hotel is really another one of these. The fact that certain types of infinities are impossible doesn't mean that any type of infinity is possible. And there's just often a lack of clarity about which particular properties are doing that work here. I think that the baseballs part is doing a lot of work here. And you just ask the question, well, what about past events? Are they analogous to baseballs? I mean, not really, right? So why are we talking about baseballs?
The point that I was going to bring up is another historical point, and Phil knows this point well. There's this fantastic paper. There's a historian of cosmology named Helge Krag, and Krag has a paper where he traces the history of the Hilbert Hotel thought experiment. This thought experiment first appears in a lecture that Hilbert gave, but that's not what popularized it. What popularized it was a book by a physicist named George Gamow, and it was a very early popularization of cosmology. And one of the questions that Gamow treats in the book is something like this: is if the universe is if the universe is spatially infinitely large, how could it be that the universe is expanding? What Gamow says is that effectively the entire universe is a Hilbert Hotel.
Right.
So, I said before that it'd be surprising if we discovered that a Hilbert Hotel floating out in space. Well, what Gamow thought was that we live in a Hilbert Hotel. It's
a great irony because he was defending infinite space and the Big Bang Theory by using the Hilbert Hotel.
It's only a decade or two later, something like this, maybe a couple decades later, that Craig writes his first book on the Kalam, in which he invokes Big Bang Theory, and he's already invoking this the Hilbert Hotel stuff. So I wonder, I don't know, but I've wondered whether Craig read that book by Gamow and that's how he found out about it. But if that is right, it would be kind of awkward because it turns out that a certain way of understanding Big Bang Theory commits you to believing in the physical realization of a Hilbert Hotel.
An uncritical acceptance of infinity in the sense of actual infinity. That's what they need for doing the kind of mathematics that they do.
Sure, there are a small number of intuitionist mathematicians who deny even the mathematical legitimacy of the actual infinite. But that's not the issue before us. I assume Cantorian infinite set theory in my arguments.
So
Sticking
hang
with
on,
this
just
clip
pause there
from
a second.
Adrian
Hang on,
Moore.
hang on. So the quote from Isaacson is almost all mathematicians have an uncritical acceptance of infinity in the sense of an actual infinity. And what Craig said was that mathematicians recognize self-contradictions in actual infinity. So, and then when we play the clip, he goes, "Oh well, I accept that. I accept that." Hang on, that doesn't work.
I was just thinking, in the interest of time, because it's a response, you know, a response on a response on a response. Maybe if I skip to around 26 minutes in this video, and I mean, it'd be good to respond to everything, but
Yeah, we don't need the different
We're going
sizes
to
of
be
infinity.
criticized
It's
for
not
not
that important.
responding to everything.
Aleph 2, Aleph 3, Aleph 4, Aleph 5 cannot exist in reality because there wouldn't be enough room for them. But in any case, this is all really quite beside the point, because the Kalam cosmological argument is concerned only with the least transfinite number, Aleph null.
This next clip, the narrator introduces you again, Bill.
As we saw earlier, when presenting to a lay audience, Craig has claimed that the infinite is contradictory.
But mathematicians recognize that the existence of an actually infinite number of things leads to self-contradictions. Yes, that is a shortcut to communicate these extraordinarily difficult concepts to laymen. Some, but not all, metaphysical and possible
Okay, stop
situations.
that. Okay, I know we're going to
That's-
hammer on this point.
That's so lame.
It's supposedly a shortcut. So I came up with a way that, I mean, he literally says, well, I shouldn't say literally. He says something like, let me think. What he should have said was, the claim is not that infinity is self-contradictory or inconsistent, but rather metaphysically absurd. So that's what I think is a summary of his position that he's putting out here, right? That is 16 words. What I just said, 16 words. What did he say in the Hitchens debate? It was 17 words. Okay, it's not a shortcut. It's an attempt to use the force of the authority of mathematicians to bolster his point, right? This idea that it's a shortcut it's really a lame excuse.
I mean, it's you know, again, I don't like to say that another academic is like, you know, willfully disingenuous, but it's hard to know what else to say here. I mean, he publicly said to a public audience that this is the view that most mathematicians have. And it turns out that in his academic work, he recognizes, and in fact, on the podcast that we're listening to, it turns out that he recognizes that that's just not the view that mathematicians have.
And one other point, because you know, in academia, you're supposed to respond to the most sophisticated version of the argument. But this is YouTube, and I wanted to respond to the most viewed version of the argument. The Craig debate with Hitchens has been viewed 5.6 million times. How many people do you think have read Craig's academic work? Right? Probably a lot less. So I think it's important to respond to someone, and in the YouTube format, I think it's the appropriate space to do it, to respond to the one that's been actually seen by the most number of people.
And these
Fair,
sorts
the
of
video that we're watching, so to be fair, the video that we're watching is itself a YouTube video. One way that you can understand what Craig is doing here is that he's responding to himself, right?
these kind of sort of miscommunications, perhaps, but to a lay audience, are almost more dangerous given that context, though, than anything, because the lay audience isn't in a position to sort of you know, distinguish between these things or realize when, you know, that something might be a bit of either rhetorical flourish or something else. So yeah, I think that the context actually maybe potentially makes it worse in this case, because if you're talking to a lay public audience, you've got to be extra careful not to do, you know, not to make what you're saying appear even stronger than it is.
Involve logical contradictions.
But when talking to philosophers, a different claim is made.
Now, Alex is certainly right that when we appeal to these absurdities, we are not talking about logical contradictions or incoherences. Jose Bernardet, in his book on infinity, says that there's no logical contradiction involved in these monstrosities, but you have only to look at them in their concrete reality to see that this is metaphysically impossible. Right, illustrations like Hilbert's hotel and Bernadette's book may not be strictly logically impossible, but I think they are metaphysically impossible. Other paradoxes, like Proust's Grim Reaper paradox, however, do involve logical contradictions.
Another clip from Alex Malpass.
In contrast to other notions of possibility, metaphysical possibility is far less clear what the definition of that is supposed to be. And many of us are dubious that just simply pointing that something seems absurd is enough to forbid it from existing. In reality, philosophers have to be a lot bolder than that, a lot more open-minded.
Fair enough. The boundaries of the metaphysically impossible are unclear, since they may not involve logical inconsistencies. For example, is it metaphysically possible that gold might have had a different atomic number than 79, or that your desk could have been made of ice? Intuitions may differ, but most philosophers would say that these logically consistent scenarios are nonetheless metaphysically impossible. Similarly, given the counterintuitive consequences of the real existence of an actually infinite number of things, I think that skepticism about their metaphysical possibility is surely justified.
Okay,
Up
just
next,
to
a
stop
clip
it there
from Daniel
a sec. So two things. First off, he's saying, well, skepticism about infinity is justified. I mean, I agree with that. Like we should be skeptical, right? But he's not asking us to be skeptical about the possibility of infinity. He's demanding that it can't exist. That's not the same claim at all, right? The other thing is he's just admitted that the boundaries between what's metaphysically impossible and what's metaphysically possible are very difficult to ascertain. That gives him, and if he's basing it off a metaphysical possibility, which he's agreed, he's just conceded, it's hard to determine because people have different intuitions. That gives you really a very weak argument straight away. I mean, that's just what's implied, isn't it?
Right. So look, all else being equal, so if all we have in support of a given conclusion is an argument, then the probability of that conclusion is just the probability of the conjunction of the premises. Moreover, the probability of a conjunction is no more probable than the least probable conjunct. So what this tells you is that if you have an argument where the epistemic probability of one of the premises or of some assumption that goes into the argument, that epistemic probability is unclear, then it's going to be at least unclear what the epistemic probability of the conclusion is. Now, things can differ if we have other reasons to support that conclusion, but at the very least, what this shows us is why it is that arguments that contain sufficiently controversial premises are bad arguments, right? Because we don't know what we should say about the conclusion if all we have is just that collection of premises. Here, Craig has admitted that the premises that go into some of his arguments against an actual infinite are deeply controversial. The people's intuitions about them will vary, and therefore, I would say that it's unclear what we should assign or how we should think about whether the epistemic probability of those premises is high or low or whatever.
And Craig also makes exactly that point in Philosophical Foundations of a Christian Worldview as well. So he agrees with you.
We need to be a little bit careful because I haven't gone back and, to be fair, I haven't gone back and looked at that book in a long time. But there are various places where the claim that Craig makes is actually slightly wrong. What he says is that if it can be shown that each of the premises in an argument has a high probability, then the conclusion of that argument has a high probability. But that's not right, because if I have a conjunction and each of the conjuncts in that conjunction
is independent,
probable, right? It doesn't mean that the entire conjunct is probable. You can imagine if I have numbers between 0.5 and 1, and I multiply that string of numbers together, it's actually quite easy to get numbers that are less than 0.5. So even if all the premises in these arguments against an actual infinite are themselves probable, as Craig has sometimes claimed, that wouldn't suffice for showing that the conclusion is itself probable.
So if we just summarize, is this correct, Daniel? That he says, well, as long as the premises are more probable than not, then we've got what we need. But if I have one premise that's 0.6 probability,
0.6, yeah.
Second probability is 0.6. Second premise is 0.6 probability. The probability of conclusion is 0.36.
Right.
Exactly.
So he's just wrong. I mean, it's simple. It's an error in really simple high school maths.
Yeah, I mean, assuming that the premises are probabilistically independent.
Yeah, sure.
I need to get my door. I'll be
yeah,
right
no
back.
problem. Don't worry. I can put you in the background for a second. Did you want to say something, James, on that?
Oh, I was just going to bring the multiple premise argument thing up because that was on my mind as well. It boggles my mind that Craig argues that all you have to do is show that all of the premises are more likely than not, and that the conclusion follows. The example I like to give is an argument saying that person A is almost certainly not going to win the lottery. Person B is almost certainly not going to win the lottery. Chain that together with everyone who bought a ticket. Therefore, almost certainly no one will win the lottery. Well, that's obviously ridiculous, right? And Craig doesn't sort of seem to get this point. But also the idea that notice what he said here is that each the fact that there are so many counterintuitive implications of infinity warrants skepticism about the possibility for actual infinities to exist. Just replace actual infinities with many aspects of like Christian theism or the existence of God. Like there are many counterintuitive aspects of God in general, and also specifically the Christian God, like the Trinity, for example, incarnation, the existence of evil, like all sorts of things that many people have struggled with. Many people have thought these are reasons, these counterintuitive aspects are reasons to be skeptical about the existence of God, but Craig doesn't really admit that at all. So I guess the question would be, when do we rely on our the existence of counterintuitive or sort of bizarre consequences as reasons for being skeptical about something? I don't think Craig has a really well established set of principles
like
for
a timeless,
applying
spaceless mind causing the universe to exist.
Yeah, exactly. Like you could phrase things in these sorts of ways that Craig likes to do about, say, Hilbert's Hotel, that makes it sound really strange.
But that's absurd.
Yeah.
And another thing he said as well was, most philosophers think of metaphysical possibility in the way that I'm describing it here, or kind of sign up to what I mean by it as well. And I don't think, look, I'm prone to saying that sort of thing when, it sort of seems to me like most people might agree with me, but I don't think there is good. Like I was looking on the Phil paper survey just then. I don't think there's any questions that specifically ask that as well. So I don't actually know. And even suppose, the majority of philosophers did agree with Craig on that. Should we take that as kind of
Craig
expert consensus
takes
in philosophy?
very risky minority positions when it suits him, but then when it's useful, he criticizes other positions for being fringe. We'll see this a little bit later with some of his other views.
Hotel case is so basic that that's no place for anybody to dig in their heels against infinity. Even if you only accept potential infinity, the Hilbert Hotel and those results about it are completely incontrovertible.
A strange response. He must mean merely that Hilbert's Hotel is a good illustration of the existence of an actually infinite number of things. Well, of course it is. We should expect that David Hilbert, perhaps the greatest mathematician of the 20th century, knew how to illustrate accurately the actual infinite. His hotel is not merely potentially infinite.
Here's another clip.
Hang on. What Daniel was saying, obviously, is that there's nothing in Hilbert's Hotel that should make you believe that infinities can't exist. That's what he's saying. I think that's obvious what he's saying. It's not a strange response. It's a very clear response. I have no idea why Craig thinks it's strange.
The examples that are supposed to be problematic always involve admitting new guests, shuffling guests from one room to the other. And if we imagine a hotel where the doors were sealed and nobody could move from one room to the other, it's hard to think of a similar example that could bring out anything that looked absurd about it. It would just be a hotel with infinitely many rooms in. And if that's right, it does lead you to wonder whether the problem is the infinity involved or whether it's the manipulation of those infinite elements that's the problem. And that's helpful because, it's plausible to suppose that what's done is done and you can't change that. The past is fixed and unchangeable. So that if the past is supposed to be like an infinite hotel, then it's more like one where the guests can't shuffle around than one where they're free to move to different rooms. It's just impossible that yesterday didn't happen, given that it has happened.
This reply is bizarre. We can use any concrete reality to illustrate the existence of an actually infinite number of things. For example, baseballs, coins, stars, people. There's nothing about the absurdity involved in Hilbert's Hotel that hinges upon the illustrations involving a hotel with rooms and doors.
Well, Bill, we're out of time, but
that's his response. Sorry, Phil, you go ahead. I just can't believe that was.
There's a bit that we skipped over where we talked about subtraction from infinity and that it's not well defined. And Craig
that comes up in the next video, I think.
Okay, well, anyway, so Craig responded and he said, "Well, you can't stop people from leaving the hotel. Bar the windows, they'll jump out the. Sorry, was it? Bar the
doors and they'll go out the window.
Yeah, and so he's saying that the reason that this is problematic is because people can leave the infinite hotel, but events can't leave the past, right? You can't take out World War II from 1939 to 1945. It happened, right? So it is not. So Malpass's point, which I think goes back to Graham Oppie, I think is completely valid here.
I mean, with the baseballs, suppose you had an infinite collection of baseballs. What's supposed to be absurd about it? Well, what's supposed to be absurd about it is that there's two different ways of taking away an infinite number of them that give you two different answers, supposedly. And I mean, that's just to say that what's supposed to be absurd about the baseballs is that you can shuffle them around in precisely the way that you cannot shuffle around times. So Craig is right that you can illustrate this with things other than hotels, but I don't see why that should matter. The thing that generates the absurdity
That
is
wasn't the
precisely
objection.
What's
The
that?
objection is nothing about hotels and doors and windows. The objection that Malpass just made was that it's the shuffling that seems to be doing the work or the moving around in these thought experiments. Might want to mute when you're sneezing. But you can't move around events in the past. So how is that relevantly analogous? Craig's response is just to say, well, it doesn't matter if it's a hotel. You could be baseballs. I don't understand how Craig can just not respond to that objection. He just ignored it. I was flabbergasted.
By the way, there's something else to be said here. So we've discussed before about how one of the interpretations of the unsatisfiable pair diagnosis is that what these thought experiments show us is that there are certain kinds of infinite collections that are problematic, and not that all infinite collections are problematic. One of the things that can be said here about these operations of moving things around, we know that in our actual universe, there's a finite limit on how fast an object can move, namely the speed of light. Since nothing can propagate infinitely fast, so consider the case where you want to accommodate a new guest into Hilbert's hotel. How do you do that? Well, you have to take guests out of each room and put them into the next one, right? That's a process that would take infinite time, assuming that each of the guests moves at some finite speed. Of course, you can say the same thing about baseballs or whatever. It could be that what these sorts of examples actually show us is that it's what's impossible is to have an infinite collection in a universe where there's no finite limit on propagation speed, for example. And I could see someone who I could imagine a philosopher who's like the anti-Craig and wants to argue that something like relativity is metaphysically necessary. And maybe what they would say is that the Hilbert's Hotel actually shows us that a finite propagation speed is a necessary feature of the physical universe, and not that infinite collections are metaphysically impossible.
Yeah, that's a really good point. I hadn't thought about that implication because I have made the point before that most of the types of thought experiments that Craig gives are ruled out in terms of being physically realizable just by laws of physics. But he would say, well, it's just metaphysically, it's not about the laws of physics. But the idea that if you could argue it the other way, as you just pointed out, Daniel, that if you wanted to avoid the conclusions, you could actually make the argument that some aspect of physicality could be metaphysically necessary.
Right.
Like
here's something that I find, so as someone that works in philosophy of physics, something that I find mysterious is why there should be laws of physics in the first place. But maybe here's an explanation
God made
for
them
at least
easy.
some. What's that?
He said God made them. He was
sorry.
God
on the wrong
right.
thing. Yeah, God made them.
But maybe here's a possible explanation, right? Is that there are these that there are principles of metaphysical necessity, and at least some of those principles are what we call physical laws. Like that's a possible explanation of physical laws, is that they just turn out to be metaphysically necessary. And someone who wants to take up a very different position from Craig's could argue that that's what these thought experiments actually show us.
Well, Oppie argues that the laws of physics are necessary, although I haven't heard him use the line of argument that you just gave, but that's actually interesting sort of connection there.
So Landon Hedrick has a paper, I mentioned it earlier, I don't know if it's from this year or the past couple of years, it's a recent paper anyway, and Hedrick has had a back and forth with Locke about Hilbert's Hotel, and in the most recent paper at least, Hedrick defends the view that what the Hilbert Hotel thought experiment might actually show us is that the amount of matter in the universe is necessarily finite, so that you couldn't build the Hilbert Hotel even if you had infinite time in which to build it.
Let's pick it up right there. And on the next podcast, we'll be talking about.
Okay, so into part 2.
have always been orbiting the sun from eternity past, which has completed the most orbits. Strangely enough, the number of their orbits is exactly the same, infinity. But that seems absurd, for the longer they orbit, the greater the difference becomes.
Hit the infamous graph just to imprint it
This
in
graph
everyone's.
is terrible.
Where's
Yeah,
that
right.
starting point there?
Yeah,
Yeah.
you know, this is a sort of ubiquitous feature of at least some of the thought experiments that, well, I guess if it's only a feature of some of them, that's not ubiquitous. But anyway, a feature of some of these thought experiments is that they like illicitly assume a beginning,
For
and
an
then
infinite, yeah.
Right.
yeah, right. And it's like, no, like your interlocutor is supposing that there is no beginning. So it's not as though like there's some time when, you know, the one planet catches up to the other or something. It's that, you know, it was always the case for every time that there ever was.
Yeah.
At that time, it was already true that they had done an infinite number of orbits.
So if you look at any kind of time slice on the graph, you could go, oh, they're in correspondence at this point. But if you looked at the whole graph, you wouldn't see them kind of converge into the past at some point and go, oh, this is.
And then you can do this too. So pick out some point in time, and then look at how many orbits each of them do over the next. Pick out any span of time you want, like the next 100 years or whatever it is, and you would see that like the blue planet would, you know, do more orbits in that window of time than the red planet. And nonetheless, it would also be true that before that window that you picked out, both of them had performed an infinite number of orbits. And by the way, the other thing to point out here is that there's a whole literature on what are called Euclidean conceptions of set size, to which this objection is just completely inapplicable. You don't have to like side with Cantor about how to so Cantor's idea, right, is that set size is cardinality. That set size and cardinality are the same thing. But there are mathematicians and logicians who disagree and have an alternative conception of set size. And on their conception of set size, the purple or blue planet or whatever would actually have a larger number of revolutions than the red planet, even given an infinite past.
I didn't know that.
And I think that this just again sort of sits within, you know, the public communication side of these philosophical ideas, right? Where it's just kind of, I mean, it is perhaps not deliberate. I mean, I don't know the exact process that went on in the creation here, but this sort of thing is at least going to lead some people astray if they kind of see a graph.
It's just atrocious that this graph got into the final video. It's just so misleading by showing that they start off with the same amount, which looks like it's close to zero, and then diverge, which just doesn't make any sense at all.
Right. And then there's a point where deNysschen said this doesn't make any sense. And Craig, we skipped over it, but Craig goes, well, that's my point. I was like, that's not your point. Your
sentence.
Right. The point Dan's making is it doesn't make any sense that you could describe these in the way that Craig describes them. That's what Dan was saying.
You know, this point about set size, it's sort of a microcosm of a larger problem in natural theological arguments, which is that, so for instance, with the moral argument, what you find often in at least like internet apologetics is that a lot of apologists just do not know anything about metaethics. They're completely ignorant about any secular ethical theory, even though secular ethical theory has been going on for 2,500 years. And likewise, you know, you have a bunch of apologists running around with talking about cardinality as their notion of set size, when they haven't actually read the logic or mathematics literature to see if there are other conceptions of set size. And so it's just like, you know, I mean, and, you know, maybe they could come back and say that they have some problem with those other conceptions of set size, but even that they haven't done, right? Like they haven't just addressed the relevant literature on, you know, how do we describe the size of a set?
This is a second independent argument against the infinity of the series of past events. Even if you think that an actually infinite number of things can exist, an infinite collection cannot be formed sequentially by adding one member at a time. Al-Ghazali's illustration of Jupiter and Saturn's having completed the same number of orbits is, I think, a great illustration of how absurd this is.
Next clip.
But the assumption here, right, is that you start from zero and then create an infinite past by adding her.
Yeah, Craig still keeps talking about forming the past series of events by successive addition, but that's not the argument. The argument isn't that somehow there was a beginning and then we accumulated infinitely many events. There's always been infinitely many events, and they just keep passing. Like I don't know why. I mean, I think that the next section there's more of this, so maybe I'll save it. But Craig just doesn't seem to recognize the point that people who think that the past had no beginning don't think that infinity was accumulated from a finite set by successive
Infinity
addition.
ago. Yeah.
Yeah,
I mean, this is very
that's not
similar
the claim.
to a point that I make in my dissertation about the successive addition argument, which is that they want to say that the collection of past events was formed by successive addition. They define that as being the notion that every past moment was added to the past through successive addition. Even if so, that only works, by the way, if we assume the A theory of time. But setting that aside, supposing that every event was added to the past by successive addition, I think it's at least very misleading to say that the past formed by successive addition, right? Like the hypothesis is supposed to be that the past did not form. That for every past time that there's ever been, there's already an infinite amount of past before that.
Yeah.
From Daniel Isaacson.
If they were always orbiting, then there is no notion of one being at any given point having gone twice as many times as the other. That just doesn't make sense.
Thank you. That's just my point. At any point in the infinite past, they will always have completed exactly the same number of orbits, even though every time Saturn completes one orbit, Jupiter completes two.
And here's Alex Malpass.
So what's the problem with that? Like, he doesn't draw this out in terms of how that tells us that the past must be finite. It's just kind of, well, yeah, it's a bit strange. We don't normally see things like that. But Craig doesn't have really much to tell us about why we should infer that the past must be finite, therefore, just because there's this sort of weird property of infinities.
Well, because we have to have a very strong intuition, I suppose, that they have, finite amounts of past orbits that they've done, and that those differ. I don't know. Yeah, it's a bit strange.
Start orbiting at some point in time, and they've done 0 orbits at that point. But if the hypothesis is that they've always been orbiting, then it's just the case that they've both always done infinitely many orbits. There's no sense in which you could draw a graph that they start at 0 and then diverge away from each other, and then one of them catches up or something. They're just both always having done infinitely many.
Yeah, weird, right? Do you think this could really happen?
Let's hear what the narrator.
So that's it. Do you think this could really happen? Yeah, that's the response.
I mean, it's just argument from personal incredulity. I mean, it's simple as that.
It's kind of on Craig to tell us why it can't happen, since he's making the argument, right? But here he shifts the burden of proof by saying, well, it's not exactly shifting burden of proof, but it's close to that, where he's like, well, why do you think that could happen? And I guess, well, because I don't see why not. Why
do we need to say in the objection that we do think that, that could
he's doing something very powerful here. He's appealing to your intuitions, which are built on your experience of finite numbers. And he's asking you to think that the rules for infinite numbers should be the same as the rule for finite numbers. And what Adrian Moore pointed out in the video was that that's ridiculous. Why should the rules for infinite numbers be the same as for finite numbers? They're going to be different. They're different things.
So yeah, that's exactly right. I mean, imagine, it was very surprising to the ancient Pythagoreans that the square root of 2 is irrational. But you can imagine someone saying, "Hey, wait a minute, you can express any number as a ratio," and then insisting that in fact you couldn't have a triangle where the base had the same length as the height, and it's just no, that's certainly metaphysically possible. Even though those numbers don't obey the same rules that we were used to before we discovered irrational numbers. The other points be I forget the other point I was going to raise was, but anyway.
I was trying to think of a good example to raise along those lines earlier, and I couldn't think of one. The closest I came was sort of, supposing someone is familiar with sort of like high school arithmetic, and then all of a sudden, you present them with two matrices and you're like, well, multiply these. And it's like, well, I can multiply, most numbers together. So of course, any two matrices you throw at me, I'm going to multiply them together. And of course it's different, depending on the number of rows and columns that there are in matrices, whether it's defined to do it or not. And it's kind of like, you making an argument based off of the apparent weirdness to someone who isn't familiar with, the arithmetic operations on matrices to get them to convince them.
We have mathematical objects where multiplication is not commutative, and so you could easily imagine someone being like, "What do you mean it's not commutative? When I multiply 2 and 1 or 1 and 2, it's the same. What are you talking?" And it's just it's once you do enough mathematics, your conception of what you can do mathematically broadens.
But no one thinks non-commutative operations can exist in reality. That would be absurd.
Right, until
Unfortunately,
you learn
quantum mechanics.
then you learn that we have non-commutative operations all over the place.
Yeah, exactly.
But the other thing that I was going to mention, and then I forgot a moment ago, was that so there's supposed to be that there's something absurd about the fact that there are two different ways of supposedly there's two different ways of doing the subtractions with infinite collections.
So it might be worth actually just waiting, because that point just comes up in a moment. So maybe we can.
Okay, all right, I'll wait for that.
Yeah.
Infinity is accepted by mathematicians. So what about physicists?
To reiterate, the mathematical legitimacy of the actual infinite is not at stake in this debate. The question is whether these mathematical concepts can be instantiated in the real world. And with regard to the second philosophical argument, the question is, can it be instantiated sequentially, one member at a time?
Let's look at the next excerpt.
So in regards to infinities in physics, the only obstruction that we have is an observer cannot measure an infinite number, because infinity is not a number. Things that are observable cannot be infinite, but things like the entire volume of a space or the entire duration of time can be infinite as long as an observer cannot measure them.
One of the most striking facts about modern science is that it does not employ the concept of the actual infinite. The use of the potential infinite is entirely adequate for contemporary science. There is no scientific evidence whatsoever of the existence of an actually infinite number of anything.
And Bill,
so we can pause there. So, there's this famous argument, from Putnam and there's a famous argument for mathematical realism, which says that look, mathematical objects like sets or numbers are indispensable for formulating our the Quine-Putnam argument.
Best scientific theories.
Argument. Yeah, that mathematics is indispensable for mathematical objects are indispensable for best scientific theories. One of the reasons to think that is just to say something like, look, if you translate sentences from our best physical theories into a formal language, you're going to be existentially quantifying over mathematical objects. And interpreted literally, you're just saying that those mathematical objects exist, and you're saying that in the same sense as you're saying that various physical objects exist. Now, Craig disagrees with that argument, but it's unclear whether he's right to disagree with it. And one of the things that we pointed out here is that the language in which we formulate our best physical theories, in fact, all of our physical theories since the early modern period have been formulated in the language of calculus. They've all used actual infinite collections in their formulation. And you can do tricks where, I was mentioning before, where the notion that you have this sequence where you don't say that there's an element of that sequence at infinity, but nonetheless the domain over which the sequence is defined is infinite. What that results in is that for an introductory student in, say, calculus, sometimes calculus is explained to them in a way that only lets them see the potential infinite that's there. But when you want to make calculus rigorous, the way that you do it is with real analysis. And in real analysis, what you do is you quantify over infinite collections like the integers and the reals. So it's just false that we can formulate our physical theories without infinities.
But even if we could, let's just take the question: is space infinitely big? If it were infinitely big, we would only see a finite portion of it. So this is just a no-seum inference. You wouldn't see it being infinitely big if it were infinitely big. You would only see a finite portion of it. So this just isn't a valid argument against infinity.
Yeah, and sometimes Craig demands that in debates, you'll sometimes see Craig demand that his interlocutors demonstrate that the past actually was infinite. But usually that's not what his interlocutors are claiming. Usually you saw this in the debate between him and Malpass, for instance. Usually the claim made by his interlocutors is just that we don't know whether the past was finite or infinite. And that, the fact that we don't invoke the infinite as an observable quantity in physics is completely consistent with are not knowing whether the past is finite or infinite.
That was the sort of Craigism at the start that I mentioned when I said, unless my opponent today tears down each of the arguments that I have presented and erects in their place, arguments for the counter conclusion, then we're rationally warranted or whatever, and believing that theism is true.
Right. Craig's arguments fail if we're justified in being agnostics.
Right.
And by agnostic, I don't mean the theological sense. I mean agnostic about whether infinite collections exist.
This makes his first appearance in this next clip.
Roger, why don't you start with the absurdity of the Hilbert Hotel? That you can't.
It's not an absurdity. It's just what happens if you have infinity. I mean, that was the major thing. That Cantor had showed you can talk about infinity in a serious way, and you deduce very powerful results from talking about infinity in the right way. You have to be careful when you talk about infinity, but yes, if you're careful, talking about infinity is perfectly reasonable. So I can't see a general statement about infinity is not physics.
Right. It's just what happens if you have an infinity. That's a big if. Hilbert knew well how to illustrate the existence of an actually infinite number of things. So if an actual infinite could really exist, you could have a Hilbert's hotel. But in view of its counterintuitive consequences, is that really possible?
Okay, just pause it there a sec. He's like, well, if, this is the thing, if a Hilbert hotel exists, but that's a big if. But the whole point of the argument is, if there were a Hilbert hotel, would it be absurd? Right? It's not to say, Penrose is not saying there really is a Hilbert hotel, right? He's just saying that it's not absurd, right? And Craig is saying, yes, it is. So his objection that, well, that's a big if, is completely misses the point.
Especially when we're talking about metaphysical possibility as well.
Right.
In view of its counterintuitive, there's all sorts of, twin Earth with its XYZ or whatever.
A lot of metaphysical possibilities are big ifs. That's sort of the point of
yeah.
But also, Craig says,
sorry, James. Yeah, sorry. I go on. I
was just going to say, Craig says that something like, if we could have infinities, or if infinities could exist, then Hilbert's hotel could exist, but that's a big if, right? But that seems kind of wrong to me. It's almost the other way around. Like, just because the fact that there could be some kind of actual infinity of some sort doesn't entail that Hilbert's hotel could exist. If Hilbert's hotel could exist, then that would be an example of an actual infinity that could exist, right? But the reverse doesn't follow. There could be some type, and this is sort of the point we've been mentioning before. There could well be some types of actual infinities which are possible and some which are not. That seems quite plausible to me. But Craig kind of lumps them all together and treats them as all as if, well, it's actual infinities or it's nothing somehow. But that just doesn't follow.
Roger's probably thinking is what I would think is that there's certainly a well-defined mathematical description that one can imagine where there's some function that's defined for all time that describes what's happening at all time, maybe a wave function that evolves with time and is defined for all time. How did we get to now question really just doesn't arise. At the time T0 that we call now, the wave function says that certain things are happening, and if that's an accurate description, that's what's happening. One doesn't have to start at the beginning at minus infinity and go through all the times to get to now. One is just here now.
This is evidently Guth's attempt to respond to the second Kalam cosmological argument against the infinitude of the past, based on the impossibility of forming an actual infinite by successive addition. And what he propounds here is a tenseless view of time, according to which temporal becoming is purely illusory. Therefore, no question can arise about how did we get to now. Indeed, on this view, there is no objective now. But on a tensed view of time, according to which temporal becoming is a real and objective feature of the world, that question is unavoidable. Now, I have written 2 academic books on the tensed and the tenseless theory of time, respectively, arguing that the tensed theory of time is correct and that therefore this does represent a genuine problem for the infinity of the past.
Here's the narrative.
Okay, just pause it there a sec. So actually, after Guth made that comment, I probed him a little bit and asked him, well, why? And he never mentioned anything to do with tense theory of time. What I gave the analogy, actually, there's another physicist called Abhay Ashtekar, who is one of the founders of loop quantum gravity. He was the president of the International Society for General Relativity, winner of the Einstein Prize, and he's a seriously top mathematical physicist. And I gave him the analogy, something like Craig would, I think, which is, if I start a race after I count 1, 2, 3 and fire the gun, you'll start the race. And if I have to wait till I count to infinity, the idea is you'll never start the race. What do you say to that? I thought that was a similar analogy to what Craig had. It just popped into my head at the time. And Ashtakar said, but there is no gun that started. The point is there isn't a beginning that you have to get to. If the past was infinite, there was no beginning. That's the point, right? It's nothing to do with the tense theory of time. I put that to Guth, and I said, is that what you're saying? And he goes, yeah, pretty much. So all Craig had to do was watch the video.
So this set of issues actually helps to bring up another set of issues, which is that all of these arguments, whether the a priori arguments or the a posteriori arguments, they all fail for one reason. And that's that all that they actually establish, if they succeed, is in showing that the past is finite. After showing that the past is finite, Craig then must show that if it has a finite past, that the universe had a beginning.
To exist. Yeah.
Now, one of the things to notice is that Craig's God is supposed to be A, beginningless, and B, in time. And also notice that C, Craig thinks that time is finite to the past. That's what he takes these arguments to show in the first place. So therefore, Craig's God has only been in time for a finite period. So if it sufficed, if it really did suffice for showing that something had a beginning to just show that its past was finite, then Craig's God would have a beginning. But of course, Craig says that his God doesn't have a beginning. So now there are some places where Craig has tried to refine his conception of a beginning such that he's able to say that God has been in time only for a finite period, even though God is beginningless. Fine. But then what he doesn't do is to turn around to these arguments that are supposed to establish the past as finite and show that the universe is the sort of object that because its past is finite, that it must have had a beginning. This is made even more problematic because in the places where Craig talks about God's relation to time and tries to establish that it's conceivable that God could be in time for a finite period, even though God is beginningless, he relates God to various cosmological models, including models that he otherwise claims have a beginning in them. So for instance, singular Big Bang models, he claims that in that context, he claims those models in some sense don't have a beginning because the singularity somehow is beginningless. So there's a weird kind of inconsistency there that Craig himself never resolves. Sometimes he tries to resolve it by invoking things about tenses and so on, but again, he needs to say more when he turns to arguing for a finite past, more than he ever has said. The other thing that it brings to mind is just that look, there are at least three ways of interpreting relativity. You can take a kind of tenseless Minkowskian interpretation. It's something like a B theory, but not quite in the way that B theory is at least presented in intro metaphysics books, where there's no space, there's no time, but instead there's a union of the two in space-time. At least that's how Minkowski presents it in a paper from 1912 or thereabouts. The second possible interpretation is where it's a tensed view, but it's not Craig's tensed view. So you could say that reality is somehow irreducibly relative. So Kit finds fragmentalism is something like this, as is some versions of causal set theory. But most metaphysicians are going to say that that's too high of a cost to say that reality is somehow relative. The third version is Craig's version. It's a kind of, instead of saying that it's an interpretation of relativity, what he's really presenting is an alternative to relativity. It's a kind of anti-realism about relativity, or kind of instrumentalism about relativity, where nature has somehow conspired against us and made the world appear as though relativity is true, when really this other theory is in fact true. And that's an awfully strange view. One of the things that it does is that it leaves completely unexplained why Lorentz invariance is a useful tool to use in developing other physical theories. So like, why is it that when we use Lorentz invariance in particle physics, we can develop empirically successful theories? Neo-Lorentzianism leaves that completely unexplained. It also isn't obvious that, Neo-Lorentzianism is an alternative to special relativity. But general relativity has since replaced special relativity. What Craig has never done is to provide us with a neo-Lorentzian alternative to general relativity. He sort of brushes that under the carpet and pretends sometimes that he has done that, but he hasn't, and no one else has either.
Yeah, so I think this comes up in the next video where Craig appeals to cosmic time as if that somehow restores an absolute reference frame, which it doesn't.
Yeah,
But
a lot of stuff to say about that issue, but I was going to save that until we got there.
Yeah, that's fine. I just wanted to mention that there. But I was just looking at it. It occurs to me, I falsely claimed that in this video they talk about the subtraction of infinite quantities. And actually, that was in the first video, but I'm not quite sure how we missed it. Do we want to jump back to that?
We had to. Why don't we just mention it, right? So
kind of important.
Yeah, because it's... who wants to...
Is there a timestamp in a video, James, that I could quickly go to? Or
yeah, so the discussion of that is in this section here.
18:20
to 23 minutes roughly.
Okay, let me just...
Well, rather than play it all, should we not just summarize it?
Well, yeah.
Okay. Well, I could, if we want. I think it's an important section though.
Okay, go for it.
Yeah.
1820, did you say? Yeah, that's right. There we go.
Hilbert's Hotel. They include that. Let's go to that now.
One classic example that Craig has given to show infinity cannot exist is that of Hilbert's infinite hotel.
Mathematician David Hilbert illustrates the problem by imagining a hotel with an infinite number of rooms, all of which are occupied. There's not a single vacancy. Every room in the infinite hotel is full. Now suppose a new guest shows up and asks for a room. The manager says, sure, no problem. Then moves the guest who was in room number 1 to room number 2, and the guest who was in room number 2 to room number 3, and so on to infinity. As a result of this shuffling, room number 1 becomes vacant, and the new guest happily checks in, even though all the rooms were already full, and nobody has checked out.
It seems Craig is claiming infinity is problematic because the Hilbert Hotel is both full and able to admit new guests. But the problem may simply be the way full is being defined.
If what we mean by full is every room is occupied, then that's true, but it doesn't prohibit us being able to accommodate new guests because we can shuffle them all up right in an infinite hotel. If what we mean by full is can't accommodate new guests, then it's just false that it's full.
Right. So do you think that it's really possible that an actual hotel could be full in the first sense? That is, every room is occupied by a flesh and blood person, and yet it could accommodate infinitely more guests just by moving people around. There's no logical contradiction involved in such a scenario, but is it really possible metaphysically?
And here's our next excerpt.
In Craig's video.
Yeah, so one reason I wanted to play that is because he used the phrase flesh and blood person. This relates to what we were saying before. I don't think anyone thinks that you can have an infinite Hilbert's Hotel with like flesh and blood, like physical people in it for reasons that we've talked about, like that it would take infinitely long to move them all, and I don't know how you'd fit them in the universe.
Feeding them would be a nightmare.
This seems to be rhetoric that Craig is using to make it seem more absurd than it is, when obviously we're talking about some sort of, I don't know, metaphysical hotel with metaphysical people in it that don't obey the normal laws of physics. But yeah, so that was one thing I wanted to comment on there. But I think then after that, they talk about the subtraction issue as well.
So we beg to summarize the subtraction issue. I mean, the issue is supposed to be that there's two different ways of subtracting infinite quantities. So if I have all my people so if the Hilbert Hotel is full in the sense that there's a person in every room, and suppose that on each room of the hotel there's a positive integer, so there's one room for every positive integer. Well, if we take out all of the take out everyone from all of the rooms, then we've taken away an infinite number. If we take away just the people who are in, say, the odd numbered rooms, then I've likewise taken away a countably infinite number. It looks like you might think, wait a minute, I've taken away the same quantities in both cases, but I've reached different answers. Isn't that a problem? There's a very simple reply to this, which is just to say, look, you actually didn't take away the same things. It's a mistake to think that the right way to subtract infinities is to subtract the cardinalities of these two collections. That's not the right thing to do. You can subtract, what we're doing is we're taking an infinite set, and then we're subtracting another infinite set, and there's two different infinite sets that you could subtract. You could either subtract the set of all the rooms, or you could subtract the infinite set that's all the odd numbered rooms. Those are two different sets. And so when you subtract the two different sets, of course you get two different answers. There's no inconsistency there.
But I suppose it seems intuitively implausible, because you think of the cardinality of Aleph Naught as like a number, right? And then you think of the cardinality of all the even numbers as the same number, Aleph Naught. And then you're like, well, I'm taking the same number away from the same number. And in finite arithmetic, that does a particular thing that it doesn't do in this case. And
right, and it's just a mistake to think that that's the way the cardinalities work. Because, by the way, the other thing to be said here is that there are ways of mathematically defining transfinite numbers for which this isn't a problem. I mean, there are notions of transfinite number in which, when you subtract away one from them, you get a different transfinite number. They're different from this cardinality concept. But again, this is the same point I raised before, that mathematicians and set theorists and logicians and so forth, people working in this area, have a plurality of ways of talking about transfinite numbers. And for some of them, it makes sense to talk about subtraction giving sensible results, and for others it doesn't. And so there's a question here about how exactly you want to model this kind of process. But I think, when we're subtracting, I think the most obvious thing to do when we talk about subtracting these infinite sets is that the operation that we're describing is the operation of taking a set and then taking away two different sets from it. Described that way, there's nothing counterintuitive about the fact that you get two different results.
I'm wondering if there's a simpler way to express this, and maybe I'm going to get this wrong. So let me run this past you and see if it's right or wrong. Suppose I've got three things on the table. Let's say pieces of fruit. Let's say an apple, an orange, and a pear. Okay, I've got three things on the table. If I take one of them away, I don't know which piece of fruit. I know how many pieces of fruit I've got left. I've got two left. But I don't need to know which piece of fruit was taken away. Okay, but in infinity, you do need to know which thing was taken away. But when you learn which thing was taken away, then you can get an answer. So if I know I've got an infinite set and I take away an infinite number of things from it, I don't know what I've got left, because I could have taken all of the members of the set, or I could have just taken all the odd numbers, right? But if I tell you I've just taken away all the odd numbers, I know what I've got left. I've got all the even numbers left. So it's not that there's some thing that prevents you from subtracting infinity. It's just that that's in finite arithmetic. Knowing how many things were taken away is enough to get the answer. But
but actually, I think so what you said is basically right. But notice the following. Suppose I've got a collection of fruit in a table, say 3 different pieces of fruit again.
Yeah.
And but there are different kinds of fruit, like maybe like 2 bananas and an apple or something. And then I tell you that I take away one kind of fruit, one piece of fruit, but I don't tell you what kind of fruit I take away. And now I ask you, how many apples do I have on the table? You wouldn't be able to answer that question either. So and that's an example where, it matters what kind of process you actually went through. It matters how you did the operation.
Is there anything else anyone wants to say on this point before I play?
Yeah. So this claim that Craig makes about subtraction not being defined and that being some sort of issue for the existence of infinities is just wrong, and it's frustrating that he continues to make this claim despite the fact that people have corrected him about this, especially the way it's presented in the video, where it's explicitly like infinity minus infinity equals this, and then infinity minus infinity equals something else. It's just that's not.
And again, the graphics are a finite representation whenever they do this as well, which I think I think that's misleading, because if you show a kind of like a discrete set of people and the way that they shuffle around, well, that's guiding your intuitions in the way that it works with a finite discrete number.
Kind of a weird turn in the video here. The narrator starts to talk about meaning in this next clip.
Suppose we agree the infinite is impossible. What does that mean for the infinite future? Supporters of the Kalam are generally committed to this idea, not just because religious texts seem to promise it, but also because some allege that our lives have no meaning without it.
That on a naturalistic worldview, everything is ultimately destined to destruction in the heat death of the universe. Our moral lives become vacuous because they don't have that kind of cosmic significance. This is a red herring. The Kalam Cosmological argument is independent of the belief in personal immortality. We have here, I think, Kevin, a good example.
Well, it's not a red herring.
Wait. Let him finish that.
Okay.
Of an ad hominem objection.
Here's a clip from Alex Malpass and Adrian Moore.
Yeah, so go ahead.
Can we get in that? I mean, wow, it's so disingenuous in my opinion. The Kalam is being used to defend Christianity. Christianity tells us that we have eternal life. So if the argument by Malpass and Morrison that if the Kalam is valid, if the arguments against infinity are valid, then you can't have an infinite life. That means that if the Kalam is valid, then Christianity is false, right? And it's supposed to be used, it's being used to promote Christianity and other religions. Of course, Muslims use it a lot. So this is showing an inconsistent commitment by the person arguing here. Of course, they could say, okay, I'm going to stick with the Kalam and ditch Christianity and ditch Islam and any other religion that teaches eternal life into the future. But of course, they're not doing that. It's completely disingenuous, in my opinion.
Yeah, I agree. I mean, I find this stuff much more interesting in a broader sense than just being arguments about Christianity. I mean, I think the Kalam argument is interesting even if you don't care about philosophy of religion at all. But uh, but I also think that it's philosophically significant if you can take a significant figure's collection of views and show that they don't hang together. I mean, it's a philosophically interesting and significant result in itself if it's true that the Kalam argument and Christianity are not compatible with each other.
I mean, this is sort of close to some of the points that Oppie makes about, disagreement, particularly in philosophy of religion. But when Craig's kind of presenting his argument, so I think he wants to say it's ad hominem because this is a different position than is being presented in any of the premises, and so it's just against him or something. But the problem is that suppose he's presenting the argument to someone who doesn't think that the conclusion is true, so they reject one of the premises. Well, he's then going to appeal to some other belief that he has that justifies, some kind of some reason in favor of believing those premises. And the point is that if we explore Craig's entire kind of justificatory structure, one of those beliefs is going to be, certain theological propositions about an eternal future. And so then there's going to be an inconsistency.
Let's not forget that when he presents these arguments, he often says it's a cumulative case, right? So he might say, well, maybe the Kalam is not totally convincing, and maybe the moral argument is not totally convincing, but adding them all up, Christianity is true, and a Muslim could do the same,
The other thing to be said here is that, since this is a film about the way in which these arguments interface with the public, there's an awful lot of apologists on the internet who do what they think of as internal critique, right? So presuppositionalists, for example, their whole aim is to try to show that their interlocutors have a view that results in absurdity or something like this. It's significant in that milieu that the collection of arguments and claims that Craig has amassed together, that they don't hang together properly.
Yeah, so
sorry, James, go ahead.
Sorry, I wanted to comment on this one. The issue about future infinities is just about to come up here, so we'll talk more about that. But I just thought it was strange for Craig to call that an ad hominem, like an attack on the person, because I don't really see how that was an ad hominem. We're talking, I mean, as was just said, we're talking about other issues which are other positions that Craig has committed to, which are potentially inconsistent with what he holds here. That doesn't seem to be an ad hominem to me.
There's two senses of the phrase ad hominem. One of them, one kind of ad hominem argument is where you present an argument that simply like insults a person or something like that. Like that you reject an argument by saying that the person offering it was dumb or something like that. But there's another kind of ad hominem argument where there's a more technical sense of the phrase ad hominem, where what you're doing is you're pointing out that your interlocutor's views are not consistent with one another. And what Craig is doing here is he's using that more technical sense of ad hominem. If you watch the exchange that Craig had with Alex Melpass, it's also the response he has in that exchange to Alex.
I guess that just seems like more of a debate tactic thing, though, because surely the context that we're in, if we're seeking truth broadly, is going to be to kind of look at the best theories which embed Christianity is true and atheism is true, and compare them and see what comes out.
I don't really see how that's a fallacy, because if Craig wants to use the Kalam as an argument for Christianity, which of course he does, then the fact that if it is the case that it contradicts a teaching Christianity, that's very relevant. So I don't know.
So it's not a fallacy. So ad hominem in this technical sense is not fallacious, but the point would be something like that. It's of limited use, or that it's provincial, because it only addresses one like package of views as opposed to addressing a broader sort of context. But I think like, but if that's the technical sense in which you're using the phrase ad hominem, then what you're saying is exactly right. Like since this argument is inconsistent with Orthodox Christianity as is ordinarily understood, it cannot be part of a package of arguments for Orthodox Christianity.
At least according to Wikipedia, I was just looking then, and this comes under valid types of ad hominem, though.
Independent of the belief in personal immortality. We have here, I think, Kevin, a good example of an ad hominem objection.
Here's a clip from Alex Malpass and Adrian Moore.
If you think about the number of events in the future as like equivalent to the number of guests in the hotel, and then as time passes, we're removing an event from the future and putting it in the present. And we can ask how many events are there left in the future. It's the same number of events in the future as there were before that event entered the present. So even though we've taken one away, we've got the same number left. That's exactly the same property. It's adding one guest and having the same number of guests after adding it in. So if one of them is problematic, so is the other.
If the idea of infinity is putting pressure on the idea of an infinite past, then it's going to put equal pressure on the idea of an infinite future. There's no clear asymmetry there that means that one of those is problematical in a way in which the other isn't.
Well, there is a notable asymmetry between the past and the future given a tensed theory of time, according to which temporal becoming is an objective feature of reality. On this view, the past is now actual, but the future is merely potential. Moore seems to be presupposing a tenseless theory of time, according to which past and future are on an ontological par.
This clip's a little bit longer. It's from...
Hang on. This is very strange because on Craig's... So Craig is right that there is... That on A theory, there is an asymmetry between the past and the future, but it's not the asymmetry as Craig has described it. Craig's own view is presentism, according to which past events are not in actuality. Only the present is in actuality, right? Like, according to the presentist, what it is to exist is to be present. And it's, so past things don't have existence. I don't, it's a very strange reply that Craig had there.
Yeah, so this is, I talk about this in my book as well. Other commenters have mentioned this. I think actually what Craig appears to say is that the past is, because past events have been actualized, they are part of the actual world, but don't exist. So I think that Craig needs to give us an account of what it means for something to be actual but not exist, whereas the future both is not actual and doesn't exist, according to Craig. So that's the difference.
You see like a Meinongian or something? I mean, it's like, most philosophers...
Yeah, so Malpass mentioned this, that there are some views where you can make sense of that. I think he mentioned modal realism, but Craig doesn't defend those sorts of views, and he's never really explained himself, to my knowledge, about what it means for something to be actual but not exist.
Right. I mean, most philosophers nowadays endorse...
It's a very odd view, I think.
Most philosophers nowadays endorse what the medievals called the univocity of being. In other words, that being and existence are the same thing, and they're the same thing as being actual, and that there is nothing else. There's just, to put it in quite simple terms, what it means for something to be is just that it's just whatever it is that the existential quantifier expresses.
Isn't there another? Oh, sorry, go on, James. Sorry.
I was going to say, Craig is at liberty to defend any model of existence or actuality that he wants, right? But the point is that it's certainly not obvious or intuitive what he means when he says that the past is actual but doesn't exist. Like that's an odd view that needs a bit of articulation, explanation, and he just doesn't give it. The only time he really talks about this is when he needs to defend this asymmetry between past and future.
Here's another way in which this is very strange, is that in a variety of different places, Craig has said that there is no present simpliciter. There's the present hour, the present day, the present second, and that any subinterval of time has proper subintervals, so there are no instants of time. If that's the view that Craig has, that there is no present simpliciter, but instead various ways of conventionally defining the present, or various ways of picking up the present interval, then I don't understand. If there's no such thing as the present simpliciter, does that mean, and he's committed to the view that only present things exist, does that mean that nothing exists simpliciter? Like, surely that can't be what he wants to say.
Yes, I've critiqued him about this as well. I think it's one of the biggest problems with his Metaphysics of Time. I don't understand how he can make sense of this. In one of his books on time, I forget which one, he talks about how that you can, as you just said, you can subdivide the present interval into parts of it that are past, parts of it that are present, and parts of it that are future, or something like that. But then the question is, well, like, what does that mean in terms of existence? If to be present is simply to exist, according to Craig, then does that mean that you can subdivide what exists presently into parts that don't exist, parts that exist, and parts that also don't exist because they're in the future? Like that, it's really, really bizarre. And other philosophers have commented on this as well, about how to make sense of this. But I don't know why Craig thinks that it's sort of okay to present these sort of half-baked ideas and not develop them in a way that makes sense when it's critical to the Kalam. Craig thinks that presentism is critical for the Kalam to work, but he doesn't seem to have a philosophy of time that can make sense of presentism and is also consistent with the Kalam.
Stephen Puryear has a great paper on this issue.
Isn't the question, and I think that this is something that Malpass raised in his debate with Craig, the question is just, is the proposition that there will be an infinite number of future events true? And, you know, it's kind of irrelevant what the truth makers
we're going to come to that in the video.
Okay.
Coming up.
From Alex Malpass.
And it seems to me that this rests on a mistake, because Craig, instead of focusing on the question, how many future events will there be if the future is endless, to which he answers infinitely many, Craig instead switches to how many future events will have been. And that is true, is always finite and increasing over time and approaching infinity, but never getting there. But its problem is that those two things are compatible with each other. And for one thing, it's changing the subject. If you say how many events will there be, and to answer in terms of how many events there will have been, it's changing the subject. But also, they're both true. I mean, even though there will have been finitely many events, it's also true that there will be infinitely many events. In the infinite future, those two are not incompatible with each other.
Well, I just disagree with Alex here. There will never be an actually infinite number of events. For any finite number you pick, there will eventually be that many events, but there will never be an actually infinite number of events. You can't turn.
That's what Malpass said.
Yeah, and also notice the phrase for any finite thing you pick, right? But that's the very thing that you want to, that he's assuming, right? The point is that, yeah, if you have an infinite line, okay, let's say we put the integers on there, okay, and we go, okay, so we start, let's say we start at 0, okay, pick any number, a million, a trillion, whatever, that will always be a finite distance from the 0 point that you picked, right? But it doesn't follow from that the line is not infinite. So that phrase for any finite point is the key here. That's kind of just assuming what he wants.
It's just an answer to a different question that he keeps slipping into. Like, I understand where he's coming from, and it kind of sounds, you know, once you grasp what he's saying, it kind of sounds like a plausible response, but it's just that, you know, you need to focus on it. Is the proposition true or false that there will be an infinite number of events? Is that a true proposition or false?
Malpass has pressed Craig on this in like when they were talking to each other, and he just kept avoiding the point. He kept talking about it never will be the case that there have been infinite. It never will be the case that there have been infinitely many, praises in heaven or something. Whereas what Malpass is asking is how many praises will there be? And the answer seems that it has to be infinitely many. And Craig, whenever he responds, just keeps changing what he says. And the thing is that it's very subtle. The language is almost the same. And so mostly people won't pick this up. But I predicted this in my initial response. I said that Craig would just do the same thing again because he always does this. He makes it sound like, well, he just said there that he just disagrees with Malpass, but actually he doesn't. Malpass explicitly said, if you listen to what he just said, that it is true that there never will have been infinitely many praises because at any point in the future, between now and then, there'll be a finite number. But that's not the point. The point is how many praises will people make towards God, or how many praises will Craig make in heaven in the infinite future? In the future, and the answer seems that it has to be infinitely many. It seems it can't be any other number if the future doesn't end, right? And Craig just doesn't, and that seems to be on par with the number of past events under the claim that the past was infinite, right? So there seems to be this parallel here that Craig seems to only be able to get around by basically making these sort of verbal performing sort of verbal tricks and not actually addressing the point here. I've never heard him directly address this question. He always changes the phrase of it.
I think there's a comment that. Oh, sorry. Go on, Danny.
No, go ahead.
Oh, there's a comment that Adrian Moore made, which is that you're never going to get to the end of this infinite series, but the fact that you don't get to the end is indicative of the fact that there is no end, right? So of course you don't get to the end, and then Craig seems to be saying, "Well, you'll never get to the end." Well, of course you won't get to the end. It's endless. That's the very definition of infinity.
Right. Yeah.
Yeah,
an endless series where you get to the end, sort of thing. Yeah,
he's demanding that you get to the end, but of course you can't get to the end.
So there's two things I want to say here. One is that so this argument that Alex presents is sort of structurally similar to Cantor's domain argument, right? So I gave that example earlier of like of the sequence of numbers where you start with 1 and you multiply by 1/2 over and over again. If you ask, is there ever a number along that sequence such that there's an infinite number preceding it? And the answer, of course, is no. If you ask how many will there be along that entire sequence, the answer is a countable infinity of them. Now, by the way, the other thing to be said here is that much of what Alex and Wes Morrison have to say in this issue assume that if you have an infinite future, there is no time, an infinite distance, an infinite duration away from us. There are mathematical procedures for adding in points at infinity. So, for instance, something that you do in complex analysis, if there's this construction called the Riemann sphere, where you imagine a plane, and you take a sphere, put it on top of the plane at the origin, take a line from the top of the sphere, extend it down to the plane. That line from the North Pole down to the plane passes through 2 points of the sphere, right? It passes through the North Pole and also another point. That other point that it passes through, that's part of the sphere, it gets mapped to a point in the plane. Now ask, where does the North Pole get mapped to? Well, it maps out to a point out at infinity. Something that's sort of mind-bending about this is if you go off in any direction at all, if you go infinitely far out in any direction, you actually get to the same point no matter which direction you go in, because they all are the point gets mapped from the North Pole. It's sometimes called the one-point compactification of the complex plane. There are other ways of adding in points at infinity, and in fact, there's a nice paper by Richard Swinburne from several decades ago, in which Swinburne argues that the universe could have had a beginning even though the past is infinitely long. It could be that there's a beginning and then a finite portion of time, then an infinite portion of time elapses, and then you have the present after all of that. He's pointing out that that's a conceivable possibility too, and of course you could do that with the future as well. But of course Craig wouldn't like that either. So.
Well, that's interesting for the theological project as well, because I mean, suppose it did, we did empirically find out somehow that the universe was past eternal. Well, then it's like, well, now we've kind of like just falsified Craig's version of God in a sense, and you don't want to kind of couple your theology in that way to something as contentious as that, perhaps. If you're
Craig, there's a blog post that Craig wrote. Where he's asked about some of Swinburne's objections to the Kalam argument. And part of what Craig says is that Swinburne effectively endorses an empirical version of the Kalam argument, in that Swinburne endorses both premises of the Kalam argument as well as the conclusion. Not for the a priori, like infinity stuff that we've been talking about, but for empirical reasons. And what that discussion leaves out is that part of the reason why Swinburne disagrees with Craig is that Swinburne thinks that it doesn't matter for his theological purposes whether the past is finite or infinite. I mean, Swinburne does think that the past is finite in actuality, because Swinburne thinks that the Big Bang was the beginning of the universe. We can get into that when we talk about like the empirical case later, but it is an important point of disagreement between the two of them. And it's also important to point out, I think, to theists that they don't have to endorse all of Craig's arguments. In fact, they don't have to endorse any of Craig's arguments, but they particularly don't have to endorse any of these arguments that have to do with like infinities and so on.
Infinite into an actual infinite by counting.
Well, Bill, we're halfway through the series. Next podcast, we'll discuss the scientific evidence.
Well, we're halfway through, guys.
Philosophical argument for the beginning of the universe in the second podcast. Today, we're going to look at yet more.
And to embrace. They've also claimed that the Big Bang singularity proves a beginning of time.
Arrives at a state of infinite density at some point in the finite past. This state represents a singularity at which space-time curvature,
along with temperature, pressure, and density, becomes infinite. It therefore constitutes an edge or boundary to space-time itself.
The argument by Lane Craig that the fact that there's that the infinite past is impossible, and therefore that conception of the universe is untenable, is incompatible with their claim that there is a singular point at which the universe originates, because the properties of that singularity are entirely infinite.
Precisely what a singularity is, as John Barrow has forcefully emphasized, is something that involves a kind of actual infinity. For physical reasons, involves a kind of actual infinity. And this is precisely what these very same thinkers said that they were suspicious of. So to put it very bluntly and very crudely, are they trying to have their cake and eat it, accepting an actual infinity in one context, while...
So I actually disagree with these folks here. It's a subtle disagreement, but it's an important one, and I think it's going to be important for the objections that Craig is about to make. So on the one hand, while we have a recording of Craig saying that the singular point is an actual like physical state of infinite density and so on, again, this is a case where he says something very different to other academics. What Craig has argued for several decades now, if you look, for instance, in the volume that he co-authored with Quinton Smith, it's quite clear that the position he takes in an academic context is that what a singularity is not a physical state but an open boundary, and so there's no actual infinite density. I think that that's the correct description of the Big Bang singularity. If it existed, I don't think it did, but if it existed, it would be an open boundary, and so not a state of infinite density. Nonetheless, there's still an argument to be made here that there is an actual infinite involved. Craig likes to say all the time that you can't count down from infinity. But let's do the following thought experiment. Suppose that I had a time machine and I wanted to go back to visit the Big Bang. So I get in my time machine, and my time machine, by the way, is equipped with a bunch of like measuring devices, like a thermometer and some sort of apparatus for measuring the local density of the universe. And I keep on going back and back and back. Eventually I get to what I would see in the surrounding ambient universe is that the temperature would increase, the density would increase. And now you can ask, well, would there ever be a point where the density and temperature ever stop? Is there like a maximum density or a maximum temperature that I ever come to? And the answer is no. That as I approach that open boundary, the temperature and the pressure and a whole bunch of other parameters increase without upper bound. That's what the classical Big Bang model predicts. That's what singular Big Bang models predict. So while there's no state of infinite density, what the universe effectively does on one side of the open boundary is to count down to infinity. For any number you could want to name, we can find some time closer to that, closer to that open boundary where the temperature, the pressure, the density, any one of a whole bunch of parameters has that value. So the universe literally just counts down through all the numbers to get up to or all the positive numbers anyway, to get up to the present.
I mean, I think whichever way you look at it, there's some infinity somewhere that he has to deal with if he's going to say that the singularity implies the beginning of time. So there's no way out of that.
But I think that the argument I just gave is a little more subtle than the one that was officially offered in the...
Well, I think if you're sort of thinking of it in the way that he's put it in the academic literature, but we're replying to what he's putting in the popular media,
and that's fair enough. I think that's what he has. Again, this is a case where he says one thing to popular audiences and another thing that's different to academic audiences.
Right. But
in each case, what he says is problematic, right? So it's like there's a problem either way. Yes, that's right.
Right.
Trying to dismiss it and being suspicious of it in another context.
The initial cosmological singularity is a mathematical artifact of the standard model. I take it to be an idealization. It's dispensable. Cosmologists often cut out the initial singularity so that the universe, though finite in the past, has no boundary point. Some cosmological models, like the Hartle-Hawking model, round off the initial part of space-time so that although the past is finite, it has no boundary point. Having
Okay,
a beginning does not entail having.
Pause this. This is really important. The Hartle-Hawking model has a beginning in imaginary time, right? It does not have a beginning in real time. Now, and you can watch our film that we made with Hartle and Hawking, and they say this explicitly. Now, Craig says that imaginary time is unintelligible. So he can't make this comment, right? He is completely inconsistent. And there's a quote from Aaron Wall, who he said, let's see if I can find it here. He said, the people that have said the Hartle-Hawking model has a beginning, he says, they are lying to you, and I'm telling you the truth. Okay, they weren't really lying, but rather oversimplifying. I'm sure their motives were as pure as driven snow. But the end result of the reader's mind is the same, right? And he says the model doesn't actually have a beginning. So Craig is just, being completely inconsistent here.
There's another thing to be said here, which is that when Craig talks about God's relationship to time, this notion that like God comes into time from being in a non-temporal state, in the papers where he argues that stuff, which is different than his Kalam papers, he uses the Hartle-Hawking model as a way to establish that it makes sense to say that something could be in a non-temporal state and enter into a temporal state. So in that context, he says that it's beginningless. But the other thing to be said here is that I actually have a slight disagreement with many other folks about why the Hartle-Hawking model is beginningless. The way that I would put it is like this. I think that if something is such that, suppose there's an aspect of something, called this aspect A, that suffices for that thing's existence, but that would have existed even if time had not. So this thing is a non-temporal aspect of that. So A is non-temporal. It suffices for the existence of whatever entity we're talking about. So long as I think as an entity is like that, then I think the entity is beginningless. And I think Craig agrees with this, because I think what Craig wants to say is that in some sense, I think that what Craig wants to say is that God would have existed even if time had not existed. And this is part of the explanation as to why God is beginningless. There's a family of cosmological models, quantum cosmologies, in which what's fundamental is the wave function of the universe. I think that on those models, the wave function is supposed to be more fundamental than time, in the same way that on Craig's theology, God is, well, I guess not quite the same way, but in an analogous way to the way in which on Craig's theology, God is supposed to be more fundamental than time. So that this is the real explanation, on my view, as to why this family of quantum cosmologies are beginningless, because they say that the physical world is not fundamentally temporal. And so long as the physical world is not fundamentally temporal, then since non-temporal things are beginningless, the physical world would be beginningless.
And therefore not needing a cause.
Yes, exactly. Well, unless Craig wants to change his mind and say that God requires a cause.
Right.
It depends which version of Craig is going to change his mind. Is it the popular audience Craig, the academic philosophy Craig, or the theology Craig who believes different things? Yeah.
Yes, this is a point that I've made before, and I mean others have made as well, that essentially what Craig claims is that God God exists, sans the universe in a non-temporal way, but then when he created the universe, he came into being with time and came into being in a temporal form. So the question is, if that is sort of a thing that can happen, then why can that only happen with God? Why can't there be other types of entities, like some sort of quantum wave function or something, that exist non-temporally at some, well, one can't say some time, but exist non-temporally, and then also have a temporal sort of mode of existence, if we want to use that phrase. I think that that's open to the physicalist as well, that something like that happened, and I don't really think Craig has an in-principle objection against that. He just doesn't think it's as plausible.
I think it's quite important that there's a developing literature in philosophy of physics that we might call in which the view that people are working on is something we might call it something like space-time reductionism or space-time emergentism. The view that that the physical world is more fundamental than space and time, and that space and time are somehow a less fundamental phenomena. And any view like that the physical world itself is going to be beginningless. I think. I mean, I think that it's having a beginning requires something to be fundamentally temporal.
A boundary point. In any case, the singularity doesn't involve infinite quantities in the Cantorian sense, an actually infinite number of things. As Quentin Smith points out, it's really a case of division by zero. You have the mass of the universe over zero volume, which yields infinite density.
Here's the next clip where the narrator says she thinks that there's another problem with the Kalam cosmological argument.
A further problem for the Kalam argument is that it assumes an eternal universe would have had to traverse infinite time in order to get to a unique now. But in relativity, there is no such notion. Time is relative. In order to tackle this, Craig appeals to what is known as the neo-Lorentzian interpretation of relativity, which does restore a unique sense of now.
Oh, Kevin, this is another red herring. Einstein's original formulation of special relativity involved ordinary three-dimensional objects enduring through time. It was wholly compatible with a tensed theory of time and temporal becoming. The tenseless space-time interpretation of Hermann Minkowski came a few years later. The soundness of the Kalam cosmological argument does not stand or fall with a neo-Lorentzian interpretation of relativity theory, even though that is my preferred view.
Next clip from Carlo.
Here. So, I mean, I think Craig is being a little bit disingenuous here because Craig thinks that creation ex nihilo, as well as several of the arguments he uses in support of the Kalam, that all of these things do require the A theory of time. And he has written entire books arguing that the only sensible way that an A theorist can respond to relativity is with neo-Lorentzianism. So, for instance, Craig has written against the Kit Fine's fragmentalism and other sorts of views that try to reconcile relativity with A theory. He thinks that those other ways of doing so are incoherent, and that it's his particular version, neo-Lorentzianism, that is really the way that that A theory should be squared with relativity.
There's two quotes that I think will be helpful here, both by Craig, of course. One is a start quote. It is only on a tense theory of time that things literally come into being. And the next quote is, my reason for thinking, for example, the universe requires a cause is because it came into being at the first moment of its existence. So, of course, how does he get the tense theory of time, as Daniel just pointed out, by having the neo-Lorentzian interpretation? So when he's sort of trying to brush it off, say, well, Kalam doesn't need it, he's being very disingenuous in my opinion.
Yeah, I mean, and the question then is how does one interpret the results of special relativity without neo-Lorentzianism? I think that actually, I mean, you might know more about this than I will, Daniel. But for what Craig just said there, that about Einstein's initial interpretation, my understanding is that gives you a relativistic notion of existence, right? Because you have to say that. Well, yes, there's no, you sort of reject the four-dimensionalism approach, but then what exists is sort of relative to your reference frame. And I don't think that's going to be acceptable to Craig either, which is precisely why I think he adopts neo-Lorentzianism.
Yeah, I mean, and to be fair, to that view, there's a sense in which, even on Craig's view, what exists is relative. Not relative in the way that it is on that particular version of A theory, but it's relative to what time you're at. Right. So one of the ways to sort of see the intuition behind this notion that reality could be irreducibly relative is to point out that on presentism, the whole of reality depends upon which time you're located at. In this version of A theory that we're considering, is one that Craig rejects. It buys into the notion that space and time are going to be unified together. And so the reason why you get reality being in some sense relative is because it's the notion of a present moment has disappeared and it's been replaced by the space-time point at which you are located. And so then reality is going to be relative to that space-time point. There are different versions of this that people are still pursuing. So Kit Fine's fragmentalism is a major way of pursuing this. Some people, like Faye Dowker, apparently, her version of causal set theory is quite similar to this idea. But I think, you know, a lot of metaphysicians, and not just Craig, are going to say that this view that reality is relative is sort of bonkers. I mean, it's a lot of philosophers really dislike strong forms of subjectivism or solipsism. And by the way, you know, another thing that's very strange about it is that if reality is like relative to which space-time point you happen to be located at, well, notice that like your brain, let alone your physical body, is occupying many space-time points. In fact, you know, an infinitude of space-time points. And so, you know, what's real according to like some of the points in your brain is not what's real relative to other points. That's a very strange implication, right? So it seems like a lot of people are going to want to say that that sort of view that way of reconciling a theory with relativity should be ruled out. And what that then leaves you with is either just straightforward realism about relativity, like Minkowski's view, or a kind of anti-realism about relativity, which, as I pointed out before, has this problem that it leaves completely mysterious why Lorentz invariance has been such a useful heuristic in developing, such a useful criterion for developing other physical theories. I've never really seen him address this. Like, why is it that Lorentz invariance gives us our most successful quantum field theories? You know, the most precisely valued number in physics is the anomalous magnetic moment of the electron. That's a number that's predicted to a tremendous tremendous order of magnitude by quantum electrodynamics. But that's a theory that assumes the truth of Lorentz invariance. Neo-Lorentzianism is incompatible with the literal truth of Lorentz invariance. So why should this number come out to have this value? I mean, Craig, as far as I can tell, has given us no explanation for why that should be.
Oh, Rovelli.
Discovery with Copernicus is that the Earth is not the center of the universe. Well, but you can always rethink the Earth as you can imagine that you can add a center. Nobody prevents you from doing that. You just complicate life for yourself. And it's the same for special relativity. You can add a preferred reference frame. It's not visible, it's not detectable, but you think it's there. That's the Lorentzian, the neo-Lorentzian interpretation of special relativity. What we gain? The only thing we gain is that we can do the new physics with old mindset. But I think we should adapt our intuition to the new physics, not adapt new physics to our intuition, right? When we discover the Earth is round, that's up, that down, but if you're in Sydney, it's the other way around. Or you can think, yeah, but in reality, there's a true up and a true down. You can, but what do you gain? I mean, you have to adapt your intuition about that down to the discovery, not the other way around. Physicists are not particularly keen about neo-Lorentzian interpretation of special relativity. Having said that when you go to general relativity, have a neo-Lorentzian interpretation is much harder, because in special relativity, you just pick a frame and in general relativity, there is no global frame. I think everything in physics, modern physics is telling us there is no preferred frame, there is no preferred time slice, there's no preferred time.
Notice that Rovelli admits that we can, with Lorentz, add a preferred reference frame. There is no scientific problem here. Rovelli's only objection is, what do we gain? Well, for my part,
eternal life with Jesus.
So look, it's just false that there's no scientific problem here. So there's two categories of empirical arguments that one might pursue against neo-Lorentzianism. The first family are empirical arguments based on data that we currently have. And the second family are empirical arguments based on data that we may have in the future but don't have yet. And those arguments are important to consider because it is sometimes claimed that relativity and neo-Lorentzianism are completely empirically indistinguishable. Well, the fact that, you know, if there could even in principle be data that distinguishes them, even if it's not data that we presently have, that would show that it's just false that they're empirically indistinguishable. So as far as the data that we currently have, the first thing to be said here is that general relativity is an empirically adequate theory. Now, there's no known neo-Lorentzian alternative to general relativity. The fact that general relativity is empirically adequate, that is to say, the fact that that all the predictions that general relativity makes turn out to be correct, The fact that that's so is at least logically compatible with neo-Lorentzianism. But the mere fact that it's logically compatible with neo-Lorentzianism doesn't mean that it's expected on neo-Lorentzianism, right? Like, I mean, general relativity was developed as a further development of some of the same ideas that went into special relativity. If it turned out that that neo-Lorentzianism was true instead, you might have expected that when you turn to developing a theory of gravity that comported with relativity, that it wouldn't follow the same principles of special relativity. But in fact, that's not what we find. We find that general relativity is empirically adequate, and that should be surprising if neo-Lorentzianism were correct. The other piece of data that we currently have is that Craig, Craig's motivation, which he was about to maybe I paused prematurely, but the motivation for neo-Lorentzianism, for his adoption of A theory that he was about to explain, is that we have the experience of the passage of time. That experience is supposed to be explained by the truth of A theory. The problem, however, is that so Craig uses a whole bunch of machinery, including this thing called the conformal mean curvature foliation and cosmic time, which we'll get into later, to try to describe the way in which absolute time relates to the physical world. And the problem is that if that's the correct description of absolute time, then in fact our experience of time is illusory. To put that in another way, notice that on neo-Lorentzianism, there's only one frame in which things are not, in which clocks read the correct time, right? Like there's only one frame in which clocks read the absolute time, and every other frame, clocks read a systematically incorrect time. So you can ask, are we in the frame in which clocks read absolute time? Well, no, because we're not at rest relative to the expansion of the universe. And in fact, one of the pieces of evidence that Craig tries to give, incorrectly, I think, but anyway, part of the evidence he tries to give for this view that there's an absolute reference frame is, or that there's absolute rest, is that we're moving with respect to the cosmic microwave background. Well, fine, but if that's a kosher argument, then we're not at rest with respect to the universe's expansion, and the reference frame that we occupy is not the reference frame that corresponds to absolute time, which means that time as we experience it is not absolute time, and in fact our experience of time is systematically illusory. Okay, so that's the data from the data that we currently have. What about the data that we're going to have in the future? Well, there's a feature of space-time, relativistic space-times, called global hyperbolicity. I don't necessarily want to get into that. We can get into that if you want to get into what exactly that feature is, but the important point is that on any plausible version of neo-Lorentzianism, space-time would need to be globally hyperbolic. We know that there are some space-times that are solutions to the Einstein field equations that are not globally hyperbolic. If we discovered that we occupied one of those space-times, like for instance, there was one that was discovered by Kurt Gödel, the same Gödel that gave us the incompleteness theorems. If we discovered that we lived in a space-time like that, well, then we would know that neo-Lorentzianism was false. Or consider an argument that Michael Lockwood puts forward in his book, The Labyrinth of Time. One of the things he points out in that book is that the particular foliation of space-time, that the way in which, so a foliation of space-time is the way that you cut space-time up into times. And of course, Craig needs that if there's going to be like an absolute time. The way that Craig proposes to do that is based on something called the conformal mean curvature foliation. And the if black hole decay is real, so if Stephen Hawking was right, that black holes really do decay, and if we ever had empirical evidence of that, then we would also know that we do not occupy a space-time that can be foliated according to the conformal mean curvature. And so if we had evidence that black holes actually decay, then we would have evidence against Craig's favorite form of neo-Lorentzianism.
And again, I would say that Craig presents the Kalam as being consistent with mainstream physics. I would say it's pretty mainstream physics that black holes decay. Like, you're going to be in serious trouble.
I mean, a lot of physicists...
the way what's going to happen if they don't decay is that you're going to lose, some of your conservation laws and everything. There's a lot that's going to go out the window that Craig is actually relying on.
Right, and there's all sorts of consequences for what exactly happens in particle detectors or in cosmic rays. I mean, there's at least some level of evidence that black holes do decay, because we don't find like macroscopic black holes accreting matter and becoming more than microscopic. They don't pose a problem for us, even though presumably microscopic black holes are out there.
So in terms of sort of theory choice here, there's a lot of problems that you're highlighting, but one of the things that Craig seems to be saying is that, well, also this seeming of time passing, right? My theory is needed to account for that, but other theories can't account for that. Do you want to say a little bit about, what competing models would have to say to this seeming of time passing?
Well, so here's one thing that, so there's a philosopher named Prosser. I forget his first name, but his last name is Prosser, Prosser. He defends B theory, a tenseless theory of time. And what he points out is the following. Suppose that I have a sequence, or just consider a sequence of brain states. These don't have to be brain states. They can be mental states or soul states or whatever states. But a sequence of mental states. That sequence looks the same inside of a space-time block as it would on presentism, right? In other words, there's nothing that like makes a change to your mind in virtue of time passing that wouldn't be there if the tenseless theory of time were true. He develops that argument further, but what's that?
Is there an analogy with Wittgenstein's comment? He asked Elizabeth Anscombe, why do people believe the sun went around the earth? And she said, well, it looks like it does. And he replied, but what would it have looked like, if it was the other way around? It would look the same.
Right. Yeah. So Hugh Price, in the beginning of his book, the name of Price's book escapes me right now. But Archimedes' point is in the title. But anyway, towards the beginning of that book, Price draws this analogy with that quote from Wittgenstein. Now, one of the things people have pointed out is that, well, I don't want to get too much into this, but there's people gave objections to the particular way in which Price formulated that argument there, and what Prosser is doing is further developing the argument in a way that responds to the critics that have replied to Price. But anyway, the point is that there's a literature that's been developed over the last couple decades on this point that it's our world would appear exactly as it does if a tenseless theory of time were true, right? It's incumbent on the eighth theorists to tell us how exactly the passage of time shows up in our experience. To my knowledge, no one has successfully done that.
I think when you... Oh, sorry, James, go ahead.
Talking about the passage of time, I am happy to go longer than 4 hours if you want, because this is just too interesting.
Okay. Did you have something to say, James? What you just unmuted?
Yeah, so I raised this criticism in my book as well, where Craig says that our experience of temporal passage is evidence for a theory, but I don't really think he explains why. As sort of Daniel was pointing out, it's not clear what the experience would be, or particularly when you consider that the difference between a tensed and a tenseless theory, particularly under presentism, is just the status of the past and the future. I mean, everyone agrees the present exists, right? So the question is, does the past exist? Does the future exist? But we never experience the past or the future. I mean, we have memories of the past, but that's not the same as experiencing it. So it's sort of not clear to me how Craig thinks that our non-experience of the future and non-experience of the past is evidence that they don't exist. Like that doesn't really make it. That's never really made sense to me.
I mean, so suppose suppose you had a device that what this device does is it senses whether or not time is passing. And it turns on a light if time is passing. Now, if that device was active in the past, what do we say about it? Do we say that the light was that it, so I mean, suppose that I mean, maybe the easiest way to do this, to think about this, is like if, say, like growing block theory was true. So in growing block theory, the past exists, the present exists, and not the future. And the block of the past is growing. That's what the passage of time is supposed to be. Suppose that the we notice that the light on the device was on at some time in the past. What do we say about that, the state of that light in that part of the space-time block at our position in the present? If we say that the light back there is on, well, that means time is passing back there, but that can't be right. If we say that the light was off, well, that means it was off when time was passing through that moment. That can't be right by construction. So there's something very peculiar about this notion that you could have something that detects the passage of time. But I like the way that you put it, where like everyone agrees that the present moment exists, and everyone agrees what the contents of the present moment are. And so long as everyone agrees on that, then everyone agrees on what sort of experience is in the present. And so there's no, like, everyone agrees that on the tenseless and non-tense theories of time, you have the same experiences there embedded in the space-time block.
I think maybe the sort of issue here is that when people think of a kind of B theory, they tend to kind of conceptualize it as this kind of view from nowhere, looking at some big kind of static object. And then you ask the question, well, why am I experiencing, now at this point, right, in that kind of block? And then, but it's sort of a malformed question in a sense, because it's like, well, when else would I be experiencing,
Right.
other than at any point that you're asking that question? Of course you're experiencing it now,
I mean, that view from nowhere, one of the things that's very odd about it is that it's almost like what the B theory, one of the things that B theory isn't consistent with is the idea that you could be positioned somewhere where you look at the whole of time at once, right? Because the whole of time isn't at one instant. It's at a series of instants, and that's still true on B theory.
Our gains are metaphysical, a more credible view of the world than that offered by the tenseless spacetime interpretation. But there are as well some prominent physicists like J.S. Bell, Franco Soleri, Antonio Valentini, and others who think that scientific gains are to be had as well. In particular, the so-called Bell inequalities seem to require a preferred reference frame. If anyone's interested in this, I'd recommend my two books, Time and the Metaphysics of Relativity, published by Kluwer Academic Publishers in 2001, and then my and Quentin Smith's anthology entitled Einstein, Relativity, and Absolute Simultaneity, both of which activity theory.
More from Carlo Rovelli in this next clip.
Pause. So I have a quite long paper replying to Craig's neo-Lorentzianism. The unpublished version was like 50 pages. I think the published version was like 39 or 40 pages. So a few things to be said here about the supposed scientific gains. So in order for Craig to say that there's scientific evidence that the past is finite, he needs to identify some physically measurable parameter that is the duration of past time. We're going to see, we haven't gotten to cosmic time yet, but when we do get there, I'll talk about what the problems with that proposal is. But the reason I wanted to bring this up now is that he brought up Valentini. Valentini thinks that the right parameter for absolute time is a parameter called the York time. Never mind what the York time is exactly. The point I want to make about the York time is that the York time, so in a singular Big Bang model, what the York time does is that it maps the singularity to past infinity. So if York time is the right parameter for absolute time, then even if singular Big Bang cosmology were the correct description of the universe, then the universe's past would be infinite. And that, in fact, is what Valentini's view is. In fact, one of the people that I corresponded with when I was writing my paper on neo-Lorentzianism was one of Valentini's grad students. on this exact issue and on some related issues. But it's Craig needs to tell us why his choice for the parameter describing absolute time is the right choice, and that is not something he's ever, as far as I can tell, successfully done.
Just to comment on the presentation in the video here as well, I mean, obviously, Craig can't respond to absolutely everything that's said, and we can't respond to absolutely everything that Craig said or has ever said. But I do sort of think that within the context of kind of responding to these objections, just kind of like pointing to books and saying, well, look, I've dealt with this in the past. I mean, we could kind of do that as well and say, and this guy's, dealt with you here in this book. And the point is, I suppose, in these public engagements, rather than to just point to things and say it's over there in this kind of big tome, is to actually, put some kind of meat on the bones and articulate it in response to what's been said by the person that you disagree with.
Right. I guess there's one other point that I forgot to raise in response to what Craig said there. So he said that there are scientific upshots in terms of interpreting the violation of the Bell inequalities. So it's true that on Craig's favored way of resolving the violation of the Bell inequality. So Craig is a Bohmian when it comes to quantum mechanics, and Bohmianism has an absolute time parameter in there. That's part of the way that Bohmianism works. And so in that sense, Bohmian mechanics has a nice relationship with Neo-Lorentzianism, which I think is one of the reasons why Bell himself was interested in Neo-Lorentzianism. Probably maybe not the only reason, but one of the reasons. And but nonetheless, there are other interpretations of quantum mechanics. So, my favorite interpretation of quantum mechanics is the many worlds interpretation. And in the many worlds interpretation, the violation of the Bell inequalities has a completely different explanation that has nothing at all to do with there being like some absolute reference frame or something like that. The many worlds interpretation is entirely consistent with orthodox relativity, with the Minkowskian interpretation of relativity.
There's one other point I want to make. So Nihaya Afshodi, who's in this video, has worked on a model of cosmology called the biothermal Big Bang, and it plays with ideas that restore the ether. But in doing so, it undoes the singularity, or at least it becomes more like a coordinate singularity. Can't really be used to defend the beginning of time. So when you start playing with these ideas, you've got to decide, well, what else follows? What else is going to get undone? And I think, Craig is relying on ideas that have the symmetries of relativity, but then he wants to sort of deny them as well.
Craig has suggested there is a universal clock that gives us a unique now. That is cosmological time, the time since the Big Bang.
Cosmic time is the same for every hypothetical observer in the universe, regardless of his state of motion. In other words, cosmic time is a kind of reinstatement of Newton's absolute time.
Well, cosmological time is a fake. Why? Because matter, gravity slows time. So inside the galaxy, clocks go slower than outside. The point is there are many different clocks in the universe, which they don't agree with one another, and there are many times in the universe which don't agree with one another. The idea of a cosmological time is just one arbitrary definition of an average, but I can give a different definition of an average.
For shame. Rovelli knows that the slowing of clocks in a gravitational field has absolutely nothing to do with the time parameter that measures the duration of the universe. Cosmic time is not arbitrary, but rather it charts the evolution of so-called hypersurfaces of homogeneity.
Here's our next clip, Bill. And
so if we can, again, we have to distinguish two different things. We have to distinguish a foliation of space-time from the parameter that we use to label that foliation. So foliation is a way of cutting up space-time into surfaces that you might call like presence or instance or something like that. In classical models of the Big Bang, what those models assume is that the universe is homogeneous and isotropic. If you take an average of the distribution of matter in large enough scales, then matter looks approximately isotropic and homogeneous, at least if you cut up space-time in a certain way, according to a certain foliation. But now there's another question. How do I label that foliation? One way that you can label that foliation is with the cosmic time, but another way of doing so is with the York time. makes one choose one as opposed to the other? It's not clear why his absolute time should be cosmic time as opposed to York time. So I want to consider a view that J. Brian Pitts and co-authors have offered in a variety of papers. Richard Feynman actually offered a similar view as well. They propose a kind of non-standard interpretation of general relativity. It's not an interpretation consistent with A theory. They're not doing the project that Craig is up to, but there's an analogy between the project that they're up to and the project that Craig is up to. So on their project, what there is fundamentally is a Minkowski or flat spacetime. And then we populate that Minkowski spacetime with a gravitational field whose effect is to mimic all of the observational consequences of curved spacetime that we find in general relativity. So we effectively then have two spacetimes, right? Like the fundamental Minkowski spacetime, and then the effective general relativistic spacetime that is actually just apparent and not real. So that's the model. Now, for the purposes of doing metaphysics, what we actually care about is the Minkowski spacetime. That is the more fundamental spacetime. Since on that interpretation, the general relativistic spacetime is only an appearance. Thus, when we ask about the age of the universe, what we should really need to ask about is the age of that fundamental spacetime and not the age of the effective general relativistic spacetime that only exists as an appearance. Now, as Pitts' co-authors argue, for a variety of reasons, according to that more fundamental spacetime, past time turns out to be infinite, even though past time is measured by the apparent spacetime is not infinite to the past. There's a structural similarity between the view offered by Pitts and co-authors and the neo-Lorentzian view defended by Craig and Sinclair. What Craig and Sinclair propose as an alternative to general relativity is that there's a fundamental Newtonian spacetime and a field of some kind whose effects are to mimic the effects attributed to a general relativistic spacetime. So we again have two times, right? Like the more fundamental time in the Newtonian spacetime, and then the less fundamental, merely apparent time. And so there's correspondingly two answers for the age of the universe. The universe's age according to the fundamental Newtonian spacetime, and the age according to the non-fundamental and merely apparent general relativistic spacetime. And the for the purposes of doing metaphysics, we care only about the age according to the fundamental Newtonian spacetime. According to neo-Lorentzianism, the fundamental Newtonian spacetime is completely unobservable. Right? The whole point of the theory is to save all of the observational consequences of relativity and to hide that fundamental Newtonian spacetime from any observational consequences whatsoever. So the only reason we have for thinking that there, So the only reason we have for thinking that there is a fundamental Newtonian spacetime has to do with our experience of the passage of time and with the semantics of tenses, none of which tells us anything about the universe's age. Given that the fundamental Newtonian spacetime is unobservable, what reason then could we have for thinking that the universe is finitely old? Consequently, neo-Lorentzianism turns into a radical form of skepticism and scientific anti-realism, completely incompatible with determining the universe's age by way of empirical arguments. So if this is the route that Craig wants to pursue, he's stripped away any ability that he would otherwise have, as far as I can tell, for appealing to empirical cosmology.
Yeah, I mean, and I think Craig has to essentially be a non-realist, particularly about, an anti-realist about like interpretations of general relativity, because it's just so hard to account. I mean, the notion of presentism doesn't really fit with the idea that space-time is a four-dimensional manifold. And the point about coming back to the cosmic time point, which I think Daniel sort of mentioned this, but just to sort of clarify and emphasize that cosmic time is not like the sort of objective reference frame that Craig wants it to be, or seems to think that it is. It is. I think there's a confusion here. It is true that cosmic time is not relative in the sense that everyone agrees on what cosmic time is, but what it is not is a preferred reference frame. And And that is what Craig seems to want it to be, right? In arguing that, I mean, he said this before. I don't know if he said it in this specific video, but he says that general relativity restores an absolute reference frame or something to that effect. He said this, but it just isn't true, right? That there's still a plurality of reference frames, none of which is like the correct or the true one according to the standard interpretation. Cosmic time is a way essentially to measure the age and expansion of the universe, which is very useful for us, but it's not some sort of objective preferred reference frame.
I mean,
would it be right? Oh, sorry, go ahead.
So just for the sake of viewers who might be lost about what exactly cosmic time is, cosmic time. So if you imagine the expansion of the universe, and if you had, so if you have galaxies that are at rest with respect to the universe's expansion, so these are, we say that they're co-moving with the expansion, and if you had clocks on each of those galaxies, time as measured by those clocks is cosmic time. But again, sometimes theologians will distinguish between God's time or metaphysical time on the one hand and physical time on the other. I mean, so those are the terms that Alan Paget uses, for instance. And one way to see the real trouble here is that if Craig wants it to be the case that metaphysical time or absolute time, God's time, is somehow observable, he needs to tell us why we should pick out like this particular physical parameter, like the time as measured by clocks that are in galaxies that are at rest with respect to the universe's expansion, like why that should be what corresponds to absolute time, particularly since the whole point of Neo-Lorentzianism is to make the absolute time completely inaccessible to us by way of empirical observations.
And what if I leave the galaxy? And isn't my clock going to run at a different rate?
Yeah, so what Neo-Lorentzians would say, so if it turned out that clock time were absolute time, and now you do this thought experiment about like leaving the galaxy, what they would say is that your clock is now reading the wrong time. They would say that there are forces acting on your clock that distort the time that you measure. There's a really nice thought experiment from Poincaré for understanding how this is supposed to work. So Poincaré imagines a spherical world. So we're imagining creatures that live inside of the sphere, and the laws of physics of their world are such that when they approach the surface of the sphere, they shrink in size. So everything, any object inside of this world, when it approaches the surface of the sphere, shrinks. And if it could get to the surface of the sphere, it would have zero size. So according to the rulers that they have in that world, it looks like the edge of their world is infinitely far away, even though it's only finitely far away. That's a world in which the forces that operate in that world hide the geometry of the world from them. What Neo-Lorentzians are proposing is that there are forces that conspire in our world to make it appear as though relativity is true, when in fact it's not. And so just as those creatures couldn't measure the true size of the world they inhabit, so too it's difficult to see how, given a Neo-Lorentzian view, we'd be able to say like how much past time there's been.
I'm muted, sorry. In terms of time, how, like, or in the ordinary sense, how are you both doing for time, by the way? Are you both okay? I'm just thinking whether I should skip parts of this video or just play it through from where we're at.
I think I'm good. Yeah, when we get to the end of part 3, if we could pause for an intermission so I can use the bathroom.
Bio break, yeah, sure.
Yeah.
Senator Lincoln makes an appearance here.
I don't think anybody believes the universe started off with a singularity. That just tells us that Einstein's classical theory of general relativity breaks down. So that classical theory of gravity doesn't apply when you get to very high energies. So it's replaced by some quantum theory, consistent quantum theory of gravity. String theory is a candidate.
Standard Big Bang cosmology, which was a hot Big Bang, right? You start with a very hot, dense universe, and which begins at singularity. So that picture, I don't think anybody believes.
Right. So what becomes of the earlier objection that the singularity involves an actual infinite? I guess that wasn't really a problem after all, was it?
Okay,
as I said before, the beginning of the
let him finish, and then I'll come.
Universe doesn't require a singular boundary point.
So this is extremely disingenuous again. Craig has appealed to the singularities to establish a beginning of time, right? Here's another quote, right, in case you didn't like the one we had in the video. This is, he said, when the expansion is coupled with the 1968 Hawking-Penrose singularity theorem, it leads via a time reverse extrapolation to a universe which began at a point in the finite past. So what we're pointing out here is that no one believes that this singularity is real. It's going to be replaced most likely with a quantum theory of gravity or maybe some other effect. And so therefore the question of whether the universe is a beginning is an open question. So what we're doing is pointing out that people don't believe the pillar that he put the Kalam on, right? And now he wants to just take it away and say it doesn't matter. That's completely disingenuous. He used this as evidence as a beginning. And we're saying it's not evidence for a beginning.
In one of the papers that Craig and Sinclair co-authored, I think maybe their 2012 paper. Anyway, they say that they don't think that there was a singularity, but that there's going to be a future quantum gravity theory that needs to correspond to that singularity. I mean, and this is just a totally bizarre view for them to take. So, they, on the one hand, they admit that general relativity is not our final theory of space-time. We're going to need a quantum gravity successor theory to our current, to general relativity as we currently have it. On the other hand, they insist that whatever that theory is, that it will replace a singular beginning with something else that nonetheless involves a beginning. But there's no reason to think that. I mean, one of the things that's really important to understand, that I really hope viewers bring away from this discussion, is that a beginning of the universe is unobservable. That doesn't mean that it's that empirical science has something to say about it. Empirical science has tons of things to say about all kinds of unobservable things. So for instance, I can't see electrons with my naked eye, but I can see the effects they leave in a cloud chamber. But how do I make the inference that there's an electron that left that trail in a cloud chamber? Well, I do that in virtue of having a physical theory that allows me to interpret the observations that I make. So the way to infer a beginning, similarly, is to look at the effects that we observe, conjoin that with a physical theory, and that way be able to infer that there was a beginning. The problem with these singularities is that it's exactly the kind of structure that we think, or that most physicists think is, outside of the domain of application of the theory. In other words, there's no reason to expect there to be some feature in a quantum gravity theory to which the singularity is some kind of approximation. Everyone expects it to be that sort of feature to be replaced by something totally different that we don't know what it might be. This has been the case, in fact, ever since people first realized that there were singularities. There's a great book it's a very technical book, but John Ehrman has a book on philosophical issues that are raised by singularities. And in that book, towards the beginning of that book, he discusses the response that Einstein had when people first realized that there were singularities in general relativity. And Einstein's response was to say that he didn't think it was a complete theory, and that here was the indication that it wasn't. The thing that Einstein thought wasn't complete about the theory was that it didn't give us a description of the nature of matter. It left open what the nature of matter was. And Einstein thought that this was exactly the sort of place where we were going to get an explanation that replaces what exactly singularities are. So that idea that singularities are going to be replaced by something else in a future theory has been around for almost as long as we've had general relativity to begin with.
And also, I should add that I had discussions with Roger Penrose, and I said, well, what did you think when you came up with the singularity theorems? What did you think it meant? And he said it meant we found the point where general relativity breaks down. And deNysschen said the same thing. And in fact, even Hawking's early paper said that, although later on he was saying, it proves the beginning, but his early papers...
And if you look at the original Borda-Guth-Vilenkin paper,
yeah,
this is what they say in that paper. And by the way, the other thing to be said about that theorem is that it's all it says is that expansion is that in classical space-times, a universe can't be expanding forever.
Well, yeah, we'll come on to BGB because it's going to come up.
Okay. Yeah.
Here's the next clip.
Many scientists have taken our best candidates for a quantum theory of gravity and analyzed the Big Bang. Models inspired from string theory often show that the Big Bang was not the beginning, and a frequent result is that there was a contracting era that preceded our expanding universe.
There had been an evolution of the universe, which was some kind of mirror image of what happened afterwards. So in the same way as the post-Big Bang era where we live, in our model, will last forever, and I think it also lasts forever in ordinary inflation, okay? For us, because of this symmetry, this duality, also the past is infinite, okay? The future and the past are both infinitely long.
String theory's main rival, loop quantum gravity, seems to show the same thing.
If you reverse the film, so to say, of the evolution of the universe and went back in time, the universe was contracting. And then instead of reaching a zero volume, in fact, when it reached the curvature became Planckian, then new quantum effects come into the picture, and they cause the universe to bounce.
For an examination of string models, including Veneziano and Gasparini's pre-Big Bang inflationary model, as well as Steinhardt and Turok's cyclic ekpyrotic model, followed by an examination of loop quantum gravity models, including Bojewald's cyclic model and Ellis's asymptotic model, see the discussion by James Sinclair in our essay, The Kalam Cosmological Argument, in the Blackwell Companion to Natural Theology. As Alex Vilenkin has repeatedly emphasized, none of these models can be past eternal. In fact,
do you want to just pause it there? Okay, so, I mean, basically what he's saying is, read my book, ignore, let's take loop quantum cosmology as an example, ignore the 4,000 papers that have been published on that model, and just read my article that I co-authored. Neither of you are professional cosmologists. Now,
and it's only one chapter in the book as well. That, like, it's a
right.
tiny,
yeah, but also they just make basic schoolboy errors in this thing. So he said the cyclic model of Bojewald, but Bojewald isn't really associated with loop quantum cosmology. We kind of left the field. The main thrust of loop quantum cosmology follows from Ashtekar and Poplawski and Singh, and it's a completely different approach to Bojewald. I mean, the main people in loop quantum cosmology think Bojewald's approach didn't work. And it's not cyclic. Their whole critique is that, they're criticizing the cyclic model, right? Or there's Ellis had this emergent model which used some of the principles of loop quantum gravity. And so they kind of criticize those too. But in fact, the mainstream loop quantum cosmology is not cyclic, right? It just says that wherever you have a singularity, you'll get a bounce. So if in the future, dark energy was to turn around and the universe would recollapse, then, okay, you could get cyclic behavior. But it doesn't predict that, right? It's just not a prediction of the theory at all. It just says, whenever you have a singularity, you'll get a bounce instead. So their criticism in this is just filled with schoolboy errors. Furthermore, the whole approach in this is just, I think, completely misconceived. What they try and do, I mean, it is kind of clever as a rhetorical device. What they do is they go over sort of models which people can conceive of being past eternal, and they try and find problems with these models. They might look at the literature and find someone that's criticized them, right? But of course, all models of the early universe have problems. That's why we don't have a consensus as which is the right one. We don't know whether it's Veneziano and Gasparini's pre-Big Bang, or whether it's string gas cosmology, which, by the way, they never mention in that, or whether it's loop quantum cosmology, which they get completely wrong. We don't know, right? So, and all of these models, they do have problems, but so do models with beginning. There are problems that people pointed out with the Hartzell-Hawking model. We just don't know. So what they do is they point out flaws or criticisms of models without beginning, and they say, see, we can't establish that these are right. But you can't establish that the ones with a beginning are right either. They all, the issue is up in the air. There's lots of competing models. And so they just sort of cherry pick the problems with the ones that, are thought of not having a beginning, and just ignore the ones. Just say, well, therefore, as a default, we win with the beginning. And that's just crazy. That just doesn't make sense.
It's also worth pointing out that many of these models are, not all of them perhaps, but a lot of them are just toy models, right? They were never intended to be a realistic description of the actual universe. And it's it's just sort of, Craig and his co-author treat these models as if they were like rival metaphysical proposals or something, but that's not the way to understand physical models. I mean, it's like if I if I present a mathematical model of a penguin in which I model a penguin as a cylinder, and then you say, okay, but you know, we know that penguins are not cylinders. Like, you just misunderstood the kind of game that we were involved in, right? Like, it doesn't, that's not the right way to understand what's going on when I offer a toy model of a penguin. And likewise, it's you know, many of the objections that Craig has to these cosmological models to sort of misconceive the kind of activity that's going on when theoretical cosmologists think about these kinds of mathematical models. The other thing to be said here is that, you know, just as Craig can point to his book, I can point to my paper published last year, the year before, in your Katniss, called Big Bang or Double Bounce, where I respond at length to a whole bunch of what Craig and Sinclair do in that book. On particular, you know, on the specific subject of how to interpret some of the cosmological models that Craig and Sinclair are interested in.
Oh, by the way, there's something else I want to mention because it's not in the video. What people should know is that there's also a written version of these videos, and the written version is slightly longer. There's some bits that maybe they cut out. I don't know what happened to them, but there's a bit where he mentions Penrose's cyclic model, and he says, very, very interesting. He says that it does not have a beginning, but it has alien concepts. Now, we made a video. He was asked on this question a week, what would happen to the Kalam if CCC was right? And he goes, well, CCC has a beginning. It's two universes. In fact, I've got the quote here. He goes, so you have, so to speak, twin expanding universes coming out of a common origin point. So they do not have one universe chronologically prior to the other. Rather, they both share a common beginning before which there is not anything. And so you just have a sort of branching multiverse. Now, we put that to Penrose. He said that's totally wrong. Then Craig put a whole I don't know how long, a whole podcast responding, saying, no, we're right. And then we went back to Penrose and his colleagues and they explained why he was wrong. And now he's sort of saying, he's conceded that it does have a beginning, right? Now, that's big. If you're going to do that, you should put a correction somewhere, make it clear that you've misled people and that you were wrong. But he hasn't done that. He sort of sneaked it in with this thing that he, you know, no one's probably going to notice. But, you know, in fact, Daniel wrote a whole paper saying that these models do have a prior time. They're not coming from this singular point. And he's just sort of sneaked it in. I think that's really, really poor. So another point to make. But then just going back to this notion of what do these models do? Let's to take cosmology again. The idea is that you're replacing the singularity with a bounce. Now, the whole point, why is this relevant to the Kalam, is because he's using that to prop up, right? He's using this as the evidence for the beginning. And what we're doing is taking away that evidence. We do not have to prove that the universe is infinite in the past as skeptics of the Kalam. That we do not need to do that. And I don't even say that the universe was eternal in the past. I have no idea. It might be, it might not be. What we have to do as skeptics is to take away the props that the Kalam stands on. And that's what these models do.
The central thesis of my dissertation is that we do not know whether the past is finite or infinite.
Right.
Or, I mean, really what the thesis is we don't know whether the universe had a beginning. And the, but yeah, it's, by the way, the paper that you mentioned, in which I cover Penrose's cosmological model, is the Big Bang or Double Bounce paper.
Craig's, this was sort of mentioned, but again, I just want to emphasize and draw this out a little more clearly. In my view, Craig's entire approach here is fundamentally wrong, like in that chapter, for example, which is to take a set of models that attempt to describe the beginning of the universe and point out problems with them. Anyone who knows anything about this field knows that every one of these models is going to be flawed because we don't have a model that reconciles general relativity and quantum gravity in the way that we would need to explain the beginnings of the universe. So obviously we don't have a fully acceptable problem-free model of the origins of the universe. That should come as no surprise. Of course, Craig only focuses on the problems with the models that he doesn't like, not the ones that are consistent with his view. But so there's that part of it. But the broader issue is, why do we need a scientific model of the beginning of the universe? Craig is making a philosophical argument. You don't need a scientific model to substantiate a philosophical point. We could just come up with whatever philosophical model we liked, as long as it doesn't actively contradict the science. That would be perfectly fine. Craig doesn't have a scientific model of the beginning of the universe. He just says God created it. That's not a scientific model. If that's fine for him to offer as an explanation, why can't the naturalist or the atheist or just the skeptic offer any sort of metaphysical type hypothesis about the origins of the universe that's just consistent with the data? Craig seems to be inconsistent, demanding that they have problem-free scientific models, but of course he doesn't have one of those either.
Stalking course one.
Yeah, that's an example of that.
I keep misstating the name of my paper. The name of the paper was Big Bounce or Double Bang. But anyway, I just wanted to get that out there.
None of these models can be past eternal. In fact, it makes me wonder, Kevin, why didn't they ask Vilenkin about the viability of these models? Makes you think.
Exactly.
Well, why didn't you ask him, Phil?
Well, who cares what Vilenkin says? I don't understand. Is Vilenkin God?
Yeah, I mean, well, why doesn't he ask Guth whether the universe can be past eternal? Why doesn't he ask Penrose whether the universe can be past eternal? I mean, yes, it's certainly true that Vilenkin has raised objections to contracting universe models. He doesn't say they're ruled out. He said they're made. We did ask him, and we put it out in a video, right? That video has 150 something thousand views, more than twice as many as this Kalam video has. We're not hiding his views. We also summarize that view. The point is, other people disagree, right? And he just keeps going back to Vilenkin as if, as you say, James, he's like the god of cosmology. He's certainly a respected cosmologist, no question about that, right? Although the main thing that he's done is come up with the idea of a multiverse and the universe from nothing, both of which, right, Craig thinks is not true. So there's kind of an irony there. But the point is, other people disagree, and he's bringing up the people he wants to support his view, and we're entitled to do the same, right? I mean, it's an incredible double standard.
Hasn't Vilenkin said more recently that his view is actually just that the expansion is finite to the past?
Yeah, well, when we interviewed him, he obviously said something very different to what he said in the book Many Worlds in One, where he was like, BGV proves the beginning. He did say that in 2005 in a popular book. Never said it in a peer-reviewed paper because I don't think it would get through.
There's an introductory cosmology textbook that he's come up with, and I believe what he says in that book is just that the consequence of the BVG theorem is just that the expansion is finite to the past, and not and in particular that we don't know whether the universe itself is finite to the past.
Yeah, I mean, when we interviewed him, and you can watch, we've got a much fuller version of the interview with Vilenkin in our film, which is called Multiverse from Big Bang, Before the Big Bang. I think it's episode 9, Multiverse from Nothing. And we have a much longer, it's the whole film is basically us talking to him. And he completely softened his view about the BGV theorem. He said it proves that the expansion had a beginning. It doesn't prove that the universe had a beginning. That's exactly what he said.
Here's our next clip.
With the physics community abandoning its belief in the applicability of the Penrose-Hawking theorem, Kalam advocates switched to a newer theorem, known as the Bordick-Guth and Vilenkin theorem, or BGV. This theorem was developed because the period of rapid expansion, known as inflation, that's believed to have taken place in the early universe, violates one of the assumptions of the Penrose-Hawking theorem, that gravity is always attractive. Inflation is also thought to be eternal into the future, creating an infinite multiverse.
In 2003, Arvin Board, Alan Guth, and Alexander Vilenkin were able to prove that any universe, which is on average in a state of cosmic expansion throughout its history, cannot be infinite in the past, but must have a past space-time boundary. What makes their proof so powerful is that it holds regardless of the physical description of the very early universe. So in fact, the Board-Guth-Vilenkin theorem does imply an absolute beginning of the universe.
I was working with Arvin Borda and Alex Vilenkin to understand what we can learn about how inflation might have started and how far back it could have gone. And in particular, once we realized that inflation could be eternal into the future, it seemed like a very natural question to ask. Could inflation have also been eternal into the past? And what we found was that inflation could not be eternal into the past. What we basically managed to achieve was proving a theorem which says that any expanding region of space-time that has a minimum expansion rate can only go back so far, and not infinitely far. So that means that inflation must have had a beginning. It doesn't really say that the universe must have had a beginning, but it says that the universe could not have been expanding forever up until the present time.
Proving that the universe could not have been expanding forever up until the present time does imply a beginning, unless you can craft a tenable model according to which the universe was previously contracting or was static prior to expansion, which has not been done.
Pause. So there's there's a way in which people systematically misuse the term universe. So in philosophy, people tend to use the word universe to mean something like the whole of physical reality or something like that. In physics, people tend to use the term universe to mean something like the whole of like the observable universe, or maybe like a causally connected space-time region or something like this. So in other words, a proper part of physical reality, not the whole of physical reality. One of the ways you can tell that this is true is that multiverse models are not models of there being multiple realities. Instead, they're models of there being distinct space-time regions with specific features, but they all are part of one physical reality. The reason I bring this up is because what the BBG theorem actually talks about is a congruence of time-like and light-like curves. Now, a congruence is a bundle of curves through space-time. So if you want an analogy what this kind of looks like, if you just take like a bunch of uncooked spaghetti and like hold it in your hand as a bundle, you can imagine that all those are like trajectories through space-time. That's a congruence. And what we imagine is that if space-time is expanding along a congruence of trajectories, these are trajectories that could be taken by either particles that are traveling less than the speed of light or at the speed of light. The technical term for that is time-like or light-like trajectories. If you have a bundle of trajectories like that, and space-time has been expanding along them in the sense that the average of a specific generalization of the whole parameter is positive, then that bundle either needs to be finite to the past, or it needs to be such that there's some region beneath that in which space-time is not expanding. But you can take that congruence. I mean, even if that congruence is like chopped up at the bottom, so there's a boundary to it, a place where it begins, as much of a beginning as Craig could possibly want out of this damn thing, you can take that bundle, you take that congruence, and you can isometrically embed it into another space-time that doesn't have a past boundary. In other words, you can construct a space-time in which you have that, in which the BBG theorem applies, but the whole thing is past eternal. So it just does not talk about there being a past boundary to the entire universe.
Right, it's just a past boundary to the inflating region. And
right, that's right.
That's why, that's exactly what Goose said, it's exactly what Valenka said. And there are certainly models which seem to have a past contracting universe. It's basically, Craig's just denying it, but it's just a fact. You can look them up in the literature. So he's just, he's just basically appealing to the fact that Valenkin has criticisms of them. But of course he does, because his model of the universe is a model with a beginning. So of course, different cosmologists, different views, and they fight each other. And it's just cherry picking to pick the one that you want.
Actually, here's a theorem. So since Craig apparently likes theorems, here's a theorem I prove in my dissertation. A universe to which the BBG theorem applies and shows that it has a past boundary is observationally indistinguishable from a space-time that doesn't have that past boundary. Observation indistinguishable, in the sense that if you're an observer embedded within that universe, no matter how many observations you ever make, you'll never be able to tell that whether you're in the universe with a past boundary or if you're in the universe without one. That's a theorem you can prove in general relativity. So if he likes theorems, that's there you go.
In fact, Guth has described inflation as resembling a steady state. He says you would never be able to see, if there was a beginning, you'd never be able to see it. But yet, Craig says that we have observational evidence for a beginning. But hang on, you wouldn't be able. Guth is telling you wouldn't be able to see the beginning if it were there.
I mean, at the very most, what you could ever have is observational evidence that the particular region of spacetime that we occupy had a beginning. Right. But that wouldn't tell you that the whole of physical reality had a beginning.
Oh, one last thing. Note that Alan Guth described his colleague's name as Border. Not Board, not Border, Border. Hopefully we can settle that now because Guth said it.
That's good to know.
Another point which I raise in my book about Craig's use of the BGV theorem is that Craig has also said that the time as operationalized in the context of general relativity is not real metaphysical time. He says it's a bare abstraction from it or something like that. And he even says that the beginning of one doesn't imply the beginning of the other. So I think he's just inconsistent here with stating that the fact that past directed time trajectories are incomplete under inflationary cosmology must mean that there's a beginning of metaphysical time, because elsewhere he says that you can't make any inference about metaphysical time based on these sorts of results in physical time, based on the way he interprets relativity. So I don't think he can eat his cake and have it here either.
Oh, and one last thing. Notice that Guth and Vilenkin also say that inflation is future eternal, right? Why doesn't he object to that?
Yeah, I hadn't noticed that. That's a good point.
He can't accept what they say in that paper.
I was muted. I was making a joke. At any point, that they asked the question, how many events have there been?
And here's more from Vilenkin.
The theorem proves that inflation must have a beginning, right? The universe as a whole, the theorem doesn't say that. It says that the expansion of the universe must have a beginning, right? So, but it opens the door somewhat for alternatives.
This clip is so misleading. The Bohr-Guth-Vilenkin theorem has the condition that the universe be on average in a state of expansion throughout its history. Bouncing or cyclical models may not satisfy that condition, and so they are not excluded by the theorem. But as Vilenkin has repeatedly explained, such models face other insuperable obstacles that preclude the universe's being past eternal. And so again, I wonder, Kevin, why didn't the producers of this video ask Vilenkin about that?
And here's the next.
So just one other thing. I mean, we reviewed that. I mean, he's kind of making the same point, and we responded to it. But just to give one other example, Francis Pistorius, very well-respected numerical relativists. They've shown that you can overcome some of the objections that Vilenkin had to a contracting universe by just having it contract slowly, right? Then you won't get some of the instabilities that Vilenkin talked about, right? So, and they've modeled this. They've got the numerical relativity results. It works perfectly well. So, of course, why doesn't Craig mention that? Yeah.
Well, that all comes out of the fact that this quantum cosmology in the beginning of the universe and all that is an ongoing frontier research area. So none of these things are really settled. And Craig talks as if they are, which is just wrong, right? And I don't know why we would take Craig's word for it, that his particular interpretation of things or views on what is not possible or feasible, because he's not even close to being an expert on this area. And neither is Sinclair, his co-author. And so I just don't understand why we would, what's the basis for accepting Craig's sort of version of how things fit together? Now, I think that's partly why he appeals to people like Vilenkin, who allegedly agree with him, although they don't, because Vilenkin is an expert in this field. But even if Vilenkin agreed exactly with what Craig said, that still wouldn't be a very strong reason to accept it, because Vilenkin's just one expert in a field where there's many experts who disagree. And I don't think it's reasonable for Craig to present it as if it's sort of accepted or that there's a consensus here, and then argue that his view fits that, because it doesn't. In fact, I don't think there's really any cosmologist who would agree with the combination of claims that Craig makes about time and the universe and all of that, because much of it is not scientific anyway, and a lot of it's involves non-standard interpretations of like relativity and things like that. So if anything, Craig is in an extreme minority fringe position with respect to this, but he's trying to make it sound like that he's in the mainstream and he's just appealing to established facts. Well, it's just not the case.
One other cosmologist quoted in the Blackwell Companion was George Ellis, and he raised objections to a contracting universe. But what's very interesting is that in the last few years, he's published papers suggesting that we have a cyclic universe. So the very guy that he was actually appealing to has now turned against him.
Another thing to be mentioned about Ellis is that Ellis, over the past many decades, has written a number of really fascinating papers about what space-time might be like beyond our cosmological horizon. And so, in other words, papers about whether we really can infer the global structure of space-time from local observations. Ellis is extraordinarily skeptical that we can do that. And given the kind of skepticism that Ellis has about being able to observe the global structure of space-time, and that at the kind of beginning that Craig wants would be a global feature of space-time, there's a huge problem here for Craig in appealing to Ellis's work.
Narrator talking about one way to avoid the BGV.
As we've seen, one way to avoid the BGV is to have a past contracting universe, which is also a common prediction in multiple approaches to quantum gravity. But some suggest that this collapsing phase will be messy and unstable, and therefore not be able to transition to our smooth, homogeneous universe.
Right. This is exactly what Vilenkin says. It's funny that they never asked
Pause
him to
it a sec,
explain it to them.
Pause it a sec. He says, he's like, well, why didn't we mention it? We just did, and it's there. We just said it.
Why didn't you mention it when you mentioned it?
Yeah, exactly.
Actually, that reminds me. Sometimes I remember, this is sort of just an aside, but sometimes I tell my mum something. It's like, well, when were you going to tell me this? I'm like, well, now, like I just told you. What do you mean? It's just weird sometimes.
Here's our next excerpt.
We have absolutely no idea of what exists in the universe before the bounce. So it's very speculative and very difficult to decide whether the situation is stable or not. And even in the case where the situation is unstable, usually what it means is that the simplifications we use in standard cosmology cannot be used anymore. But nature doesn't care about the fact that it is hard to calculate. So when we say that something doesn't work, most of the time it means that the model we use to describe these things doesn't work anymore. For example, you cannot use the Friedman equation because the universe is so inhomogeneous that the Friedman equation is not usable anymore. So what? The universe doesn't care that we have to invent another equation. I think the correct way to think is not to go from the past to the future, is to start from what we know. What we know is what we see around us today. The universe is expanding. We have stars, we have galaxies, we have gravity. We have a theory. And then we go backward in time and we see what happened. And in our theory, when we go backward in time, we do not end up with a singularity. We end up with a bounce.
This is mere hand-waving, an appeal to the unknown. The bounce needs to result in the low entropy condition of our early universe.
Pause it. Sorry. It's the exact opposite. What Aurelian is saying is we don't know what the matter content of the previous universe was, so we can't say, with confidence, whether we're going to get these inhomogeneities and whether we can transition easily. So what Craig is saying was that's speculative. So he's saying it's speculative to say that we don't know what the matter content of the previous universe was. That's just absurd, right? He's the one that has to know what's happening to say it is ruled out. And of course, since we don't know, we can't rule it out.
By the way, so this whole point about the low entropy past, there's a whole series of replies that have been given, including ones I've given in print. But part of so there's an argument from Hugh Price. It's a very simple argument. This points out the following, which is that we know that there needs to be a low entropy condition to the past in order to have the thermodynamic arrow of time, in order for our memories of the past, for instance, to be reliable and so on. So everyone should be committed to there being this entropy gradient and there being a low entropy condition to the past. Now, there's a further question here about where exactly you place that low entropy condition. If you're a member of that prior universe and the low entropy condition is to your future, this is supposed to be problematic, or so says Craig, because it means that all the physical constituents in that universe are somehow conspiring to produce that low entropy condition. But part of what Price points out is that it's not really any more problematic where you place that low entropy condition along the timeline. I mean, put it wherever you want. It's equally a problem wherever you put it. So it's that the problem isn't about there's no problem of trying to produce this low entropy condition. That's not the issue. But there's some other things besides here too, which is that for instance, there's a research program developed by Barry Lower and David Albert and some other people associated with the New York City, Rutgers type area called the Mentaculus. And on that research program, their view is that all of the statements that we make, the probabilities that are assigned to all the statements that are made in the sciences need to be conditionalized on three statements, the conjunction of which they refer to as the Mentaculus. One of those statements that all of these scientific statements need to be conditionalized on is the statement that there is this low entropy boundary condition to our past. That statement, what they call the past hypothesis, if it's really true that all the statements made in the sciences need to be conditionalized, or the probabilities, of all the statements made in the sciences need to be conditionalized on the past hypothesis, well, then you can ask, what is the probability of the past hypothesis? Well, if you conditionalize the path hypothesis on the past hypothesis, the probability of the past hypothesis is just 1. So instead of thinking that a low entropy condition to the past is like improbable if there's some problem like this, the solution, according to the Metaphysical project, is just to say that it's as probable as a statement could be. But there's some other replies too. Another reply that one could give is to say that it's not actually a low entropy condition. It's only an apparent low entropy condition. So there are cosmological models in which what happens during the bounce is that there are a whole slew of a large number of the universe's degrees of freedom become hidden from us. And because those portions of the universe become hidden from us, it makes it appear from our perspective as though it were a low entropy condition, even though the entropy increases throughout the entire process.
Actually, Abai's going to mention that in a minute, or something like that.
Shown that
Sorry, I
cannot
wanted
happen.
to comment on the idea that this is hand waving and appeal to the unknown. First of all, Craig is claiming to know certain things. If we do not in fact know them, that is, have sufficient justification for them, then it's perfectly acceptable to appeal to the fact that we don't know them as a refutation of what Craig is saying. So I don't really understand that objection. But as to the hand waving part, look, Craig's explanation of all of this is God did it. To me, that's the ultimate hand wave. He doesn't have a physical mechanism. He doesn't have a theory. He doesn't have an explanation as to why there was low entropy at the beginning of the universe or the earlier universe or whatever. He just says, well, I guess God made it that way, right? That's his answer to all of these problems. So if you're offering this as a comparative explanation, that is, that Craig has a better explanation for certain things in various physical theories that he would reject, then Craig would have to show that his explanation is superior. It exemplifies the explanatory virtues. But I mean, first of all, he never really makes much of an effort to do that, certainly about this cosmological stuff. And second of all, when you do that, I think that you end up with just a series of brute facts. Well, why was there a low entropy condition? Well, God made it that way. Well, why did the universe begin when it did? Well, God made it that way. Why was there an inflation? Well, God wanted it to inflate. Like there's no actual explanation here. It's just a restatement of all of our observations.
Like, compare these sorts of theological ideas in this context, when we're talking about creation ex nihilo, to other theological contexts, like when people talk about models of the incarnation or models of the Trinity. In those contexts, people actually have fairly sophisticated formal models. I mean, not all theologians do, but there are theologians who have developed very sophisticated models, including Craig. I mean, he recently has come up with some sophisticated models of the incarnation. In terms of creation ex nihilo, there's no divine mechanism that's responsible for creation ex nihilo. There's no way to go from his theological model to a prediction about how low the universe's entropy should be, or what the distribution of fluctuations in the CMBR should look like. The hypothesis doesn't make any of the kinds of predictions that we want out of good physical cosmologies. And it doesn't have the kind of formalism that we see in theological models in other contexts, like when we talk about the Trinity and the Incarnation.
Of our early universe. Belenkin and others have shown that cannot happen. So beginning from what we know, where we are, we go backwards in time, and we find that you cannot get here from there. And even if we could, postulating an earlier contraction does nothing in itself to restore a past eternal universe.
Okay. In this next clip, they discuss.
Does anyone want to say anything on those last comments?
Well, it's just the same thing. The skeptic of the Kalam doesn't need to say the universe was past eternal. What we need to do is to remove the evidence on the table that it has a beginning, and that's what these models do. If valid, they do that. So basically, this criticism is just completely misplaced. It's basically like saying, you're at a trial. He's presented the evidence that you're guilty, and you need to prove that somebody else did it. You don't need to do that. You just have to say, the evidence you brought to the table is not.
Well, if the accused didn't do it, who did? You can't prove who did it.
Well,
that's literally his argument.
Yeah, exactly. It's just completely misconceived.
It's similar to that. There's a scene in Peep Show that I always bring up because a lot of these kind of arguments that people raise are.
I think we should say, for those not familiar with Peep Show, it's one of the best comedies ever.
And Jeremy, who's one of the characters in it, joins a cult, and then so he's got the book, and David Mitchell, who plays Mark, he's like, oh, I've heard about these people or whatever, and Jeremy goes, and he goes, let me look in that book or something. And Jeremy goes, oh yeah, it explains all about orgones in there. And he goes, orgones? What are orgones? And he goes, well, you know, they're the explanation for, you know, all of the problems in the world. And he's like, Jeremy, like that sounds kind of crazy, doesn't it? He's like, well, how do you explain it? You know, and he's like, well, I couldn't. There's complex historical and economic.
Look how unifying these orgones are.
Yeah.
Another theorem developed by Aaron Wall.
With the authors of the BGV explicitly stating it does not prove the universe had a beginning, the Kalam advocates have begun using yet another theorem developed by Aaron Wall.
Wall is assuming that some version of second law of thermodynamics is really fundamental and should be a fundamental ingredient in the series which determines whether there will be singularity or not. And I agree with that. I think that it really is something that will emerge in approximate sense in a semi-classical regime.
Generalized second law that was proven by Aaron Wall for quantum singularity, it assumes an infinite space. And if you don't allow for infinities in your theory, then you cannot take that theorem seriously either.
Well, Kevin, why do you suppose they didn't go to the source and ask Aaron Wall himself about this? I think we're seeing a lack of objectivity on the part of the producers of this video. So I did go to Wall and ask him. And he tells me that while his generalized second law of thermodynamics implies an initial cosmological singularity in an infinite space, nevertheless, in a finite space, at some time t in the past, the generalized second law would simply reduce to the ordinary second law of thermodynamics. And then he says you can still argue from the ordinary second law of thermodynamics that most likely either A, the universe had a geometrical beginning, or B, the arrow of time must have reversed at some time in the past. In the latter case, one still has a beginning of the universe since both time directions are future oriented.
You always
let's pause it there. Okay, so notice, it's like, why didn't you ask Aaron Wall? It's there in the abstract of the paper, right? The model requires an infinite space. It's based off the Penrose theorem, which requires an infinite space. He brought this as new evidence to the table that would rule out a quantum gravity theory providing a beginning, right? But the new evidence depended on an infinite space, right? Notice he also never mention the objection that Abai raised. He didn't even address that, right? So now it reduces to the ordinary second law, but the ordinary second law doesn't necessarily give you a beginning of the universe either, and we go into that. So there's nothing left, right? I mean, it's completely disingenuous to bring to the table in this Carroll Craig debate a theorem that required an infinite space. So, you know, now as to this reversal of the arrow of time, I'm sure Dan will have stuff to say about that. You know, why didn't he ask Don Page, who made a very elegant argument? Let's see if I can find the quote. Hang on a sec. That the reverse arrow of time does not provide any evidence for a beginning of the universe. And why didn't he ask Alan Guth? I did ask Alan Guth. He said, well, that bit in the middle, because Guth thinks there's a reversal of the arrow of time and a contracting, expanding universe. And I say, is that the beginning? He goes, well, that's a logical beginning when we start our description. I said, well, what if someone said it's an actual beginning? He said, well, I would just put, if they took the word logical out, I'd put it back in. But there's a quote from Don Page. Let me just see if I can find it here. Hang on a sec. Here we go. Nope, hang on. Here we go. This is Don Page. It is erroneous to say that bounce is a true beginning of time, since the structure of space-time there, at least if there is an approximate classical space-time there, has time-like curves going from proper time of minus infinity through the bounce, say at proper time 0, and then proper time of plus infinity. That is, there are world lines that go through the bounce and have no beginning there. So it seems rather artificial to say the universe began at the bounce that is in the middle, just because it happens to be where the entropy is minimized. I think Sean made this point well in the debate. So Don Page made this point. Alan Guth makes the same point. Sean Carroll makes the same point. Why doesn't Craig ask them?
So look, you know, one of the things is that if you think that the direction of time is reducible to the thermodynamic arrow of time, or shares a reductive base with the thermodynamic arrow of time, then you're going to say that the fact that there's a reduction, there's a reversal in the entropic arrow means there's a reversal in the direction of time. But you're also going to say that that can't be the beginning, because fundamentally, time doesn't have a direction. And one of the things you need for a beginning is there to be an event that we can call the beginning that precedes everything else that happens. if fundamentally time is directionless, if time is what philosophers call a C-series, then there just is no beginning. So a reductive account of the direction of time is incompatible with Craig's purposes, but also, by the way, incompatible with Craig's A theory of time. Now, if you look at some of the papers which Craig discusses the reduction of the direction of time, either to a common reductive base as the thermodynamic arrow or to the thermodynamic arrow itself, what you'll find there is that Craig says that one of the advantages of the A theory of time is that we can explain the direction of time without having to appeal to entropy. And so, for example, if the universe's entropy fluctuated up and down, then on A theory, time would still just be going the same direction despite those fluctuations. So what that tells you is that what's happening in a fluctuation? Well, what happens is the entropy decreases and then increases. That's what we're calling a reversal of the entropic arrow. Now, in these cosmological models, it reverses for a very different reason than if you had a fluctuation. Granted, but part of what is involved with the fluctuation is a reversal of the entropic arrow of time. And in the case of fluctuation, Craig wants to say that the direction of time does not reverse. So if it doesn't reverse in that case, even though there's reversal of the thermodynamic arrow, then why does Craig think that the fact that there's a reversal in the thermodynamic arrow in some cosmological models would mean that the direction of time reverses in those cosmological models? I mean, it seems to me that if he wants to make use of those kinds of cosmological models, then he has to square them with his A theory of time. I'm not sure that can even be done, but supposing that it can be, what you would have is a progression from one universe into the other. Here's another point about this. If I'm sitting in one universe, I shouldn't be able to receive a signal from the other universe if it's really to my past. I mean, if you had one common origin and two universes came off from it, and the one person in one universe received a signal from the other universe that was like somehow to their future, that's a very strange form of time travel. And yet, there are light curves. There are signals that go from the one universe to the other according to the model. In fact, in some of these models, the observational test that they predict is in terms of being able to detect signals from the prior universe. None of that makes any sense if the direction of time actually reverses at the bounce. The other point, and I raised this earlier, is that we have bounce cosmologies in which there's sensible thermodynamic development through the bounce. There's no reversal of the entropic arrow. One way that can be is if, because of the development of cosmological horizons, there are degrees of freedom in the universe that become hidden from us, and where the bounce is, where there's the join between the two universes. From the perspective of observers in one universe, it will look to them as though that join is a low entropy condition, even though the entropy had a smooth increase through the whole process.
Yeah, honestly, I think that what Craig would really want to say, or sometimes does say about many of these models, is just that they're metaphysically impossible because the way they describe time is just inconsistent with the way he thinks time works as a sort of a presentist, and with where temporal becoming is real and time has an intrinsic direction and things like that. So, I think that these models, he's just, in so much as he does sometimes talk about them, I think is sort of thinking about them, in a way where he's trying to apply his sort of way of thinking about time to them, but it sort of doesn't really work, as you mentioned, which is why I think he says that in the universes where there's a change in the direction of where entropy decreases and then increases again, that he describes that as, well, there's really one beginning and sort of two universes that come out of that, because that's maybe the closest you can get to understanding that model under his sort of metaphysical positions. But I mean, ultimately,
in some of my papers, I have offered theoretic interpretations of those models. I'm not sure whether those specific models are incompatible with Craig's metaphysics of time. But the one thing that I would say about them is that, or the one thing I want to say in connection to the comment you just made is that, so Kurt Gödel, the same Gödel that came up with the incompleteness theorems, came up with a fairly pathological solution to Einstein's field equations. He came up with a fairly pathological spacetime in which there's a closed time-like curve that passes through every spacetime point. So for people who don't know, maybe watching, a closed time-like curve is a closed loop on a space-time diagram, right? So it's like a time travel trajectory. And in Gödel space-time, there's a trajectory like that through every space-time point. That Gödel took to show that there couldn't be an atheoretic way of interpreting general relativity. Now, what Craig says in reply to that model is he says that that particular solution is not metaphysically possible. So if he says that in that case, if that's his response to Gödel, like why isn't that his response to these balance cosmologies? I'm not sure. But here's another reply that could be given, by the way, which is one that I offer in I have a paper called "The Kalam Cosmological Argument Meets the Metaculus," and one of the things I say in that paper is that one of the atheoretic models I offer for interpreting balance cosmologies is that if you do interpret it as being a common origin for two universes, you could think of both of the universes as being simultaneous causes of each other, and therefore not requiring an outside cause.
Yeah, that's interesting. I hadn't thought of it from that perspective. Yeah, I don't think that Craig really takes that model seriously as like metaphysically seriously. It's kind of what he says in the Blackwell Companion about closed time-like loops. But yeah, basically when the past causes the future causes the past in some sense. And he just basically says, well, these are, I can't remember exactly what he says, but they're just sort of weird or counterintuitive. I think he actually maybe says that later in this video about those sort of models. And so I just, in terms of why doesn't he just say that as his response to all of these models? I guess one can speculate about that. I guess it comes to the question as to why he even talks about these models in the first place when he thinks that there are powerful a priori arguments, or at least like philosophical arguments, why the past must have a beginning.
Yeah, but
So
Craig's
why
position
even
has
mention the
always-
scientific arguments at all?
Right, but Craig's position has always been that the beginning of the universe can be independently established on empirical grounds alone. So it's there are some authors who think that all that needs to be shown about the empirical stuff is that our cosmological data is consistent with the a priori arguments that establish a beginning in the finite past. That's Andrew Loke's position, for instance, but that's not Craig's. Craig's position for many decades has been that a beginning of the universe can be established merely on the basis of physical cosmology and without appealing to any of the a priori stuff.
Well, that's not how I read his earliest work on this, but that doesn't even make sense to me because, I mean, cosmologists don't agree about that. Like, I don't understand where is he just saying that he knows the models better than they do? I always took what he was saying is that fundamentally it's the philosophical arguments that get you there, that there's sort of confirmatory or supporting evidence from physical cosmology. And he's going to interpret it in a way that's consistent with his arguments, of course, because he already sort of thinks that way.
Yeah, so for instance, there's a paper from 92 or 93 or thereabouts where he says that what physical cosmology has done is what Thomas Aquinas thought was impossible. So Aquinas thought that it would be impossible by way of reason to establish that the universe had a finite past. Craig says that that's actually what physical cosmology has accomplished. That he says that it's made undeniable the conclusion that the universe has a finite past. Another place to look is that he has I mentioned earlier that there's a post on his website in reply to Swinburne's rejection of the a priori case for the Kalam. And in that reply, Craig points out that Swinburne thinks that a finite past can be established on empirical grounds, and that Craig would be fine if that's all we could do is establish the finitude of the past on empirical grounds. And then you can also look at his public debates. So his debate with Sean Carroll, for example, where he presents arguments for the conclusion. I mean, in that debate, he doesn't mention his a priori arguments, right? He only talks about the a posteriori case. In my dissertation, I call this the Craig Swinburne view, the view that the premises in the Kalam argument can be established on empirical grounds, as opposed to Locke's view, where the view is that all that needs to be shown empirically is mere logical consistency with the a priori case.
Yeah, I guess I'm not sure that that's the argument that Craig takes in his original work, the Kalam Cosmological argument, but I guess we don't really need to get into all of that.
Do your homework, Bill. Here's the next clip.
Craig also quotes a paper by Anthony Aguirre and John Cahias that he claims closes the door to a past eternal quantum gravity era. But in most models, the quantum gravity era is brief anyway, and the paper only referred to a particular model known as the emergent universe.
Now, I quoted Aguirre and Cahias simply to show that a quantum state cannot persist changelessly from eternity past and then produce a new effect. And what he says in the next clip confirms that.
Let's go to the next clip.
But there are other possibilities too, as to how the universe could be in accord with the Bordet-Guth-Vilenkin theorem, but could, I think, really be past eternal. If you define a past eternal model, you can. It self-consistently works, but you do have an edge to it. If you can ask what's beyond that edge, and it's another copy of the same universe. So I think where the debate lies, past eternal models exist. I think some of them are flawed, like the emergent model. I think you can't really make a self-consistent model that stands up. Past eternal inflation or the steady state model, I think you can, but you have to do it carefully. And there's an interesting then answer to what is this Bordet-Guth-Vilenkin theorem pointing to? It's pointing to something very interesting. It's just not in initial time.
Jim Sinclair has already responded to these proposals in his Blackwell companion article. In brief, it's more plausible to interpret the Bordet-Guth-Vilenkin theorem, as Vilenkin does, as implying a beginning of the universe, than to try to save a past eternal universe by postulating two non-interacting universes at some past boundary, or a reversal of time's arrow at some point in the past.
The narrator.
So if we can pause here.
Yeah, hang on, I just want to make one very quick point. Well, he basically, well, I was only using the paper to establish that this quantum instability can't go on forever. Sorry, the static Einstein universe can't go on forever into the past. But that's not correct. In the Carroll Craig debate, he used it to establish that the universe had a beginning. Right. The quote is, hence, whether at the boundary of the quantum gravity regime, the universe already began to exist. That's what he said exactly following that use of that paper. Whereas the paper never claims that, and Aguirre himself just told you that he thinks the universe can be eternal into the past.
Well, here's something that's really important. There's the initial paper that Aguirre wrote, and then a follow-up paper, and there's something slightly different that happens in the two. So the kind of objection that he just quoted from Sinclair applies to the first paper and not the second. And it's you know, but the other thing that Aguirre himself points out in those two papers is that the original paper was meant to be a toy model and wasn't meant to be physically realistic. The second paper, to which the Craig and Sinclair objection does not apply, is supposed to be the more physically realistic one. And so it's there's this weird Craig and Sinclair do not address the more physically realistic model.
And there have been papers claiming that actually the model can be stable if you choose the right potential. So why didn't Craig talk to them? Why doesn't he quote them? Lack of objectivity, surely.
So the other thing is that, so he mentioned this model from Ellis and others where the universe begins in this Einstein static state, and that Einstein static state is supposed to be unstable for quantum mechanical reasons. In the 2012, I think it's in our 2012 paper, they make this comment that because that state couldn't have been around, can't persist forever for an infinite duration of time, but therefore the universe must have had a beginning. And it's like, no, all that tells you is that particular physical state can't exist forever. It tells you nothing at all about what precedes it.
Yeah, I mean, this is the same issue as before, right? Where we're talking about sort of a set of models where there are problems with the models, but physicists are proposing new ones and developing the literature. Craig doesn't really have an in-principle objection against these models. He just sort of says, well, they're not plausible, so we should ignore them. But I don't know why we should take Craig's word for it.
One of the important points about the Aguirre paper is that the original motivation for that paper as far as I understand, I mean, I haven't talked to Gira about this, Phil has, but as far as I understand it, the original motivation for the paper was just to show what is possible while retaining consistency with the BVG theorem. It wasn't meant to show like some way that the universe could actually be, or something that's like a plausible statement about the actual structure of the universe or whatever, right? I mean, it was just meant to make a point about that theorem.
Here begins this next clip.
Just as there are theorems that prove the universe had a beginning, there are also theorems that imply the opposite.
I think you can prove anything. Theorems are very strange things because you can have a theorem to prove anything as long as you assume the right things. In a way, that's the problem. And you can violate any theorem as long as you violate the assumptions.
Pardon me, but you can't prove just anything. Your assumptions must be credible in light of the evidence. The Born-Guth-Vilenkin theorem rests on the single, unremarkable assumption that the universe is, on average, expanding throughout its history. If it's not, then the theorem doesn't hold. But in that case, as Vilenkin has said again and again and again, you encounter other insuperable problems that preclude a past eternal universe.
Okay, just pause it a sec. So I think the point that Zhao is making is that if you have a singularity theorem, it could be interpreted to say there's singularity, or it could just be interpreted to be saying one of the assumptions in the theorem must be wrong. So you can just, and then that's completely valid, right? So in fact, the Penrose-Hawking theorem have a number of assumptions. There's no closed Fermat curves, gravity is always attractive, general relativity describes the gravitational field in all conditions. All of these can be questioned, and I think that's the point that Zhao's making, and I think it's a completely valid point.
Right, and I want to emphasize again that you can construct spacetimes that are consistent with the BVG theorem, but that do not have a global singular boundary, that are only that only have one particular region that has a boundary, and then the rest of it is unbounded.
Of course, there are the singularity theorems, but you can always interpret them as telling you that a quantum theory of gravity should not have one of the hypotheses that you are using to formulate this theorem.
Fine, so bring on the quantum gravity models like the Hartle-Hawking model or the Vilenkin model, both of which involve a beginning. Quantum gravity doesn't restore.
Well, okay, I mean, does he not know who's talking there, right? That's Francesca Vidotto. She's, in a PhD thesis, created what are called spin foam models, which have a bounce. So he says, bring them on. And then he does it. And then he mentions models, quantum gravity models have a beginning. And in fact, I would say Hartle-Hawking and Vilenkin-Tunneling aren't really quantum gravity models anyway. They're semi-classical models, whereas spin foam is a quantum gravity model. And he basically then just ignores it. I mean, it's just absolutely outrageous in my opinion.
Again, as I've said before, on my conception of what it would take for physical reality to have a beginning, if what's fundamental to physical reality is the wave function of the universe, which is a plausible way to interpret many quantum cosmological models, then I don't think the universe had a beginning, even if it is finite to the past. So it's the question about whether the Hartle-Hawking model is finite to the past, in some ways, it's just a mistaken question. In that model, what's fundamental to the physical universe is a non-spatiotemporal object or entity, the wave function of the universe. Since that entity is more fundamental than space-time, it couldn't have a beginning.
Yes, and as you pointed out, Daniel, there's quite an interesting, I guess, literature or field of development, which what's his face, Sean Carroll has been talking about recently, which is basically making the argument that space-time may be emergent in this sort of way from some sort of I combine underlying and fundamental, some sort of underlying sort of quantum processes. And I mean, if that's true, then it's not clear that even if the universe is sort of bounded in the past, that it had a beginning in the way that Craig says. In fact, it would be just sort of what Craig says about God, that there's sort of part of the universe that exists outside of time.
You're right. Now, it is important that some models, according to which the wave function is the fundamental object, also have do not say that the wave function is more fundamental than time. So, for instance, Alyssa Ney has an account of non-relativistic quantum mechanics in which the wave function is more fundamental than ordinary space-time, but nonetheless the wave function evolves through time. The universal wave function, in her view, evolves through time. But there are other views on which there's a universal wave function, where the universal wave function is more fundamental than time. Sean Carroll has a model of that kind. So Sean's model would be one in which the entirety of space-time is going to be metaphysically explained by a more fundamental object, namely the universal wave function.
Model, both of which involve a beginning. Quantum gravity doesn't restore an infinite past. As will come up later, I think, the question will be rather whether, according to these models, the universe can come into being from nothing, as both Hawking and Vilenkin suggest.
Well, Bill, that's what we're going to talk about next time.
Okay.
Can we do a bathroom break if we're going on to the next one?
Absolutely. Yeah, feel free if
All
you
right,
want
back
to.
in 2 minutes then.
No problem.
One issue that I wanted to comment on about Craig when he talks about whether a model does or does not have a beginning is that in one of his books, I think it's the Tensed or the tenseless theory of time, one of those two that he held up, he actually defines having a beginning in tensed terms. So that's not the only definition he gives. He gives a series of definitions. But I guess the trick is that if, in order to decide whether a model has a beginning, or the universe in a model has a beginning, you need to use a tense theory of time. It's a bit hard to know how to apply that in models where it doesn't appear that it's hard to reconcile with the tense theory of time. Like many of these quantum gravity models or like cyclic universe models and so forth, it's a little less clear whether, well, I would say actually quite unclear whether you can reconcile those with Craig's tense theory of time. So it's not always clear whether a model does have a beginning or not, depending on how you define like a beginning in the way that Craig talks about it.
Something that I think is going to come up more particularly towards the end of this video, but came up a little bit in the last one as well, is Craig keeps kind of insisting that the documentary makers are clearly not earnestly pursuing objective truth in the way that they've gone about producing this documentary, and I think there's going to be a clear sort of tu quo quo kind of thing, in terms
Craig
of, well,
never claims to be doing that. When does Craig claim to be doing that? He claims the opposite.
Yeah, even if these arguments were all knocked down, then the Holy Spirit would still, So, yeah, I mean, it could still be the case that the documentary is produced in a biased way or whatever, but I mean, that's no better than what Craig claims to be doing.
Well, I want to be absolutely upfront. This is a polemical film. It's not claiming to be an objective assessment. Is doing what Craig does. He makes films defending the Kalam, and we're making a film attacking the Kalam. And if he can do his, we can do ours.
It's just so ridiculous that he raises that objection. It's like, oh, but you're not allowed to make arguments. You just have to be objective truth seekers, as if you're like writing an academic thesis or something. I mean, even those are polemical in some ways, but it's like,
you have to have both hands tied behind your back.
Greg, if you're allowed to make these arguments, why can't we argue against it? And
yeah, he's literally saying we can't argue against him. I mean, it's just absurd.
Anyway, let's do the last one, shall we?
Yeah, absolutely.
At the first philosophical argument for the beginning of the universe in the first podcast. The
We can't
second
see it.
philosophical argument for the beginning of the universe. Last time we looked at the scientific evidence.
There we go.
Oh, there we go.
Yeah, sorry about that.
Today, the need for a cause of the universe's beginning of the week
to 773. We'll cover all 4 sections of the video.
Let's go then to the first excerpt from the video today.
The Big Bang doesn't prove the universe had a beginning, only that it evolved from a very hot, dense state. But when it comes to physics, the Kalam advocate has another card to play, the second law of thermodynamics. The second law states that entropy, which is roughly a measure of disorder, increases with time. And so the argument goes, if the universe were eternal into the past, we would already be in a maximal entropy state. Since we aren't, the universe can't be past eternal. This is also related to the mystery of why the Big Bang was in a surprisingly low entropy state. But what if the universe were infinite?
Perhaps we're living in a physical system where there's no maximum possible entropy. Suppose the entropy can just grow forever. And an eternally inflating universe looks like such a system, although nobody really knows for sure how to define the entropy of the eternally inflating universe. But if it's the case that entropy can grow forever, then any state is a state of low entropy because it's low compared to the maximum, which is infinite.
The puzzle of our universe's initial low entropy condition, which is universally recognized, cannot be so easily dismissed. The problem doesn't presuppose that there is a maximum entropy for the universe. It's enough that compared to today, the initial entropy was astonishingly low.
This next clip.
Okay, pause it a sec. I think it's confusing two things. I mean, there's two issues here regarding the entropy. So one is the argument that if the past were infinite, then we would be at the maximum entropy state, and since we're not, the past can't be infinite. That's a different thing to saying, why was the entropy low at the Big Bang? And he's answering that one and not addressing what Guth said, which is that if there's no maximum entropy, the argument that the past must be finite doesn't work. Furthermore, Guth does explain the dynamical process that can get you the low entropy condition, right? It's in our video on eternal inflation, just watch it. And he just doesn't address that at all.
Today, the initial entropy was astonishingly low.
This next clip.
What we need to consider is not just the entropy of matter, but also entropy associated with horizons, so to say the gravitational entropy. In the contracting branch, because the dynamics is different from Einstein's theory, a horizon develops, but it grows extremely rapidly. This entropy dominates completely the entropy of matter. Therefore, the entropy is really growing very rapidly, but then at the bounds, the geometry is such, which is my previous statement, is such that, in fact, the area of this horizon becomes infinite. And then after that, the horizon simply disappears. So if you like, what one has to do is to reset the entropy clock, in a certain sense, at the bounds.
This amounts to nothing more than a description of what happens in his model. It goes no distance toward showing that the model is plausibly the true description of the universe. The producers of this video don't seem to understand that it's not enough simply to float theoretical models. One has to provide some sort of evidence on their behalf.
They play.
Right, so
this is just unbelievable.
I mean, it's just incredible. The argument is, he's basically making an argument saying it couldn't be eternal into the past, right? All we have to do is to say it could.
It could.
We don't have to say that it was, right? And he's basically saying you have to say that it was. You have to prove that it was, right? No, we don't, right? We only have to say that the evidence he's saying it couldn't be is not valid, which is what Abai's argument, I believe, does.
I've seen people do this in print. I've seen philosophers of religion say, oh, such and such scientific theory is overly speculative. And I'm just like, but wait a minute.
Oh, I think your internet.
That you're a Christian philosopher. This move when
could you start that sentence again? Sorry,
like,
Daniel. Your internet cut out for a second. Your internet cut out. Oh, are you back?
Oh, so literature where like Christian philosophers will sometimes say things like, oh, such and such scientific theory is overly speculative. And it's like, wait a minute. You're a Christian philosopher. Like, don't you think that your theology, like, I mean, I guess they don't think this, but like from my perspective, their theology seems very speculative. So if we're gonna like, compare here, it seems like they're sort of on.
Dan, I think your internet's a bit so maybe cut the camera.
Yeah,
Dan,
maybe. Yeah.
Dan, you might want to cut the camera.
Might want to. I'll put it in the private chat if you can't hear us.
Yeah, just yeah. Well, Daniel Saw said that. I completely agree, and I think that Craig is entirely inconsistent here again because what Craig is doing, we should remind ourselves, is that he is advocating for a specific model of creation, perhaps not a scientific model, although he requires others apparently to have a scientific model, but it's certainly like a metaphysical or philosophical model. And so I would levy the same criticism as he does. Then, if it's good enough for Craig, what is Craig's positive evidence that his particular account of creation is the correct one? He appeals to, well, obviously he's appealed to the philosophical arguments, right? But with respect to the scientific side of things, he's going to say that, well, that there's these BGV theorems and these other results, right? Or and entropy being another one. And people say, well, yeah, but those results don't necessarily prove that the past had to be finite because there's these possibilities. Those undermine Craig's the fact that Craig is citing those as evidence for his claim because it doesn't necessarily support the claim, right? So then Craig needs to provide new evidence that does uniquely identify his preferred theory as, evidentially favored, right? It's not enough for him to just sort of give up and say, well, prove your theory. That's not how this works. Craig, if he requires other people to prove their theories, which is sort of fair enough, he needs to provide the evidence that, in virtue of which we should prefer his theory. But he seems to only sort of want this one way.
Yeah, and the model that Abai has outlined there, they've spent years working out predictions of the model, and showing that it's at least compatible with Planck, and may even have predictions for some of the anomalies in the Planck data. Now, I don't want to claim this is definitive and they've made predictions that are confirmed by the evidence. That would obviously be going too far. But they have a program doing this. They've got huge resources, computed power to work out, you know, things like non-Gaussianities and TT correlations in the CMB. Where's Craig's program to do any of that? I mean, nowhere, right?
I think it's in the Blackwell Companion. You just have to read that.
I mean, this is part of what Sean Carroll raises in the debate that he did with Craig, that, you know, physical cosmology is now a really sophisticated science. And it just, the kind of philosophical cosmology that Craig is up to looks entirely qualitatively different from what it is that physicists are doing.
An excerpt from one of your videos in this next clip, Bill.
What if the universe did have a beginning? In the 1970s, Edward Tryon claimed the universe might arise as a quantum fluctuation of the vacuum. But this still raises the question, where did the vacuum come from? In 1982, Alex Vilenkin suggested that if space itself was treated quantum mechanically, it could quantum tunnel into existence. He titled his proposal, Creation of Universes from Nothing.
Now, sometimes skeptics will respond to this point by saying that in physics, subatomic particles, so-called virtual particles, come into being from nothing. This skeptical response represents, I believe, a deliberate abuse of science. The theories in question have to do with particles or the universes originating as a fluctuation of the energy contained in the vacuum. The vacuum in modern physics is not what laymen understand by vacuum, namely nothing. Rather, in physics, the vacuum is a sea of fluctuating energy governed by physical laws and having a physical structure. To tell laymen that on such theories something comes from nothing is a distortion of those theories.
Hang on.
Properly
If I can
understood,
pause this.
nothing.
So, you know, the point that's being made when these kinds of models are discussed is not that something comes from nothing, but rather that something can begin to exist without a cause, right? Craig's causal principle is not that, you know, something has to come from something. Craig's causal principle is that anything that begins to exist needs a cause for its beginning to exist. Hang on.
Yeah, we heard that fine if that was
Yeah,
the concern,
yeah.
Daniel. But yeah, and so just to add to that, well, not just me, people like Oppie and others have criticized Craig for this language of coming from nothing, since no one argues that in a literal sense that the universe like came from nothing, like that there was nothing and then the universe sort of came into being. That doesn't really make sense. The idea, as Daniel just explained it, the postulate is that the universe may have begun like that is. Well, yeah, let me just say the begun without a cause, or that it did not require a cause to commence. That's really the claim that Craig needs to critique as to why that's implausible. But he keeps using this language of coming into being or popping into being from nothing.
Well, I do want to say that when I speak to Vilenkin, the way he describes his model is that it's like vacuum fluctuations. You have particles coming out of the vacuum. He's saying that space and time fluctuate into existence from a state where there's no space and time. So I think there is a way then that you could say that is nothing. Obviously, it depends what you mean by nothing. There are still laws of physics there, but it's nothing.
Well,
in the same
that's not
sense.
nothing according to Craig.
Right, okay, but it is not. Fair point. But it is nothing in the same sense that God does creation ex nihilo, right? I mean, Craig is saying that God. There's two different models of God's creation, or at least two. Maybe there's more than two. One is creation ex materia, where God creates out of pre-existing materials, and another is creation ex nihilo, where God creates without any existing materials. And I think that the Vilenkin tunneling from nothing model is a universe from nothing in the sense, because obviously when God creates out of nothing, God is there, right? There's not nothing there, right? But he is creating with no materials. And I think the Vilenkin tunneling from nothing model is a universe from nothing in the sense of what theologians refer to as creation ex nihilo.
Yeah, that's a fair point.
Right. And I think the other important point to appreciate here is that so while the universal wave function does not like temporally precede the space and time, it would metaphysically precede space and time in much the same way that God's non-temporal existence, on Craig's view, precedes God's temporal existence. And one of the things that's important to appreciate about that is that it's this is again going back to my point that the reason why in some sense there's no beginning on this model is because physical reality is fundamentally non-spatiotemporal, according to the model in question.
Does not mean just empty space. Nothing is the absence of anything whatsoever, even space itself. How silly then when popularizers say things like nothingness is unstable to quantum fluctuations, or the universe tunneled into being out of nothing.
Right, I'm speaking here of that. Hang on, remember that quote. How silly then when popularizers say things like nothing is unstable to quantum fluctuations, or, and it's an important bit, or the universe tunneled into being out of nothing. So just remember that and play.
Quantum fluctuations, or the universe tunneled into being out of nothing.
Right, I'm speaking here of vacuum fluctuation models like tryons.
Here's Alexander Vilenkin.
When we say nothing in this context, tunneling from nothing, we don't mean quantum vacuum. It's actually what a tryon meant.
Okay, so pause it.
Here we have.
Okay, so what Craig just said was that I'm only talking about tryons models, vacuum fluctuation models, right? That's what he said. Now, he noticed that he said tunneling from nothing. What does that refer to? That's Vilenkin's model. So when Craig said, "Oh, I'm talking about tryons model," he's basically telling something that's totally and utterly false, right? The tunneling from nothing model is Vilenkin's model, and he bracketed that as one of the silly things where it's really a vacuum, right? What I think is going on here is that Craig is obviously quoting Vilenkin a lot as saying the universe had a beginning. So he doesn't want to undermine his source. But really, that's exactly what he's doing, because he's saying Vilenkin's being silly for suggesting the universe came from nothing, right? So I think it's really disingenuous for him to say, "Oh, I was referring to Tryon's model," when he literally said tunneling from nothing in his list.
Why doesn't Craig just ask Vilenkin whether the universe could have come into being from nothing?
A state without space completely. So there's no vacuum.
Vilenkin's quantum cosmological model is different than Tryon's, whatever Tryon may have meant. The old vacuum fluctuation models are now obsolete, having been refuted, but Vilenkin's model still remains on the table.
Here's more from Vilenkin.
But if the universe did quantum tunnel into existence, what caused it?
Many quantum mechanical processes do not require a cause. So for example, if you have a radioactive atom, you know that it will decay, but you cannot tell when. There is a half-life time. For example, you can tell that in a year, the probability for this atom to decay is 50%. Then the year has passed, it didn't decay. The probability for it to decay the next year is still 50%. Eventually, it will decay. But if you ask why did it decay at that particular moment, there is no reason. There's no cause. So quantum mechanical processes like this are uncaused. And the spontaneous creation of the universe is of the same nature.
Notice that Vilenkin just assumes here the Copenhagen interpretation of quantum mechanics, according to which quantum indeterminacy is ontic rather than merely epistemic. There's no justification for this. There are, moreover, at least 10 different physical interpretations of quantum mechanics, which are empirically equivalent, and some of which are fully deterministic. So this is not a proven counterexample to the metaphysical principle.
So hang on, if we can exist. So he says, notice he said some of which are deterministic. In other words, not all of them are. So, like, how is it that he's able to infer that Vilenkin is using the Copenhagen interpretation as opposed to any of the other indeterministic conceptions of quantum mechanics, right? Like, why not Penrose's conception of quantum mechanics? Why not the GRW interpretation of quantum mechanics? The other thing to be said here is that just as neo-Lorentzianism turns out not actually to be empirical equivalent to orthodox relativity, so too several interpretations of quantum mechanics are not in fact empirical equivalent to they're not actually empirical equivalent. So for instance, the GRW interpretation, in fact, maybe all of the most or possibly all the interpretations that involve the that involve the objective collapse of the wave function as a real physical process they all postulate they all entail something called self-heating, whereby systems will spontaneously heat up due to the collapse of the wave function. People have looked for that and not found it. Now, there's still the possibility that this self-heating is below the threshold with which people have been able to search, but the fact that they haven't found it thus far provides us with some amount of evidence against those kinds of interpretations. Other interpretations, like the many worlds interpretation or Bohmian mechanics, do not entail self-heating. There are also problems with relativity. So, a lot of people know that quantum mechanics and general relativity haven't been successfully united. One thing that maybe a lot of people don't realize is that special relativity actually has problems being united with some of these interpretations. So the GRW interpretation, Bohmian mechanics, and several others, it's not obvious that they're consistent with special relativity. Now, some of them, like Bohmian mechanics, the sense in which they're incompatible with special relativity is not a sense that's observable, but at least not in some obvious way. But one of the things that's important here is that we have a version of quantum mechanics, namely quantum field theory, that is consistent with, that's already been united with special relativity. There is no general procedure for doing a kind of like Bohmian quantum field theory or doing like GRW in a quantum field theoretic context. So the fact that relativistic quantum field theory has been as empirically successful as it has been is itself surprising. What would be surprising if some of these interpretations were correct, in the same way that the empirical success of general relativity would be surprising if Neo-Lorentzianism turned out to be correct.
So one point I'd like to make is that he said that Vilenkin is obviously relying on the Copenhagen interpretation. If you just watch the film that we made with Vilenkin, he explicitly says he isn't. He's not sympathetic to the Copenhagen interpretation. Later on, and in fact, even in this video, he basically says he thinks the many worlds also is a causal. So he says it doesn't really matter whether you're many worlds or Copenhagen; they're both going to have a causality in them. So the statement that Craig made is just contradicted by Vilenkin a moment later in the film. Another point to make is that Craig values the pilot wave theory, and there was a recent paper by Smolin and colleagues saying that actually that is going to violate conservation principles. And there is a way to save that. That's by introducing retrocausality, which of course Craig thinks is absurd. So how has he got this sort of consistent view? And there's a sort of knock-on point. Something Alex Malpass made the point, this is going back to our infinity conversation, where he said, look, infinity is just counterintuitive, but so is quantum mechanics. So, what's the problem? And Craig responded, well, look, you've got pilot wave theory. That restores causality. Well, it may do, but it still violates basic things that are intuitive, like as I said in Smolin's paper, like locality. So I think he really sort of pulled a fast one on Alex Malpass there. And I understand that Malpass didn't want to go into the physics because it's just not his preferred area, and that's fair enough. But I think we should point that out here.
As a cause. I've responded to Vilenkin's claims about physics being able to explain how something can come into nothing on our website under Popular Writings, The Existence and Nature of God, the section on Creatio ex nihilo, Theology and Science. And so I would refer our listeners to that article.
And Bill, someone you've debated a couple of times, here's Arif Ahmed.
The notions of quantum mechanics place severe pressure on our everyday ideas of causality. You might say, well, there are some interpretations of quantum mechanics that allow for causality and determinism, and it's true, there are, but then there are other interpretations that don't.
Right, so quantum mechanics is not a proven counterexample.
Here's the next
one. Hang on, right, so, well, I guess we're going to make this point here. You can play it, actually, sorry.
Asserts that everything that begins to exist has a cause. Its defenders carry the burden of proof to show causality is maintained in quantum mechanics.
No, I provide 3 arguments in support of the causal principle. To defeat it, the objector has the burden of proof of showing that there is a proven counterexample to the principle.
Right, so
Wilson.
I mean, he's kind of, all right, he's assuming that his arguments are valid, right? But I think the point is that quantum mechanics casts, I'm not going to say it disproves causality, but what I'm saying is it casts sufficient doubt on causality, or that we understand causality enough for him to make these arguments. And since there are, as he admits, valid, apparently equivalent, apart from the exception that Dan mentioned, versions of quantum mechanics that don't have causality, and there's debate about it, he can't just assert it. He basically says, well, it's a metaphysical principle, and you have to find a definite counterexample. No, he's making the argument, so the burden of proof is on him.
Look, so, one of the mistakes that people often make in philosophy of religion, and actually not just philosophy of religion, other parts of philosophy too, is to conflate two different kinds of determinism. So nomological determinism is the view that everything is necessitated by laws or determined by laws, whereas causal determinism is the view that everything is determined or necessitated by causes. You can deny causal determinism without denying nomological determinism. So it's there are people who will argue, neo-Russellians in particular, who will argue that no interpretation of quantum mechanics, whether deterministic or indeterministic, involves has causation in there. So there's a number of historical authors, Ernst Mach, Bertrand Russell, John McHaggart, who have argued that for a kind of determinism, who have argued for a kind of determinism while simultaneously denying that causation even exists.
In this next clip.
So the different interpretations of quantum mechanics do differ a lot in terms of the role of causality. Start with the Bohm interpretation, or Bohmian mechanics, or the pilot wave theory. That is the most like classical mechanics when it comes to causality. Causality is deterministic, and cause necessarily follows effect according to the law. A bit of more of a deviation from the classical approach to causality comes in collapse theories, dynamical collapse theories, or the GRW approach. And these theories have irreducible randomness in the way the world turns out. So an effect need not necessarily follow a cause. A given cause could lead to many effects with different probabilities of each one. And there would be nothing in the world that explains why one effect happens rather than another. Any of them could have done. It was just random. And so that weakens the link between cause and effect. Instead of being ironclad necessity, it's probability. The cause makes the effect more probable. And I think that's a big change to the role of causality. But there's a bigger change still, potentially, to the role of causality in the many worlds interpretation, or the Everett interpretation. People often call that a deterministic interpretation, that they say we have the quantum state of the universe, and deterministically there evolves a multiverse, a system of many parallel worlds. But there's an open question as to whether we should call that process causation, or we should call that causality. My own preferred approach to understanding many worlds has it that causality is a process that goes on within each individual world, but not outside or between them. So causation is an emergent process that emerges along with the individual worlds, but is entirely contained within them. And that is perhaps an even bigger change to the concept of causation, because it means it's non-fundamental. It's not part of the deep structure of reality. It's not a concept that's even really properly applicable at the level of the whole universe.
This account nicely illustrates how uncertain the correct physical interpretation of the mathematical equations of quantum mechanics is. And notice, too, that the causal principle of the Kalam cosmological argument is deliberately formulated so as to allow for the possibility of uncaused events. What it precludes is things, substances, coming into being without a cause.
More from...
One of the things I find really... Sorry, go ahead.
I was just going to say that raises the question as to whether the universe counts as a substance, which is, I think, something one can dispute quite readily.
Yeah. But, what also... It's just obvious from what Craig just said there that he's not familiar with who Wilson is or what Wilson has argued. I mean, on Wilson's view, so one of the things to understand about Wilson is that he's a modal realist. But unlike other modal realists, Wilson thinks that the plurality of possible worlds are reducible to a more fundamental physical object, namely the universal wave function. So that on Wilson's view, the right way to think about quantum mechanics is the many worlds interpretation. And that unlike other versions of the many worlds interpretation, the worlds that appear in Wilson's quantum multiverse are the worlds that appear in the those are the worlds of metaphysical modality. So in a view like that, where physics actually turns out to be more fundamental than metaphysical modality, the physical world necessarily exists. It couldn't be caused to exist. right? Like, I mean, that's the metaphysical view that Wilson has defended in his book and in some papers, and that's why Wilson thinks that, for instance, causation is the sort of thing that applies within a universe and has a more fundamental explanation. I mean, he also takes up a view sort of similar to David Lewis's about how to reduce causal relations to more fundamental features of possible worlds. But in any case, the on a view like that, it's it's like the kind of response that Craig gave there is just completely inadequate. Craig needs to actually respond to the person he's responding to.
Alexander,
you're muted, Phil, if you're talking, I think, but
sorry, didn't ask for. We've got to unmute. So Craig conceded then, that there were many interpretations of quantum mechanics, and there's uncertainty as to what is the right one. And I think the analogy here would be, let's suppose we had a trial and someone brought handwriting evidence to the trial and said, look, that proves, something about where the person was or whatever. And then we found that all the experts disagreed as to whether handwriting analysis was even valid. Would you go with the evidence that was brought to the table? I think that you'd have to say no. So similarly, if we can't agree on whether quantum mechanics, of most fundamental theory of physics, it has causality in it, surely we shouldn't really be confident that everything has a cause, or everything that begins to exist has a cause.
Things, substances coming into being without a cause.
More from Alexander Verlinken.
In the Copenhagen interpretation, things are acausal simply because it's kind of built in the nature of interpretation. You have a wave function describing your atom, and then the wave function collapses in the course of measurement, resulting in some of the outcome probabilistically. And there is no cause how you choose these things. In the case of many worlds, this wave function describes an ensemble of universes. And in different members of the ensemble in different universes, you get all possible outcomes of your measurement. Simply, you don't know which universe you are in. And which universe you end up in is also an acausal kind of process.
Aha! So here he explicitly.
What's that? No, right. So explicitly, he wasn't relying on the Copenhagen interpretation, and Craig earlier said that he was.
Acknowledges his assumption of the Copenhagen interpretation, but notice that he doesn't provide any justification for thinking that.
Right. Oh, sorry, you're playing it back. Yeah.
Indeterminacy is ontic rather than merely epistemic.
And Daniel J. Linford makes an appearance in this next clip.
In defense.
Did you want to comment on that, Phil, or?
Well, it's just the same point. He basically said he's relying on the Copenhagen. He literally said the many worlds does not have causality in it. Alistair Wilson made the very same point, right? And then Craig says, aha, he's relying on Copenhagen. I mean, wow, it's as if he didn't hear what the people said.
So there's a few issues here, right? The fact that Craig, and in fact in some of his more recent presentations, actually says this explicitly. He retreats from everything that begins to exist has a cause, and instead says every substance that comes into being has a cause, which is one way to sort of get around this idea that, well, maybe quantum events are uncaused, because the idea is, well, those are events, right? But substances that come into being don't always require a cause. And as I sort of mentioned, the question is, well, is the universe, is like space and time a substance? That's a highly contested view. And Craig then would, I think he rejected that view. I could have sworn that I read he rejects that view, but I guess it doesn't matter. So the point is that he then would need to defend that particular view in order to establish that this substance idea about the beginning of the universe is sort of relevant. I
don't know.
So he's sort of boxing himself in more and more here, it seems.
I don't know if he thinks that space is a substance, but he does think that he does deny that time is a substance. So his view about time is a relational account of time where change suffices for the existence of time.
Of the argument's first premise, Craig makes use of de Broglie theory, also known as pilot wave theory. And in defense of the argument's second premise, Craig makes use of neo-Lorentzianism. Now, at least amongst physicists, both de Broglie theory and neo-Lorentzianism are considered to be fringe and disreputable. Therefore, although Craig might seem to be simply appealing to common sense or to mainstream science, Craig is actually appealing to theories that do not enjoy wide philosophical or scientific support.
Well, this isn't quite right. The de Broglie-Bohm pilot wave interpretation of quantum physics is simply an illustration of the fact that a mathematically consistent, and empirically adequate deterministic interpretation of quantum mechanics is available. It doesn't need to be the correct interpretation to serve that purpose. Although it must be said that this interpretation
is available. It doesn't need to be the correct interpretation. Just
Which
in
is the
terms of
opposite to what he
models
said before about models, right? Which others have advanced as counterexamples to what Craig. So Craig says, oh, the universe must have had the beginning, the BVG theorems and other things prove it. They say, well, what about these models? And Craig says, prove your models. But now when people say, well, causality is not fundamental, and Craig says, well, what about because of quantum mechanics? And Craig says, well, what about these models of quantum mechanics that don't that do establish causation as fundamental? The response that's consistent with what Craig says is for his interlocutor to say, prove that the Broglie theory is correct. But apparently, Craig doesn't need to do that. It just needs to be an option available. This seems inconsistent to me.
There are two things to be said here. One is that my actual point that I was trying to make is that the more controversial assumptions that Craig builds into his argument, the worse off his argument is. Right? I mean, I said that earlier that the an argument taken in of itself, independent, everything else being held equal, the conclusion of the argument is no more probable than the probability of the conjunction of the premises, and the probability of a conjunction is no more probable than the least probable conjunct. So if his argument builds on a whole bunch of really controversial assumptions, then that means that his conclusion is actually going to be only very weakly supported, if at all, by the premises in that argument. Now, the other thing to be said here is that notice that part of what he's doing here is the same sort of equivocation as I was talking before. He is saying that because we can find a deterministic interpretation of quantum mechanics, that suffices for showing that quantum mechanics doesn't provide a counterexample to his causal principle. Well, that's not true. I mean, even if we knew that quantum mechanics was deterministic, it might still be the case that quantum mechanics doesn't involve causation. I mean, so in 1912 or thereabouts, Bertrand Russell wrote a paper called On the Nature of Cause. I think that was the name of the paper. Anyway, Russell argues that Newtonian mechanics does not involve causation. Newtonian mechanics, at least as it was understood at that time, is completely deterministic, and yet there's a sensible way of talking about Newtonian mechanics, a sensible way of interpreting Newtonian mechanics, in which causation is absent from Newtonian mechanics. The other thing to be said here is that even if even if a particular physical theory or particular scientific theory has causation in there, that doesn't tell us that causation is fundamental. So on a view that I'm attracted to, causation is absent from fundamental physics, even though I think fundamental physics is deterministic. And yet, causation is required for the special sciences. On a view like the one that I endorse, the right way to think about this is that causation is a particular physical phenomenon that's reducible to yet more fundamental physical phenomenon. There's a lot of philosophers who endorse a view like that, and if any view like that is correct, then it's just not going to suffice to show that that the quantum mechanics has a deterministic interpretation. Like that's in many ways, on my own view, that's just irrelevant.
There's one other point I want to make. The whole thing in context is that the Kalam is being advertised as marketed as being sort of consistent with mainstream physics, and that's the point that Daniel made. But it isn't, right? And so he's sort of when he presents to an audience like the Hitchens-Craig debate with 5.6 million views, that is hidden from view. Now, there are other people, of course, that have minority views, right? Like Penrose, for example, his CCC model is a very minority view. It has radical assumptions that most physicists don't subscribe to. But Penrose is upfront about that. He never says, he doesn't try and pull the wool over your eyes and say, this is mainstream is with me. I'm a Nobel Prize winning physicist, so everyone agrees with me. He's very upfront. This is a radical conjecture that I'm making, and so there's nothing wrong with taking a minority view against the mainstream. What I think is wrong is when you hide that, and that's what Craig does do when he presents it to these very large audiences.
seems much more plausible than the Copenhagen interpretation, especially when it comes to cosmology, in light of the so-called measurement problem. As for a neo-Lorentzian interpretation of relativity theory, which enjoys the support of some very prominent physicists, I've already explained that the Kalam cosmological argument doesn't depend upon it. Rather, it's simply my preferred interpretation for explaining how God relates to time.
He said that neo-Lorentzianism enjoys the support of some very prominent physicists. Well, first of all, who are they? Second, when I published a paper, a very long paper, in the European Journal of Philosophy of Science on Craig's neo-Lorentzianism, one of the reviewers said in the referee report that the view that I was responding to was very unpopular, but that my paper was still interesting enough, and that Craig is prominent enough for it to warrant a response. I mean, I think, if you go into like a physics department and just ask people at random about neo-Lorentzianism, I almost guarantee people are going to have no idea what you're talking about.
Right. And also some could mean like 3 people. It's such a weak statement.
Well, he mentioned a few names earlier, which I'm not familiar with, but I mean, I don't really understand the relevance of this. So there's a larger number of eminent scholars who disagree with Craig here. So does the fact that some agree with him matter? Like, I don't. Does he have a consistent standard for appealing to expert opinion that he's going to then apply across his arguments? It seems that he doesn't, because he's just as happy to argue a very fringe case as to argue in the mainstream when that suits him. It doesn't seem to me that there's any consistent standard that Craig has for what relevance expert views has.
Yeah, and also I went to a conference on loop quantum gravity, and there must have been about 200 people there, and they, very large consensus that there's a bouncing universe there, which he thinks should be ruled out. And I could just say, well, some physicists don't rule it out. I mean, about 200 of them at least. I mean, that was just the ones at the conference. I mean, I don't know that they all subscribe to the bounce, but I mean, it's a very much a consensus position in that field. So again, inconsistent appeal to authority here.
Yeah, I mean,
in the videos.
But hang on. I traced down every physicist that I could that had written something on neo-Lorentzianism when I was writing that paper. For whatever reason, there was for a time a kind of cottage industry in Soviet Russia of people writing on neo-Lorentzianism. Craig has in some of Craig's books where he talks about neo-Lorentzianism, he cites some of that literature. There's one guy in particular named Prokofnik that Craig apparently consulted with when he was working on neo-Lorentzianism. But if I ask my physics friends, like, I have a very close friend of mine who's a theoretical physicist. I asked him, have you ever heard of Prokofnik? He was like, I have no idea who that is. It's just like, now, if you go back to the very early 20th century, you can find people who support this kind of view. I mean, you can find Lorenz, for example. And you can also find people today that support other conceptions of absolute time that are not neo-Lorentzian views. So you can find Bohmians, for instance, who support a kind of absolute time, but they don't endorse neo-Lorentzianism.
Interpretation for explaining how God relates to time. In the videos attempt to marginalize these theories, Kevin, what tends to get overlooked, I think, is the fact that they are scientifically unimpeachable.
And back to Valenkin.
If something could come from nothing, then why doesn't this happen all the time? Why don't tigers just appear in our living room?
In quantum mechanics, many things are possible that are not possible in classical physics. And indeed, you can have, in principle, you can have very strange things happening, like objects coming out of thin air. A lump of matter, in principle, it can turn into a tiger. And quantum mechanics will not tell you that this is absolutely impossible, but if you try to calculate the probability of this happening, it will be pretty low. If you think of the quantum creation of the universe, it is a tiny microscopic universe, right, that has to pop out of nothing. If you calculate the probability of this happening, I should say that conceptually this probability, interpreting this probability is a little difficult, but still, if you do the calculation, you find that it is far more probable than having a tiger materialize in front of you.
The low probability of such remarkable quantum physical transitions has nothing to do with the possibility of something's coming into being uncaused out of nothing. Something's popping into existence from nothing is not governed by physical probability. The idea of a probability of something's coming into being from nothing is meaningless, since there is no physics of non-being.
Next is
this is why I said before that Craig's conception of nothing is not the same as Vilenkin's, right? Because he's explicitly here and elsewhere identifying nothing as the absence of any physical laws or principles at all.
Right. And Vilenkin basically, his position is that the laws of physics have a sort of Platonic existence, that they can exist even when there's no universe to describe it. Now, that is a radical view. I don't want to say that it isn't, but it's a consistent view. And I don't see it's any more outrageous than saying an immaterial mind can exist without the universe. I think, in fact, I think it's better because at least we know the laws of physics exist in some sense. Exactly in what sense they exist is up for debate. They may have the Platonic existence of Vilenkin suggests, maybe they're just descriptions, but they exist in some sense. Whereas an immaterial mind, I don't think we have any strong evidence that that exists in any sense.
Look, even if you like on Vilenkin's view, the universal wave function is the thing that does all the fundamental explanatory work. And if you are not a Platonist about the laws of nature, but for instance, an Aristotelian, so if you think the laws of nature are grounded in the essences that things have, then you could just say the laws of nature are grounded in the essence of the universal wave function. And the universal wave function explains, on Vilenkin's view, how you could have a space-time come into existence with no pre-existing space-time. As Phil pointed out, that's basically what Craig wants out of creation ex nihilo. So I don't see what the problem is supposed to be.
Another clip from Arif Ahmed.
The argument that something can't come from nothing, or perhaps it'd be better to say something won't ever come into existence following nothing, isn't really confirmed by our everyday experience, because in our everyday experience, we don't ever experience a nothing and check it to see whether something can or can't come from it. So there's no argument at all, I think, on the basis of what we've observed in everyday life at all, to think that something can't come from nothing.
Such a reply is badly misconceived. The inductive evidence in support of the causal principle appeals to our observation of things that begin to exist and noting that there are causes for them. The Copenhagen interpretation of quantum mechanics claims to provide evidence for some exception to this inductive evidence. But as I say, that interpretation is highly disputable, and so it is not a proven counterexample to the inductive evidence.
In this next clip, they bring back
I just don't think he's replying to what Arif said. But the point is, if I look at my experience, I only ever see things coming from things where there's already something there. What we'd like to know is, what if there was nothing there, no physical reality? What would happen? We can't use our experience to inform us of that, because we've never experienced nothing there. And so any appeal to your experience is just invalid. And he hasn't replied to that at all. He started going on about the Copenhagen interpretation, which is really irrelevant to this point.
Right. And I want to emphasize again that, he's once more equivocating between something coming from nothing and the idea that things must have causes for their coming into existence. It could be the case that it's impossible for something to come out of nothing, and yet also the case that Craig's causal principle is false, or vice versa, right? Like, I mean, these just aren't, so this whole example of like the tiger coming into existence from nothing, for example, well, suppose that necessitarianism were true, but also that that causal determinism were false. In that case, everything that happens is necessitated to happen, and perhaps everything is necessitated by the laws of physics. And yet, because the laws of physics are what they are, you can't have tigers coming into existence out of nothing, even though you could have a whole universe such that when it, that the first segment of the universe's existence is not preceded by anything.
Yeah, again, as I said before, a lot of it comes down to Craig equivocating between not having a cause and coming out of nothing, and particularly popping into being out of nothing.
Right.
It isn't just quantum mechanics that divides thinkers about the nature of causality. Philosophers are equally unsure of its merits.
So causation is a classic philosophical topic in the sense that there's no agreement about it at all, and there hasn't been ever.
Oh, what he means is that there is no consensus concerning a philosophical analysis of causation. Either then an analysis can be successfully given or should be given. The metaphysical principle that out of nothing, nothing comes has been nearly unanimous in Western philosophy ever since Parmenides.
Here's the next clip.
Okay, pause it there. Pause it there. Parmenides was arguing that the universe has always existed. That's why he said, out of nothing, nothing comes. So it's very ironic for him to quote Parmenides. Then he starts to just assume what Alistair Wilson meant. But Alistair Wilson has made it clear that he doesn't think causality is fundamental. So, I mean, I don't know what the justification is for this. Oh, what he means is, I mean, the point that Wilson makes is causality is not fundamental. And then he says also that philosophers don't agree about it. So if physicists don't agree about causality and philosophers don't agree about causality, is it really okay for Craig to demand his causal principle?
You know, as far as principles that all philosophers have agreed upon, well, gee, I mean, I don't, I certainly don't think that the causal principle is one of them. I mean, you know, like maybe a principle like the principle of non-contradiction, though even there, I mean, Graham Priest apparently disagrees with that principle. I think, you know, like I was saying, that there's a cottage industry of philosophers who have historically disagreed with the causal principle. In fact, there's been several philosophers who disagree even with the notion that causation exists at all. But you know, just to pick out the same three famous names as before, Ernst Mach, Bertrand Russell, and John McTaggart all denied the causal principle.
Yeah, I think Arif's just about to talk about that, so we might want to let it play.
It's hard to see how it could have a cause. After all, we tend to think of causes happening
Oh no,
before their effects.
that out.
But if time began,
They've cut it out. Actually, the Arif went into all the different philosophical interpretations of causality, including eliminatism, including Russell's.
Right.
Yeah,
so
I just
there's-
don't. Oh, yeah, go ahead.
Right. Oh, well, so Russell's own view is a kind of a limitivism, according to which causation does not survive into sophisticated science, even though determinism does. There are people who, I call them neo-Russellianisms, other people call them neo-Russellians as well, who either take up Russell's position or take up a position that's not as strong as Russell's. So for instance, my own view is that causation isn't there at the level of fundamental physics, but it is in the special sciences. So for instance, we might need causal explanation in, say, psychology, but we don't need causal explanation at the most fundamental level. And
I think that's a key point, Daniel, because I mean, it seems obvious that causes exist in some sense, right? Like you take the vaccine and it causes you not to get the disease, but it doesn't follow from that it's fundamental. And I think what Craig's argument needs it to be fundamental, and it just doesn't follow that if we observe things in the world. I observe my computer in front of me. My computer is not fundamental, right? So just because I observe stuff, it doesn't follow that they're fundamental.
Yeah, that's right. And I think I mean, all these intuitions that we have about causation arise from our ordinary experience. They don't arrive from thinking about fundamental physical law. And it's, you know, it just really annoys me that people equivocate between these two different kinds of determinism all the time. You don't just see this in philosophy of religion, you see it in all kinds of places, that people, for whatever reason, they get confused between thinking that everything is determined and thinking that everything has a cause. But those are not the same view.
Just for clarification from my part, Daniel, how could things be determined non-causally? Like, what's an alternative model there?
Well, yeah, I mean, it might be that they are. So causation, one of the things to notice about causation is that causation is asymmetric. So causes determine their effects in a way that effects do not determine their causes. An alternative view might be that at the fundamental level, there are necessary connections, but those necessary connections are symmetric. And in fact, this was part of John McTaggart's argument against God's existence. So McTaggart thought that what there really are these symmetric relations. So there couldn't be something that is more fundamental than the universe. There couldn't be something that causally brings the universe about without the universe bringing that thing about, because the relation on McTaggart's view is symmetric. that's one kind of view that you could have, is that what there are fundamentally are symmetric relations where we don't recognize a causal direction. There's another kind of view that goes back to David Lewis, where so David Lewis has this view that what each metaphysically possible world is a distribution of properties across space-time, and it's by looking at how the properties covary across different space-times that we come to an idea about counterfactuals. So counterfactuals are going to be described in terms of how properties that covary across possible worlds, and then causation is going to be understood in terms of counterfactuals. So those are two different views about how causation might be reduced.
And with the universe, then there was no before. So how could God have caused it?
LOL. I thought that we were just told that there is no agreement on the nature of causation and that common sense cannot be trusted.
This next clip is an excerpt from you.
Right, hang on, pause it there. So what we're basically running with Craig's view is saying, well, if we follow our intuitions, it seems that causes have to be before their effects. I mean, not just, and that's not just our intuitions, that's also in standard physics. So one, it's not based on intuitions, but even if it was, then we can just say, okay, but your intuitions are going to undermine your argument as well.
Yeah, and you just ignored it, essentially, by saying, well, before you said the other thing. Well, yes, it is possible to entertain different possibilities and see that maybe they actually both undermine that the point that Craig is making.
Right,
Like,
exactly.
there's something inconsistent there.
Right.
I just don't understand why people think that causality is a temporal relationship. For example, philosophers talk all the time about cases of simultaneous causation, where the cause and effect occur at the same moment of time. Immanuel Kant gave the example of a heavy ball resting on a pillow, causing a depression in the pillow. Now, the ball and the pillow could have existed from eternity past.
This seems like the admission of something that's existed for a past eternity. So it may be that Craig, by using this example, is allowing, and he may not consistently be able to allow, that something's existed for a past eternity.
Kant's example is intended to be an illustration of simultaneous causation. Neither I nor many other philosophers see any reason to think that a cause has to be temporally prior to its effect. In fact, it's very difficult to see how it could be prior to, but not simultaneous with, its effect. If simultaneous causation is possible, then God's causing the universe to come into being is simultaneous with the universe's coming into being. What could be more obvious?
Here's more on.
So if we could pause here, like a few things to notice. First of all, some of the people who are speaking here, and maybe just Craig, are sort of misspeaking, because simultaneous, for two things to be simultaneous means that there's a temporal relation between them. Namely, it means that they occur at the same time, right? Like simultaneity is a temporal relation. Second, actually, I should also say about that first point that I think what they mean is not that there's not a point about temporal relationship, but rather a point about a particular kind of temporal relationship, right? So the issue is about whether or not causes need to temporally precede their effects. But here, the issue is going to be about, on the one hand, I think that relativity precludes the possibility that two things can be objectively simultaneous. And even if we take up a neo-Lorentzian view, according to which there are things that are objectively simultaneous, it's still going to be true that relativity is empirically adequate. And insofar as relativity is empirically adequate, it has to be the case that effects will need to precede their causes, or perhaps be after their causes. In other words, they can't be simultaneous with their causes, because if we had if we had an occurrence where you could observe an effect being objectively simultaneous with its cause, that would mean that you would have a signal propagating faster than light. And then the last point to make is
Dan, let me interrupt.
Yeah.
Let me interrupt 1 second.
Yeah.
And correct me if I'm wrong, and therefore you could send a signal back in time, which is not allowed on Craig's view of time.
Well, I mean, it depends, because so it gets messy, because you'd have a signal going faster than light, but whether or not it actually goes backwards in time depends upon how things look from like the one correct reference frame. right? I mean, what you'd be able to say is that there's some reference frame from which it appears that you sent things back in time. But since on Craig's view, there's only actually one correct reference frame, it would depend upon what things were like in that frame. And it may be that in that frame, the signal did not go back in time. And in any case, one of the things that, since Craig is an A theorist, it seems like on a view like A theory, you'd had better say that causes precede their effects, or at least are simultaneous with them. And since we've already ruled out the simultaneity option, it seems like causes would have to precede their effects.
On that in this next clip.
In physics literature, there is no such thing as simultaneous causation. So the notion of causality in physics always has a chronological nature, that basically the cause should precede the effect. And in this particular example of the ball and the pillow, if you just look at things as they are at one instance, then you cannot really make any statement about causality. But if you look at the history of what preceded what, basically you put the ball somewhere, and then its effect propagates with the speed of sound through the medium, and the pillow basically accordingly reacts to that.
Obviously, physical influences are propagated by finite velocity signals, but the effect will not come into being until the signal actually contacts the patient entity. That is, say, the recipient receives the signal. At any instant prior to that point, the signal could be intercepted and the effect would not be produced. In any case, divine causation is not mediated by the transition of physical signals.
And this clip from Alistair Wilson.
Right. So as usual, God doesn't have to obey any of these rules. So why are we even talking about them? Like, this is why I think God is a bad theory, because there seems to be very few, if any, constraints on what God can do or how it works.
I mean, it's not completely unconstrained. God has to be constrained by God's own nature, for example. I think it's a fair point that God doesn't act by signal propagation, because the usual way in which omnipotence is conceived is that God has causal influence or potential causal influence at every space-time point. And I suppose that on a view like that, what Craig could say is that because God acts at every space-time point, and every space-time point is trivially simultaneous with itself. But the only kind of objective simultaneity you get in relativity is that space-time points are trivially simultaneous with themselves. That in that sense, perhaps Craig's notion of simultaneous causation is compatible with relativity. At any rate, I think there's this broader point here, which is just that accounts of causation are sufficiently controversial among philosophers that it's not clear that there's going to be, whatever the correct account of causation turns out to be, it's not clear that it's an account that can save Craig's theology.
Makes sense when applied within the universe or within some part of the universe. I mean, if you ask how much something costs, some table or some chair, then that makes perfect sense and that's a good answer. If you ask how much the universe costs, that doesn't really make sense because you can't step outside the universe to buy it. It could be very similar with cause and effect. Cause and effect is something that operates inside the universe. So it just doesn't make sense to step outside the universe and ask what causes it. Cause and effect is something that happens within the universe, not to it.
I find this claim utterly implausible. The causal principle is a metaphysical principle which applies to reality as such. Namely, being does not arise from non-being. It is not a natural law like the laws of thermodynamics or the law of gravity, which apply only within the universe. I think that what we're seeing here is a subtle scientism that reduces everything to what science tells us and rejects any metaphysics that is not simply an extension of science. And do I need to say that such scientism is scientifically unprovable and nothing more than a philosophical prejudice?
So if we can pause here, like, Wilson's not a scientismist. I mean, he does believe in a project of naturalistic metaphysics in which we're going to look to scientific theory to try to develop our metaphysics. But that doesn't mean that he thinks that, I mean, it doesn't make him like a logical positivist or something. It doesn't mean that he thinks that the only things that we ought to believe in are those things that can be scientifically proven. You could engage in the project of naturalistic metaphysics and think, as Wilson does, that we can reduce modality to the universal wave function. That's a pretty wild metaphysical view, a lot of people would say. And yet it's one that's heavily influenced by science. The other thing to be said here is that, like, Craig has once again equivocated. He told us that the causal principle is the principle that being cannot come from non-being. That's not what the causal principle says. The causal principle says that everything that begins to exist must have a cause. It says nothing about whether being can come from non-being or whatever. I mean, that's just not what the causal principle is supposed to be about. To put this another way, one of the reasons why the Kalam argument is supposed to have an advantage over the contingency argument is precisely in that the causal principle is supposed to be a weaker principle than the principle of sufficient reason. But if we just make it into, like, another version of the principle of sufficient reason, then in fact the Kalam argument does not enjoy the kind of is not in fact better than the contingency argument.
Yeah,
Just
Craig.
jump right next to you. Well, very quick point. On Alistair Wilson's website, he describes himself as, "I'm a philosopher at the University of Birmingham working on metaphysics," and then various other things. So the idea that he just, is a scientist, a scientism, I mean, it's absurd.
Yeah, well, that just seems to be an ad hominem or a straw man of some sort. I don't even know where Craig gets that from, but because he certainly didn't say anything of that Craig just added that in. But the idea that, so Craig's saying here that, well, the causal principle is a metaphysical principle, so it's not something that's sort of reducible to any kind of physical law or within the universe. But that's just Craig's view. Like, that restating his position is not a defense of his position. Like, we know that Craig thinks that, but clearly, I mean, there are people who disagree with that. So what's Craig's argument?
And I think it's very reasonable. So I think it's very reasonable to suggest that there are reasons why there are causes. Maybe it's because there's an hour of time, or because there are laws of physics. Whereas Craig seems to just say, well, it's just there, like a magic thing.
Well, let's think about John McTaggart, right? So McTaggart, I mean, he was a British idealist. I don't know if you can, like, be more metaphysically inclined than the British idealists were. And yet McTaggart denied that causation was a real feature of the world at the level of fundamental metaphysics. So, it just, I don't know. It's weird to me the way that sometimes people treat scientism. It seems like it's a reply that sometimes gets thrown out when a metaphysician appeals to various scientific theories. But there's nothing inappropriate about a metaphysician looking to science to help them develop their metaphysics.
Brings up bouncing cosmology in this next clip.
We've seen that many cosmologists favor a bouncing cosmology, which may be eternal into the past. Others favor a universe that had a beginning from a spontaneous fluctuation. Another class of models suggests that solutions to Einstein's equations that allow time travel into the past, known as closed time-like curves, could enable the universe to create itself.
Our narrator has never met a cosmological model that she doesn't like, unless it involves a beginning. The question is not the existence.
Wow. Didn't we have a whole section talking about Vilenkin's tunneling from nothing model, which has a beginning? Didn't we just say there are models with a beginning and models without? And then it's like he just never even heard that.
Yeah, and they're kind of all relevant as long as they're sort of live options. If any of them are inconsistent with Craig's claim, then they kind of are all relevant, even if they're mutually consistent with each other, because they provide different options that are available that Craig kind of has to refute if he's going to substantiate his claim that the universe began to exist. So there's no inconsistency in appealing to multiple different models.
Right.
Of theoretical models. The question is their mathematical consistency and their empirical adequacy. There is no model that meets those conditions and is past eternal.
And they feature a clip from you in this.
Okay, just pause it there.
This is clearly impossible.
Hang on. So take, Luke quantum cosmology as an example. It's perfectly mathematically consistent as far as I can see. And they've made predictions for the CMB and they appear to be consistent with Planck data. So where's Craig's alternative that does that? And now again, I don't want to oversell it. They have to make some assumptions, and you can challenge those assumptions. There are certainly issues with the models, Again, I'm not trying to say, this is right, it's been empirically confirmed, but it certainly seems in better shape than anything Craig is suggesting.
For in order to create itself, the universe would have to already exist. It would have to exist before it existed, which is a self-contradiction.
It may be inconsistent for Craig to say that, on the one hand, causes do not have to precede their effects in time, but then on the other hand, dismissing the idea of a self-created universe on the basis that a self-created universe would have to precede itself in time.
Fair enough. But the point is that in order to bring itself into existence at t equals 0, the universe would have to already exist at t equals 0, if not before. I mean, seriously, is this now the alternative to theism?
More on a self-creating universe in this way.
Hang on. This is not... Well, first of all, it was very interesting that he actually conceded the point that Arif made. He said, fair enough. I mean, that's quite an important point. It's not supposed to be an alternative to theism. It's a proposal for the other universe that might or might not be right. And there's nothing wrong with making conjectures and seeing where they lead. It's not supposed to, everything, probably in Craig's mind, all cosmologists are conspiring to try and disprove the Kalam argument. I would suggest most cosmologists have never even...
He actually sort of says that at some points.
Sorry?
He actually says sort of similar things. He said something to the effect that, since the Big Bang was developed, then theorists have been trying to come up with all sorts of different... I think he sometimes says, like, desperately trying to come up with models that avoid absolute beginning, things like that. So he kind of edges towards saying something like
I
that.
just don't think that's what is going on in physicists' mind. They're not trying to do that. They're faced with puzzles about, why was the entropy low and blah, blah, blah. And they try and solve those puzzles. They come up with conjectures and various different models. The idea they're all trying to diffuse a Kalam cosmological argument is just absurd. My guess would be and it is a guess, fair enough, but most of them probably never even heard of the Kalam cosmological argument.
One of the really important things to point out about the history of Christian theology, so Aristotle, of course, was not a Christian theologian, but influenced many. Aristotle thought that the universe was necessarily past eternal, and the reason why Aristotle thought that was because Aristotle did an analysis of time on which every moment of time needs to be preceded by another moment of time and followed by a moment of time. So every moment of time is between two others. Therefore, according to Aristotle, past time needs to be infinite. Now, there were medieval theologians who adopted that view. It was eventually condemned by the Catholic Church as heretical, but there were debates in the medieval church about whether the Christian orthodoxy would require that the beginning of the universe was an event that took place at finite time in the past, or if God could have created the universe even if the universe were infinitely old. Now, in some early papers of Craig's, where he's responding to, for example, Stephen Hawking's Brief History of Time, he actually appeals to those debates and points out that even if the past history of the universe were infinite, there would still be reasons to endorse God as the creator of the universe. So it is sort of odd that at times he does exactly what you're describing, where he seems to think that anyone who rejects his particular thoughts about cosmology is necessarily an atheist. It's also worth pointing out that there's an evangelical Christian who's also a cosmologist named Don Page, and after the Craig Sean Carroll debate, Page wrote on Sean's blog affirming his agreement with Sean Carroll and disagreement with Craig, even though Don Page is an evangelical Christian.
There were also Christians who supported the steady state, and they quoted passages from the Bible saying, look, it supported the idea of continual creation. That God is the sustainer of the universe, I think was what they were quoting, saying, that's just like the steady state. And Craig has this quote, typically atheists thought the universe was eternal, as if to contrast with Christians. But typically everyone, in at least academic circles, physicists and so on, Newton thought the universe was eternal. Newton was not an atheist, right? So, it's just completely wrong to try and sort of say, this is the desperate attempts of atheists. I mean, lots of people have taken views opposite to Craig about the beginning of the universe who are believers.
Yeah, my personal view is definitely that supposing steady state were true, I'd consider that evidence in favor of theism, because I'd think that that's the sort of world that, you know, like a deity might make for, you know, beings like us to live in, that wasn't going to, you know, have some kind of weird heat death thing.
By the way, the other thing to point out here is that, you know, there's that a-theoretic interpretation of a bounds cosmology that I presented in one of my papers, in which the two universes to either side of the bounds are the simultaneous causes of each other. You know, that would be a model on which there didn't have to be something prior to the universe that, like, temporally prior to the universe that caused the universe to exist.
So a self-creating universe may appear to be a contradiction if you imagine a linear direction of time, because if you have some cause that leads to our universe, then that cause should precede the effect. But if you have a circular time, then there's really no notion of cause and effect, and because of that, there is no contradiction, because basically all you have is a consistency condition between what happens at one era and what happens at a prior era or future era, because they all just lead to each other. And as long as those consistencies hold, there is no contradiction.
Whoa, I thought that my espousal of Bohmian quantum mechanics and neo-Lorentzian relativity was untenable because such theories were fringe and disreputable. But this, C. Jim Sinclair's discussion of the Lee-Gott model featuring closed time-like loops in the Blackwell Companion to Natural Theology. For my part, I reject such models as metaphysically impossible because on a tensed theory of time, according to which temporal becoming is real, the universe would have to come into existence from nothing, since at the time of its origin, its future states in no sense exist.
Here's what the
okay, just pause there a sec. So let's take some of these things. So first off, he's pointing out supposed inconsistency, that we criticize him for appealing to fringe views like neo-Lorentzianism, but then we espouse, you know, closed time-like curves, and so there's a deep inconsistency there. But the difference is that we don't rely on these. We're not saying these things are right. We never say that the universe did have a closed time-like curve or is a closed time-like curve. The reason we pointed that out is that the statement that if the universe had to create itself is absurd. What we're basically saying is, well, it's not necessarily absurd. There could be a way it could happen. There's no point where we say this is what happened. Yet, Craig does say that neo-Lorentzianism is true, right? So these are not equivalent at all. Now, then he refers to his argument in the Blackwell Companion. Again, what he does there is he basically just quotes criticisms of Gott and Lee model, like let's say take by William Hiscock. And William Hiscock basically tried to argue that the vacuum state in the Gott and Lee model was unstable. But, you know, we interviewed Gott and he basically replied to that saying it's not unstable. And there's a disagreement there. And so, of course, Craig just quotes the critic and apparently that's the end of the matter, but that's not the end of the matter. There's another model that we just showed a screenshot of, and that Nihaya Afshori is an author of, the periodic time cosmology model, and Craig has never responded to that. Now, don't forget, at the beginning of the video, he said there's nothing new here, but he's never replied to the periodic time cosmology, he never mentioned it, so that undermines that claim too.
Narrator says in this next clip.
In order to assert the universe must have been created by an agent with free will, Craig uses an argument from the medieval philosopher Al-Ghazali, which asserts the universe must have arisen spontaneously, and the only example of spontaneous action is that of a free agent, something we supposedly know from our everyday experience of the world.
Well, not exactly. The point, rather, is that the only way to get a temporal effect with a beginning from a permanent, changeless cause is if that cause is a personal agent, endowed with freedom of the will, and so able to produce an effect without any antecedent determining conditions.
Here's more from Alistair Wilson.
I mean, I think the fact that well, so first of all, libertarian free will is deeply controversial philosophically, of course, but supposing, I mean, it's even controversial among Christians, whether it's true or not, but supposing that there were libertarian free will, the fact that you could have this kind of agent causation without determining conditions prior to it, that actually suggests that that's true more generally. Like, why would it be limited just to agents? I mean, he needs another argument here that says that that's the only thing that could do that, but he's never provided an argument like that.
Yeah, well, his usual approach is just to say it's either if it's not a physical cause, then it's either an abstract object or it's an immaterial agent, as I'm sure you know. And he says, well, abstract objects can't cause anything, so it's got to be like a libertarian agent. But I think that he's really suffering from a lack of imagination here, as if there's just sort of no other possibilities of any type of process that could bring about these sorts of causes, apart from a libertarian agent.
And I would also add that Vilenkin's view is that, laws of physics, or maybe you might say the universal wave function, is the sort of ultimate reason for the universe. You could argue that that is an abstract object. So when he says, "Oh, abstract objects don't cause anything because number 4 doesn't cause anything," yeah, sure, number 4 doesn't cause anything. But if the laws of physics do have this Platonic existence, I think arguably you could say they're abstract objects, and therefore they are a candidate for the sort of uncaused cause.
What about the idea here of agent causation sort of creating something out of nothing as well? I mean, I tend not to use supposing, agent causation is, a good analysis of what kind of happens when I choose to move my hand or whatever. I can't sort of volition my will to create stuff out of nothing. I mean, why suppose that's even a candidate?
Right. I mean, it's also important that if he is going to equivocate between his causal principle and some version of the principle sufficient reason, it's important to note that the principle sufficient reason and libertarian free will are not themselves compatible. So, he needs his causal principle to be distinct from the principle sufficient reason in order for God to have libertarian free will.
Without any antecedent determining conditions.
Here's more from Alistair Wilson.
I mean, I think it's a pretty good argument. It's just that the premises we no longer tend to accept. The modern conception of the world, the standard view of quantum physics is that it's not deterministic after all, that most interpretations of quantum mechanics have some indeterminism in them. And the most popular approach to understanding free action tends to be compatibilist. It sees free action as compatible with the laws of physics, indeed enabled by the action of the laws of physics. So Al-Ghazali's argument was pretty good, given the assumptions he was making. It's just that I don't think we now have any reason to accept those assumptions.
Here we come back to the point quoted earlier from Aguirre and Casillas, that a quantum state can't endure changelessly from eternity and then suddenly produce a new effect a finite time ago. So quantum indeterminacy won't do the trick here. Notice too that Wilson's understanding of compatibilism is mistaken or idiosyncratic. Compatibilism is the view that freedom is compatible with your being completely determined in everything that you do.
Here's Arif Ahmad.
I don't think that's right. I think Daniel, you correct me if I'm wrong. I understand compatibilism is that free will is compatible with the laws of physics, and the laws of physics may or may not be deterministic. Have I got that right? Or
That's not quite right. So compatibilism is the view that there's no incompatibility between free will and determinism, either kind of determinism, either causal determinism or nomological determinism. And now that doesn't tell us in itself whether you could endorse compatibilism and also think that the world is indeterministic. In fact, I mean, in some sense, if compatibilism is just the view that free will and determinism are compatible, then you couldn't. I guess, I mean, people don't usually take up the following view, but you could take up the view that your will is indeterministic, but that you would still be free even if that weren't the case.
But this issue of him referring to Casillas and Aguirre, saying, well, that rules out what Wilson says, I don't see how it does. I mean, the point is that you can have something that can behave in a way that has the properties of what Craig calls free will, right?
Right. Yeah, I don't see what I'm not clear exactly on what Craig's point is either.
Yeah.
Next clip.
if you're in the game of appealing to everyday observations, then there's all kinds of things you can say that would be unhelpful to the Kalam argument. For instance, we observe that every event has been preceded by another event, but clearly the Kalam argument can't allow for that. We observe that everything that comes into existence has a material cause if it has a cause at all, but again, the Kalam argument can't allow for that. We observe that all agency, for instance, all intelligent agency, is material, but again, the Kalam argument can't allow for such things. So everyday experience furnishes all kinds of generalizations that are inconsistent with the conclusion of the Kalam argument, and it's just arbitrary to choose the generalizations that you like from everyday experience and ignore the ones that don't fit with your conclusion.
I deny that we observe that every event is preceded by another event, or that every intelligent cause is material. The principle that everything that comes into existence has a material cause, if it has a cause at all, is indeed powerfully supported by inductive evidence. But it gets defeated by the evidence for the beginning of the universe, which cannot have a material cause.
Bill, we have...
Or is it the opposite, that the arguments for beginning get defeated by the principle that everything needs a material cause? You know, I mean, it's exactly, he's complaining about this accusation of him cherry picking, but we just listened to him apparently do that. So, you know,
Yeah, I agree, and I don't quite understand this. What Craig says that he denies that every event is preceded by another event. Sorry, he denies that we observe that every event is preceded by another event. I'm not exactly sure if what he has in mind here is the counterexample. Well, even our free choices are preceded by other events, right? So that's not a claim about causation,
right? And they're preceded by necessary conditions, right? Like, in order for me to exercise my free will, I need to exist, for example. So it's, you know, it's not as though that there are no necessary conditions at all that go into an exercise of free will. Rather, it's that whatever conditions there are that bring about me making one choice as opposed to another do not determine the choice that I make.
Yeah. And so on that basis, I assumed he was just talking about the first event, the beginning of the universe, which I assume would be the only event that Craig would think was not preceded
if
by
he's
another
talking
event.
about observation, I guess there's like the first event that you observe in your lifetime.
Well, I don't know. It depends how you define observation as opposed to like an individual, as opposed to, I don't know, collectively as humanity. He said we observe that, but I guess the point is, if he is referring to the origin of the first event that began the universe, that would be a bit question begging, since that's sort of the point he's trying to establish. But certainly every other event that almost all events are preceded by another event. And plausibly, the idea would be that, well, maybe there's something special about events that aren't preceded by other events, such that maybe all events that are preceded by other events require a cause, but maybe those that aren't don't. And I think that's sort of the fundamental point here, that there seems to be a clear difference between things that we observe within the universe and within time and the very beginnings of time, such that we should be skeptical about making an induction there.
Well, and I want to press on this too, because it doesn't make any sense to say that we observe the beginning of the universe. I mean, what you might say is that we have astronomical observations that, when placed in conjunction with a powerful or independently well-supported physical theory, entail that the universe had a beginning. But the beginning itself is unobservable. So
yeah,
and this is a very important point, because Craig will often say, the beginning is confirmed by remarkable discoveries in astronomy and astrophysics. But all the observations tell you is that the universe was in a hot, dense state. It doesn't tell you what came before the hot, dense state. And there's no observations whatsoever that can tell you anything that happened before that state. I mean, you could say inflation has got observational confirmation. That's controversial. But certainly, even if you went with that, there's certainly no consensus that there's any observational confirmation of anything that happened before inflation.
That's a good point, but it's a slightly different one from the one that I was making. Even if we supposed that general relativity was our final theory of space-time, that was like if God revealed to us that general relativity was the end-all be-all of space-time theories, so that we could take our astronomical observations, join them with general relativity, and suppose that by whatever miracle we had enough astronomical observations that we could infer that there was a beginning. Even then, we're not, you might be able to say as a definitive fact then that there was a beginning, but what you wouldn't be able to do is you still wouldn't be able to observe it. I mean, there's no such thing as observing the beginning of the universe. That's just not a thing that can take place, regardless of how much data you have or what physical theories you have available to you or whatever. Instead, what always has to be the case is that we have some body of observations and some physical theory, and it's the two conjoined together that at best would allow you to say that likely there was a beginning. I mean, compare it to the beginning of the Earth, right? Like, we have evidence that the Earth began, and we take it as established scientific fact that the Earth began like 4.5 billion years ago or whatever it was. But no one says that we observe the beginning of the Earth, right? Like, that's not part of geology as it's currently practiced, or planetary science, or whatever.
Yeah, so I think this all raises the question as to what Craig is referring to when he says that he denies that we observe that every event has a prior event.
Right.
We come to the last clip, and this is how the narrator summarizes everything.
To summarize, the Kalam cosmological argument is based on an outdated view of mathematics and an outdated view of physics. Mathematicians don't deny infinity, and physicists no longer believe the Big Bang is the beginning. The argument assumes our everyday experience of causality must hold true, even when there is no space or time, but then claims an immaterial mind made the universe from nothing, which is completely contrary to our everyday experience. In short, the Kalam cosmological argument is unsound.
Oh, please. The first philosophical argument for the beginning of the universe is based on modern Cantorian set theory. It argues that if there were an actually infinite number of things, then various metaphysical absurdities would ensue. In contrast to intuitionistic mathematics, the argument does not deny the mathematical legitimacy of the concept of the actual infinite, but rather employs it. The second philosophical argument...
Pause there. Yeah, I just want to recap. I want to say, oh, please. Clearly, Craig said mathematicians think actual infinities lead to contradictions. He said it. He's repeated it on several occasions. It's in his video. So this is basically just the point we made earlier. We're accusing him of saying P and not P, and he's defending himself by saying, I sometimes say not P. That doesn't, there's no way that that's a defense against the allegation of the contradiction that we said.
He also said there are various metaphysical absurdities, which, you know, it's still not clear when he says absurd whether he means, you know, it's metaphysically impossible for something to happen, or he kind of finds it absurd, but it could be metaphysically possible.
And he conceded that the border between what is metaphysically impossible and not possible was hard to define, right? So that just makes it this incredibly weak argument.
Is rooted in a tensed theory of time, which I have defended at length in my published work. As for the two scientific confirmations of the beginning of the universe, from the expansion of the universe and from the thermodynamic properties of the universe, it's just laughable to think that an argument appealing to cutting-edge work in astrophysical cosmology and constantly updated in light of it is based upon outdated physics. Many contemporary scientists do believe in the beginning of the universe, even as they explore models aimed at falsifying that prediction.
Okay, just pause that. Many. What does many mean here? 2, 3? I mean, it really is absurd, because he's basically relied on Penrose-Hawking theorem, then the BGB theorem, and neither of those prove a beginning, right? Then he relied on the argument from thermodynamics. That doesn't prove a beginning either. And I think if you speak to most cosmologists, and I've had the privilege of interviewing most of the leading cosmologists, well, I should say most, a lot of the leading cosmologists that work in early universe cosmology, and, you know, their views are totally different from Craig's. Like, I think you would struggle to find anyone that agrees with Craig.
Yes, and with respect to Craig's claim that it's absurd to say that his arguments, which are based on and appeal to current cosmology and are constantly updated, are out of date, I think it's entirely reasonable if Craig consistently misrepresents and makes false claims on the basis of those theories that he appeals to, just like the ones that you mentioned. So, I mean, that's how I would square the circle there. So, well, yes, Craig does appeal to recent developments, but very frequently he does not accurately represent what these theorems tell us, or these results tell us.
The video's producer doesn't seem to understand that the universe is having a beginning doesn't imply that it begins to exist at a singularity as it does in the standard model. Finally, the causal premise of the argument is based on...
Pause there a sec. Now, notice he said, as it does in the standard model. But when he does these debates, he basically tells you the standard model has a beginning. Where does he get that from? Right? You know, if you go on an astronomy course, cosmology course and they talk about the beginning, they'll appeal to the singularity theorems. So yes, I agree that there could be a beginning without the singularity theorems, but he's used those as his evidence for a beginning. And if you take those away, yes, it's not impossible you could still have a beginning, but what's the, where's the evidence that it does? He hasn't provided it.
And moreover, I mean, there was something very important about the development of the singularity results, in that you mentioned earlier, Phil, that many people before the development of relativity took the universe to be past eternal.
Yeah.
There's a fairly decent reason for that. I mean, suppose that yesterday the world was created ex nihilo, all of our memories intact, and so on. That's a skeptical scenario that people often discuss. And it's if you suppose that the universe began, if you truncate the universe's history in some arbitrary place, then you introduce this kind of skeptical scenario. But if you instead, the nice feature of singularities in general relativity is that the open boundaries that they give us are places where at least in the classic Big Bang model, that open boundary is accompanied by the pressure, density, and temperature being arbitrarily high. It's a special time in the universe's history. It's not just truncating at some arbitrary location. It's not the sort of thing that would introduce a skeptical worry. So if he wants to get rid of that idea, if he wants to divorce himself from general relativistic cosmology, then he has to tell us what he's going to do with this kind of skeptical worry.
A singularity as it does in the standard model. Finally, the causal premise of the argument is based on both metaphysical arguments and inductive evidence. It is in accord with, but is not simply based on common sense. And so I think the video's conclusion is vastly overdrawn. To sum up, Kevin, I want to say I'm genuinely grateful to the many scientists and philosophers who took the time to be interviewed for this video. This sort of vigorous debate can only raise the visibility and the influence of the Kalam cosmological argument. Unfortunately, it's very clear.
You should stop there. You should have stopped there. I think what Craig says at the very last minute or so here is well, we'll just play it and you can make up your own mind.
By the producers in advance. What we observe in this video is not an objective piece of investigative journalism, but rather a polemical piece consisting of mutually inconsistent, often irrelevant, and increasingly desperate objections aimed at undercutting the Kalam cosmological argument. There's no genuine interest here displayed at all in learning whether and or how the universe began to exist. All that matters is perceiving loopholes. And as the video proceeds, increasingly bizarre and implausible scenarios are suggested for avoiding the beginning of the universe without any attempt at all at their evaluation. When we finally get to the point that in order to avoid the argument's conclusion, we're advised to believe instead in circular causation or spontaneous generation ex nihilo, then I think we know what the desperation is really all about, namely avoiding theism at all costs.
Okay, well, just pause there. I just want to, obviously there's a lot of points to make, but I just want to refer to that particular point because, I mean, Craig just not done his homework here. The most famous version of the closed time-like curve model is by Gott and Lee. Richard Gott, just look it up. He's a believer in God. He describes himself as a Presbyterian. He believes in God. So basically, Craig's saying, well, he's just invented this as a desperate attempt to avoid theism. He's a theist, right? Gödel also was a theist. He also believed in closed time-like curves, not necessarily as the origin of the universe. So it's just wrong. I mean, you just can't be more wrong about this. And as we said, this idea that, oh my God, this is a polemical film, well, yes, it is. I make no apology about that. He makes polemical films. Why can't we?
Well, the real reason Craig is rejecting, these objections to his argument, the real reason is his deep down fear of atheism.
Yeah, I know. Sometimes people have critiqued me for saying that I don't think Craig is always intellectually honest. And but they get upset about that. But then Craig, and this is not the first time Craig makes claims like this. I've said before that he often characterizes things as a battle between like theists or Christians and those who are trying to disprove it, scientists desperate to avoid theism. He just said it right there. He said it before. And so Craig says these things fairly regularly. And to me, I just don't sort of see, well, why is he allowed to get away with that? And somehow his supporters don't seem to mind. But then when other people, like a lot of scholars don't like to cast aspersions on academics like Craig, but popularizers like me don't necessarily mind as much, right? But when we do it, it's like, oh, you're so horrible. You know, you're focusing on the person, not the argument. It's like, well, you can talk about both, right? But I think Craig is, if he wants to put himself above that, then he shouldn't do this, right? I just feel it's really inconsistent.
I was just gonna say, this whole idea that people have to be like afraid of God to reject the Kalam argument ignores three really important things. First of all, the Kalam argument itself, if we just take the first stage of the Kalam argument, does not mention God, and one could accept that argument and still be an atheist. But the other thing that it ignores is the fact that some of the most famous people to have rejected the Kalam argument were theists. Thomas Aquinas famously rejected the Kalam argument, as did Richard Swinburne. At least, Richard Swinburne rejects the a priori version of the Kalam argument. I mean, is Craig going to tell us that, like, Thomas Aquinas is afraid to accept God's existence? Like, that just seems very strange to me.
Also, there's something that Richard Gott said when we interviewed him. When we asked him, how can you justify that there was a closed time-like curve at the origin of inflation? And he said, well, something funny had to happen at the Big Bang. And I think that is a popular view. Something weird did happen at the Big Bang. And so when he says, oh my God, we're asked to believe all these weird things. Well, yeah, but something weird happened at the Big Bang. Craig believes that an immaterial mind created the universe. Right, that is also something weird happening, right? So he cannot point to these other things and say, "Well, that's something weird happening."
I mean, look, when Laplace proposed the nebular hypothesis for the origins of the Earth and the solar system, people were famously quite skeptical because there was this expectation that you would need God to create the Earth and the solar system. Well, today, mainstream geologists and planetary scientists, regardless of their religious beliefs, accept the nebular hypothesis. I mean, everyone. You can find creationists out there, but they're not taken seriously in the scientific community. Those Christians who are taken seriously in the scientific community are Christians who accept the nebular hypothesis. So it's sort of, there's something analogous here with the history of the physical universe, that you can propose that there are these catastrophic events in the history of the observable universe that have nothing to do with the beginning, without having to say anything one way or another about theism.
Also, I should add that one of the philosophers in this film believes in God. I asked him, could you say that on camera? And he said, I'd rather not. But he's one of the main philosophers in this film, and he believes in God, but he thinks the Kalam argument is terrible. So again, this is a completely invalid point.
I brought up the fact that that Thomas Aquinas rejected the Kalam argument. There are still Thomists around today, and many Thomists who are around today reject the Kalam argument for the same reasons that Thomas Aquinas did.
There's a really good Catholic YouTuber, I've forgotten his name. You guys know his name? He did a debate with Craig, right? And he's a Catholic. And he said the Kalam. Sorry?
Trent Horn, is that who you're thinking of?
No. He's opposed to the Kalam argument. I forgot his name. He's a Catholic philosopher. And he debated Craig on the Kalam. He said the Kalam is a bad argument. It shouldn't be used by theists. And so Craig knows this. So it's really disingenuous for him to say this.
I'm trying to figure out who it was now. Not Bishop Barron.
No.
No.
I've got it. I've got a note about it somewhere. Hang on. I can probably find it.
Yeah, my reading is that Craig says these sorts of things
Jimmy
about.
Aiken. Jimmy Aiken is his name.
Ah, right. Yeah.
Craig says these things about everyone's trying to desperately avoid God for basically consumption of his Christian audience. Because I mean, he doesn't even try to defend that. And as you pointed out, that there are numerous current examples that he knows about. So why would he say this? I think it's sort of a rhetorical flourish that goes over well with his core audience. I assume that's why he says it.
And consider too the fact that Craig has said that the Kalam argument is not the reason that he believes in God. He would still believe in God to keep up the Kalam argument. And like I said earlier, like many hours ago now, I think the Kalam argument is interesting in its own right, quite apart from whether God exists. I have a paragraph early on in my dissertation where I just say, look, I think there's a really interesting research program here, and it raises a series of really interesting questions, really interesting philosophical questions, really interesting scientific questions, and those questions are worth exploring regardless of whatever theological views one might have.
Yes, and that's the irony of Craig criticizing the documentary makers about not really caring about honest pursuit of truth, which is that Craig never really claims to be doing that. Craig is very clear. I quote him numerous times in my book where he says, look, the reason he believes is because of his own subjective experience, the witness of the Holy Spirit. The arguments come after that. If the arguments were proven wrong, he would still believe. And that the reason he advocates for these positions is to help other people consolidate in their faith and or bring new people to the faith. And I mean, Craig is at liberty to do that if he wants to, but I think it's very hypocritical of him to criticize other people for having their own agendas, essentially, that are more than purely just finding out what is true, when he's very explicit about that's not even what he's doing.
Especially the last minute or two, the kind of accusations levied against the documentary in terms of cherry picking contradictory views and things like that. And when you look at the kind of bits of science that Craig will use to kind of support his view and the way that they might either contradict other philosophical positions that he's taking, things like that, he's just doing the exact same thing that he accused you guys of doing with the documentary. So.
Right, and also we do present contradictory views, but we don't rely on them. That's the whole point. So we did say the universe might not have a beginning. We explore models where it doesn't have a beginning, and then we say, but what if it did? And we explore those models that have a beginning. There's nothing wrong with that because the whole point is we don't know, so we explore all the options.
Right.
He wants
I think
to say, no, you've got to be consistent.
He expects your video to
We don't know.
He expects your video to have a monolithic voice or something, and it's like. One of the things that's nice about your video is that even though, all the people that you talk to are skeptical of the Kalam argument, you represent a plurality of perspectives on this topic.
Right. Yeah, we've got people that think the universe always existed, and we've got, Vilenkin arguing that it didn't, and we have him doing that, So there's nothing wrong with that because we don't know whether the universe had a beginning or not. So it's good to keep our options open, and that's my point. I mean, I remember I was on a podcast and they said, what if you were proven wrong and it turned out the universe did have a beginning? And really, it's just a misplaced question because that wouldn't prove me wrong. The point is we don't know right now.
Then we look at premise 2.
Right. Well, I don't know if there's anything useful in this last. I'll just play it a bit
4-part
and
series
see.
on this rather extensive video. I want to remind everyone that they can
Yeah,
get
it's
more.
just promotion stuff.
Oh, I'll just say one thing. I'll just say one last thing. He did a 4-part series replying to our video. Daniel, has he replied to any of your papers?
No.
We put a paper out criticizing him on animal suffering because there was a big controversy where he said animals didn't suffer. We did a YouTube video replying. He did a YouTube video replying to us, and there was a lot of back and forth. He never replied. He has never even mentioned our. We've got a paper published in a very leading journal. Daniel's had papers published in English, not replied. And yet he'll say, "Well, I won't quote. I won't debate," because someone's tried to arrange a leading podcast host tried to arrange a debate between me and Bill Craig, and he said, "No, I'm not going to debate popularizers." But yet he'll do 4-part YouTube video replying. Right, but he won't reply to Daniel in print. He wouldn't. He hasn't engaged in our published papers on
Also
animal
hasn't
suffering.
responded to Alex Malpass's papers or to Wes Morrison's more recent papers.
Right. So that I think that tells you that Craig's strength is in popularizing arguments, right? And so there's what's wrong with us making a popular reply to his popular argument.
Well, he also does talk to popularizers when it suits him. So he's talked to Cosmic Skeptic, for example.
Yeah.
I think they called it a discussion rather than a debate to get around that restriction. But it's, yeah. You just need like 300K subscribers on YouTube or however many he has.
Right.
Right.
Anyway,
Are there any?
it's very late. I should close this out.
Yeah, I was going to say final thoughts.
We've been going for almost 6 hours.
Final thoughts on the kind of 4-part review, if there are any, or have
I think we've said everything.
Yeah, I was actually disappointed. I wasn't expecting a lot, but it was kind of worse than I thought. The number of times he just sort of, Craig just kind of avoided the criticism, didn't actually answer the question or respond directly to what was said and just says something else, or just says, "Oh, read my book." He said that so many times actually, and or actually just make some kind of ad hominem or straw man attack. There was quite a few of those as well, especially we saw at the end. There are a few points where I think that he had a fair. Craig had a fair response, but those were few and far between. Yeah, it's actually surprising to me that Craig even made this response because, as was just said, he ignores lots of other things. And yeah, I don't know. I wasn't happy, not surprisingly.
The one thing I think I am maybe happy about is that this is the 7th podcast that he's made replying to my material, which I think is a record for a YouTuber. I might be wrong. Anyone knows more, let me know.
Right.
I'm quite happy that he did write a response. I think that it was, I think it's important that he brought his followers into this discussion, and hopefully some of them will see this video. And I think this is an important conversation that needs to be taking place, not just in academia, but also in the public square.
Great. Well, thank you everyone for coming on and doing this episode. It's been a long one. I think the next episode in this like Bad Apologetics series that James and I do is the Apologetics Industrial Complex, which will be like in a month's time or something, when we figure out a time for that one. And I think a lot of people have been looking forward to that. Yeah. So
thanks a lot, Nathan. Appreciate being on.
Yeah, thanks. I'll end the stream there.
Thanks, guys.